Hello everyone. In this lecture, we'll be learning about the datetime module. This datetime module is a very important module and we'll be using it all throughout the data science journey. So it's a fairly short module, but quite an important one. Let's understand what are there to learn. So first, we learn about the datetime module. The most important thing that we need to remember over here is the format of the representation. So it's in a year, then month and date format. So 4 characters of the year. Let's say today's, let's take a random date of, let's say 25th December, right? 2020. Let's take this particular example. So how do we represent that? The first 4 characters should be that of year. Therefore, 2020, right? Followed by a dash, then the month, which is in this case 12, because December is the 12th month. Followed by the date, which is 25. So this basically represents the 25th December of the year 2020. Now the datetime module is used to work with dates as well as time. So we'll see 2 types in this particular module. The first is the date module. Next is the time module. And there is something also called as the datetime module, which is a combination of both date and time. So yeah, here we come. The date module, the time module, the datetime module, and there's another thing called as the time delta class, which is used to find the difference between a particular given date and some delta dates forward or backward. All right. So how does this work? The date class. And why do I say class? Because it's fairly a module inscribed in a class format, as we have already learned about the OOPS. So since the internal working is the form of a class, we'll be calling it as the date class. You can call it as the date module itself. So there's not much of a difference. All right. So there are basically 3 mandatory attributes for a date class. The first one is the year. Next comes the month, and next the day. The range of year is max year to min year. So it can be anything from the maximum year given and the minimum year. However, the month has some limitations, 1 to 12, because January to December, that's how it rolls. And for day, it should be 1 to the number of days in a given month. It can be as less as 28 for February, or 29 for leap years, and 30 or 31, whatever it is for that given month. One quick note, do not put any wrong day. For example, we know that February has usually 28 days, or in special cases 29 days. So if you however put, let's say any year, let's say 2020, which, okay, let's say 2000, right? And let's say February, that is 02. And let's say you want to put 30, it would simply give you an error because there is no such date present, right? So that was all about the date class. Now coming to the time class, it has 4 attributes: the hour, minutes, second, as well as the microsecond. So none of them are mandatory fields. These are optionals. And it has been clearly mentioned as well, all the arguments are optional. Now coming to the datetime class, which is a combination of both date and time. It has 3 mandatory attributes: the year, month, and the day, and 4 optional: hour, minute, second, and microsecond. Now coming to the time delta class, it is used to calculate the differences in dates. So we'll see everything via the lab session. So here we come to the datetime module. as already mentioned, the same things have been given over here. Now let's come to the date class. What it does is, so there are essentially 3 attributes as already mentioned. Let's give a particular date. So we can also give the date in the format of year, month, followed by date. We can do that. Or we can use this particular format wherein I have taken a variable, my date equals to, date is the name of the module. So what we do before that is we import from datetime, import date. So we have already imported the date module. Now what we do is date followed by the name of the attributes. So here I have taken 2023, month I have taken to be 2 and day 7th, which essentially means the 7th of February, 2nd of Feb of the year 2023. So that's what exactly I have done. Now, since this date has been inscribed or populated in the myDate variable, now when I call date, so what I do is, when I need to find the exact date, what I do, I print my date. So I've written date is my date, so it gives me the date 2023 2nd 07. This is the exact format that we have got, year, month and day. Now when I want to take only, when I want to extract the year only, what I do is my date, which is the variable containing the exact date, dot year. So it would only extract 2023 out of this particular date, and that's what exactly it has done. When I want to extract the month, I write my date dot month and I get the month, which is 2nd. And similarly for day, I write my date dot day and I get 7th. So this is exactly how it works. Pretty easy. Now coming to the time class. As mentioned before, it has 4 attributes: the hour, minutes, seconds, and microseconds. So all are optional. I've taken a again from datetime, import time. I have to import this particular time module. There it was date. From datetime, import date. And here I have imported time. Now I've taken a variable, my time, equals to time. Hour equals to this, minute equals to this, and second is equal to 45. So now when I write my time, I get 12:30:45. That is 12 hours, 30 minutes, and 45 seconds. Right? I could have also included the microsecond part. Now, here what I do is, time is my time, so I got the time. When I want to extract the hour part, I do my time dot hour. Similarly for minutes, my time dot minutes, and for seconds, my time dot seconds. And for microsecond, what we do is my time dot microsecond. Since no microsecond has been mentioned yet, so it's taking 0 to be the default one, which is essentially the case. It's 12:30:45 with 0 microseconds. This is how we use the time class. Now let's move to the datetime class, which is again a combination of the 2. So what we essentially do here is, we take from datetime, import datetime. Now I've taken a variable x equals to datetime, and now what I need to do is, I need to give all the 3 for date, that is year, month and day, right? Year, month and day. These 3 are the attributes for the date class. Now for the time class, there are 4 attributes, which are hour, minute, second, and microsecond, right? And as we know that these 3 are mandatory, all these 4 are optional. So what I've done is, I've taken all the 7 into account. So year is equal to 2023, month is equal to 2, day equals to 7, hour equals to 12, minute equals to 30, second is equal to 45, and microsecond is equal to 30. And now when I print X, which is essentially the entire thing, what I get is 2023 to 7. That is in the form of year, right? Month, day, followed by the hour, right? Followed by the minute, followed by second, followed by microsecond. This symbol means micro. So this is exactly what they have given me, right? Now what if we want the live date, that is today's date? What we do over here is, we use the module datetime.now, and this datetime.now gives me the current date. So let's try it out. So this gave me an error. Why? Because I have not imported it. So now what I need to do is import the same, and now it gives me the current date and time. So today is 2023, the month is 4, that is April, and the day is 8th of April 2023. The time currently is 14, that is 2 o'clock, 38 minutes, 25 seconds, followed by a microsecond of 8,04,077.86. Now, if you want to extract the year, you do it today.year, today.month. Again, today is just the variable. You can write it whatever you want. Now, you can do it just that also. So, you can extract it the way we have done previously. The most important thing to remember over here is, for getting the present date, you do datetime.now. That is what we do. Now coming to the time delta class. So let's say you want to find a date ahead of you, or let's say some days before. What was the exact date? So for that, what you do is, you import the time delta class. I've also imported the date time. Now what we do is, today equals to datetime.now. So we get today's date. Now what we need to do here is, we want to find what was the exact date 3 months before, and next 3 months after, what would be the date. So what I've done over here is, date before 3 months equals to today minus time delta days is equal to 90, because 3 months is 90 days. Similarly, 3 months after is today plus time delta days is equal to 90. And now when I print them, I get the exact same thing. As I said, now is April, that is the 4th of month, which we can get it over here. So 3 months before was Jan, that is 1, and 3 months after it would be the 7th month, right? That is exactly how it rolls. So that was all about the time delta module, which is pretty important. The next chapter that we will learn is the RegEx module, the regular expressions. So this is again very important, and it would again be a quick session, post which we'll be moving to the important libraries such as NumPy and Pandas. Okay, so that was all for today. Bye guys. Hello everyone. In this lecture, we'll be learning about the regular expressions, or RegEx as we call it. So what are RegEx? Regular expressions or RegEx is a sequence of characters that forms a search pattern. It can be used to check if a string contains a specified search pattern, right? So how do we do that? We'll be learning then shortly in the lab session. So there are basically 4 functions: the find all, search, split, and sum. What does find all do? It basically returns a list containing all the matches inside the find all command. We'll see how we use them. Search is quite similar to find all. However, it matches the object that we are required to find and tells the span of that particular object. Span means the start to end. Let's say there is a line called, let's say there is something called as hello. Hello, okay. So if we search for EL or ELL, it would say the span is from 1 to 2, 3, right? 0, 1, 2, 3. So that is how the search gives you the result. Now, what is the work of split? Split is quite simple. It splits the characters wherever necessary, wherever you have marked. It's quite simple and quite same to that we have already learned. And what is sub? Sub is the short form for substitute. It substitutes any value that you would want to place over a given, or instead of a given word, or let's say letter or character. So it basically substitutes, replaces one or more matches with the text of your choice. So that's quite all the functions of RegEx. Now what we can also do using RegEx is the usage of meta characters, which is typically the most important part of RegEx. So the meta characters are the building blocks of the regular expressions. What we do here is, there are actually a lot to learn about the meta characters, but some of the things that we generally use has been listed over here. And for beginners or for even intermediate level, you should not go beyond all these things. Again, that said, there are pretty more things to learn for the meta characters, but that would come with time and experience. So let's not overburden ourselves by learning more. Almost all the projects or intermediate level handling of data science projects can be done using all these meta characters. So first is the square bracket, which specifies a set of characters we wish to match. So basically inside the square bracket, whatever is written, let's say A, it would actually match with the given text and tell us if this exists or not. You can also give a range over here. We'll see everything. What does period do? It matches any character other than the new line character. Caret is for the start function and dollar is for the ending function. Not function, but for the starting character and ending character. For star, it matches 0 or more occurrences, and for plus, it matches 1 or more occurrences. And the second bracket is used to specify the number of occurrences you want to match. So let's move to the lab session and understand what we have seen over here. So as I said, there are basically 4 functions. First is the find all function. It returns a list containing all the matches, and if no matches are found, an empty list is returned. So what we need to do at the beginning is, we need to import the RegEx module, and that is named as RE. So import RE. Now whatever we do is using RE dot the functions, right? So I've given a text saying the rain in Spain. Now what I'm trying to do is x equals to RE dot find all AI comma text. So AI is what we are to find and text is from where do we find. So this finds the required text from the given text, right? So now when I'm printing X, I'm getting AI and AI. Why? So AI for rain and AI for Spain. Got it? What if I thought of checking out for I only? We get 3 I's. The first I is for rain, the second I is for in, and the third I is for Spain. So that is how the find all function works. What if I give any word? So mind it, for find all, you can give characters as well as words. No problem. So what if we match any word that is not present over here? That is Portugal. It gives me a blank list containing nothing. That's what we have mentioned over here. If no matches are found, an empty list is returned. Now coming to the next parameter, that is search. What it does is, as I said, it returns a match object if there is, so it returns a match object if there is a match anywhere in the string. If there is more than one match, only the first occurrence of the match will be returned. So if there are more matches, unlike find all, it returns only the first match. And if no matches are found, none is returned. So I'm giving the same text, x equals to re.search. Again, remember you have to import the RE module. Since I've already imported, no need to import again. So re.search AI comma text. And now when I'm printing X, for search, it is giving me the span for the first one. That is 0, 1, 2, 3, 4, 5, 6. So what it means is span has been given as 5 and 7. So what it means is fifth element and all the elements up to 7 minus 1th element. That is 5 and 6th element. That's what exactly it is, rain. Now what if we actually removed rain? Then we get the span is 10 to 12. So 1, 2, 3, 4. I have given too many spaces over here. Let's correct the spaces. Right. Now it's saying 9 to 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9. It should be, okay, I've counted it wrong because it should be 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Right? Then A is 9 and I is 10. And 11 minus 1, that is 10 elements up to 10th element. So that is what is giving me match is equal to AI. So for AI, the span is from 9 to 11. And when I'm giving Portugal, it's showing me none because it was not present over here. So what does split do? Split returns a list where the string has been split and its syntax is quite similar. Max number of split that you want is optional. So what I've done over here is I've given the text the rain in Spain re.split AI from text. So every time it comes across AI, it would split. So that's what it has done. The R split it for AI, then N in SP, then again split it for AI and N. What if I wanted to split only once? Then I have to give AI comma text and limit the number of times I want the split to happen. So the exact syntax is re.split, split element, the element that I want to split, AI over here, text, the text from which I want to split, and the max number of elements. So it has only splitted once. The R, AI has been splitted, and then in Spain. So that's how the split works in RegEx. So when you want to split the white characters, the white space characters, what you do is you use the, so this is not the correct symbol. You use the / followed by S. So text is same, the rain in Spain. And what I wanted to do is split all the white space characters. So that I get all the words. So that's what I have done. re.split, the / S followed by text, and I'm getting the rain in Spain, all the words. Last, the substitute character, it replaces one or many matches with the text of your choice. So the same text has been given, and I needed to fill in the the white space. So what I do is / S followed by 9. So instead of the space in, it would show the 9 rain, the followed by 9 in 9 Spain. Because what I'm doing is this was the text written, the rain in Spain. And what I'm doing is I'm removing this white spaces and substituting them with 9. Therefore, the result that I'm getting is the 9 rain, 9 in 9 Spain. That is exactly what we have got over here. So I hope you understand how do we use the functions in RegEx. In the next lecture, we'll understand how do we use the meta characters as well. So hope to see you in the next lecture. Hello everyone. In this lecture, we'll be learning about the meta characters in RegEx. So as we know that meta characters are the building blocks, and the 5 important meta characters that we'll be learning over here are the use of square brackets, period, caret, dollar, and the symbols such as star, plus, and second bracket. So let's understand one by one. So first important thing that we need to know here is how do you use the square bracket. So it basically specifies a set of characters that we wish to match. Let's set for an example, we want to match AR or N. Therefore, what we do over here is we use the second bracket and write ARN. And now what it does is it returns a match where one of the specified characters of either A or R or N is present. Now, what if we actually wanted from a range, instead of writing A, R, and N, let's say we wanted all the characters from A to N. In that case, what we do is A, N. And then it would do the same thing. It would actually find all the characters in the given text. Again, note that here both A and N are inclusive. That is, we use both A and N as well. Now, what if you want to find all the characters except A, R, and N? Simply put a caret sign over here. Then it would match all the characters except A, R, and N. Typically what is mentioned over here. Now, what if you want to, check for all the alphabets. So for that, it's a general idea. We do A to Z. But what if we come across something called as Spain? S is capital. So S won't be mapped over here. Therefore, what we also need to do is, now everything would be mapped. Same goes for the numbers. We can do it for 0, 1, 2, 3. We can use it for 0 to 9. Then everything would be matched. Let's say we have 2-digit number. Let's say from 0 to 99. Then what we do is 0 to 9 followed by 0 to 9. If there is 3-digit number, then we do the same. That is how we roll. For this 0 to 5 and 0 to 9, all the digits from 00 to 59 could be mapped. Why 59? Because the first thing is 00. So I'll just put over here 0 to 9 followed by 5, 0 to 9. Oh, sorry, the first one was 0 to 5 to 0 to 9. The first number would be 00 up to 5, right? Followed by 9. Therefore, 0 to 59 is what we get. Next comes the plus symbol. So for plus, it returns a match for any plus character in the string. So we can also include any symbols. Let's say @ multiplication, plus, anything, or backslash, anything. So whatever you put inside the bracket is what it matches. So let's understand them through proper programs. So what I've done is imported the RE module. Then I've taken the same text, the reference pen. X is equal to find all A to E. What it does, it finds all the variables, all the characters from A to E. That is A, B, C, D, and E. So that's what it's doing. The E comes here, so E has been put. After that, rain, A is the one that should be matched. Then in, nothing has been matched. Spain, A is matched. And therefore, we get the output as EAA. So that is how the square bracket works. This was quite a simple example, but I've explained everything in detail. How can you use everything, and that is how we will be using going forward in our course. Now, what does period do? The period basically matches any characters except a new line. All right. So what a period does is it matches all the characters except a new line. So when I write the text India and we want to find the dot, it gives me the output as all the characters because no dots has been found, because there is no new line in it. So that is how the period command rolls. Now for caret, what we do is it checks if the given is the starting of the element. So let's say text is given India and I write re.findAll I. So it would give me the output I. What if I change the text? Let's say I write AI, A India. It gives me an error. Okay, I'm sorry. So I need to import. So it gives me a blank. Why a blank? Because the starting character is not I. Now it gives me the correct thing. Now, while using the caret function, I can go on entirely how much I want. Let's say here I have written I. What if I had written IND? It would have given me the same thing. Because IND is also the starting, right? It not necessarily takes the first character. It can take the entire thing as well, India. It can do it as well, no problem. But remember, the sequence of the characters should be correct and the starting should be as given. So it can take from I to IN to IND to INDI or to INDIA. That's how it is done. The exact opposite of caret is $. It checks if the particular character ends with it. So for India, it ends with A and same is here given. What if I wanted, IA? It gives me the same because yes, it ends with IA. What if I wrote India? It would still be giving me, I'm sorry, I have mistaken the spelling. It would still be giving me the output because yes, it starts with India, it ends with India, no problem. What if I had written ends with I? So no, it does not end with I. That's what it gives me, right? So that is exactly how the caret and $ works. Now coming to the star, plus, and the second bracket operator. So let's understand this through examples. So the text I have taken here is H, HA, HAA, and HAAA. Now when I'm using the star operator, it would print everything H followed by 0 or more A. Let's see what I'm doing. I'm doing re.findAll HA star. So what it does, let me grab the pen and make you understand. So what it does over here is HA star. So HA star, what it means is HA should be there followed by 0 or more of A, right? Since it's 0 or more A, it would also take into account H. Therefore, 0A. HA, that is 1A, and many more to go. What plus does is, it takes into account 1 or more A. So what happens over here is, H would not be printed. It prints from HA because at least one A has to be there. So let's see the solutions that's given. So print for star, it has printed all H, HA, HAA, HAAA. But for plus, right? For plus, it has printed HA. It has omitted this particular thing and printed all the rest. Why? Because star prints from 0 to infinite A. But for plus, it prints from 1 to plus infinite A. And followed by the second bracket. Here we declare how many do we want. So since I have written HA2, so at least 2A should be there. Therefore, it omits HA as well. It takes into account HAA and then HAAA. But even for HAAA, it has taken 2A into account. Why? Because it would only take the number of characters specified, and that's what it has exactly done, HAA, HAA. It has not taken the one where A is less than AA. So this is how star, plus, and second bracket works. And by this, we mark the end of our RegEx module. Next, we'll be starting with the long-awaited NumPy module. All right. So hope to see you in the next lecture. Bye, guys. Hi, everyone. In this lecture, we'll be learning about NumPy. So num in NumPy stands for numerical and py stands for Python. So together, NumPy becomes numerical Python. Or the reverse way true, numerical Python becomes NumPy. So NumPy is basically a library used extensively for computation in the field of data science. Let us see what NumPy has to offer. All right. So before learning NumPy, let us take an analogy with list. it definitely has some similarities and differences with list. And that is the reason we will be understanding them explicitly so that we get a test of how to use NumPy. Now, first similarity is between the representation. Both list and NumPy are represented in the same fashion. Printing any elements from a NumPy array as well as list is same. That is, if you want to print let's say if you want to print the second element of a list, what we do is li of 1, right? Same is done by a NumPy array. Replacing elements is also of the same manner. Now, the actual differences come in the fact that, let's say when you want to add to list, let's say there are two lists, li1 is equal to 1, 2 and li2 equals to 3, 4. So when how do we get this particular list? 4, 6. If we do li1 plus li2, right? What do we get? Do we get 4, 6? No, we get a concatenated list. Both the lists are concatenated. But for NumPy, if we do li1 plus li2, we get this particular list. This is because in the field of computation and calculation, mathematics, statistics, data science, we generally do not need a concatenated list. We need the addition of the index-wise addition. And that is the reason NumPy is computed in such a way. Same goes for vector multiplication. It does the single multiplication. That is 1 into 3 plus, not plus, comma, 2 into 4. And various other mathematical operations can be performed in NumPy, which list does not support. So before going any further, let us see all these things through some examples in the lab session, right? So let us move there. So what I've done over here is I've taken two lists, x and y. X containing 1, 2, 3, 4, y containing 5, 6, 7, 8. Now, how do we convert them to a NumPy list? So there are basically 3-4 ways of creating a NumPy array. The most basic thing that I'm going to share over here is creating list, converting list into an array. We'll be learning the different methods as well. But for now, let's understand this particular part. So what I do over here is I call the NumPy array, import NumPy as np. Now np has an inbuilt function called array. So what I do is np.array, right? What I do is np.array followed by the list that I want to convert into an array. So that's exactly what I've done, np.array of x. And now x array is the NumPy array for the list 1, 2, 3, 4. Let us see the differences in representation. So what I need to do over here is, we all know how x should look. This is the exact thing that we wanted and we are getting. Now x array, that is the NumPy array, is looking like this. So basically it's a list embedded inside an array function. But if we print it, instead of just giving the output, we see it as a list without the commas. So nothing to worry, both of these two things are exactly same. This is how an array is represented. All right. So now let's understand how do we print elements. Now for list, as we know, we do x of 2 to get the first element. Same is the way of getting the second element out of a NumPy array, x of r of 2, and we are getting 3. If you want to replace an element, here I have replaced the first, or the second element. So for list, we know x of 1 equals to 100, and that's how we get the second element 2 is replaced to 100. Same for NumPy, 1 is replaced to 100, and that is exactly what we are getting over here. So this 2 is replaced by 100. So all these were the similarities between NumPy and list. Now what if we want to learn the differences? So I've taken the same list, an array, x and y, and x add and y add. Now, what do we, if we want to have a vector addition? As I mentioned over the slide, we simply do x add plus y add, which I have named as z add. So I'm getting, so x add, so x add basically was 1, 2, 3, 4, and y add was 5, 6, 7, 8, without the commas obviously. So 5, 6, 7, 8. Now z add is nothing but x add plus y add, which gives me the addition. 5 plus 1 is 6, 2 plus 6 is 8, 3 plus 7 is 10, and 4 plus 8 is 12. That is exactly what I'm getting, right? Now in case I added x and y, x plus y, I would have got this particular concatenated list. Now there is, again, as I said, there is a way to create this particular list out of this two lists by using the zip function that we have already learned. So what I do over here is I create a blank list and I create a loop ij in zip x of y z.append I plus j. I hope you remember how we used to do that. So in that case, we are still getting this particular factor. But don't you think that's quite a complicated process? And that is the reason NumPy has this innate quality in it. Now another feature of NumPy is, let's say you want to just add a scalar with a NumPy array. What you do is, so what I've done, I've taken in NumPy array 4, 6. So p equals to 4, 6. What if I want to get another array with 1 increased in it? What I do is p plus 1. That's it. And I get the array 5, 7. Or 5, 7, whatever you want to call it. That is what I get. So I hope addition was clear to you. The same theory follows for multiplication, the exact same theory. Instead of addition, I have used the multiplication term, and same for list. You need to zip it if you want to get the same output. That's quite about vector multiplication. Now, one important thing, you can use vector addition, vector multiplication, vector division, and everything by just using the arithmetic operator as desired. All right. Now, one very important thing is the dot product. So people belonging from science background must know what is a dot product, right? And we'll be using dot product extensively while doing feature engineering and everything. So NumPy has this function called np.dot, and you give the two required arrays, let's say A1 and A2, and it finds the dot product for you directly. Now, if you want to ask how do we compute a dot product for people, for a quick revision if you want. So let's say P1 is a NumPy array containing 1, 2, and P2 is another NumPy array containing 3, 4. That's what we have done over here. Now np.dot P1, P2 would give me 3 into 1, that is how dot product is computed. 3 into 1. So 3 plus 2 into 4. That is 8, which gives me 11. So 11 is the dot product. And that is exactly what we are getting over here. So I hope the dot product concept is clear to you. Had you forgotten the same? And the analogy between a list and a NumPy is also clear. Now in the next lecture, we'll be learning and understanding NumPy in depth. So hope to see you in the next lecture. Hello everyone. Welcome to this lecture in which we'll be learning NumPy in depth. So NumPy, as we all know, stands for numerical library, Python. Now NumPy in context with list are about 3 to 10 times faster and are more memory efficient. Now, since NumPy is always used as a computing library, therefore its speed and memory efficiency is highly considered, where NumPy does the justice. The reason why NumPy are so much faster as well as memory efficient is because it uses, unlike list, it uses contiguous blocks of memory. And all the elements are of the same data type. Therefore, there is no type checking and the runtime. It is also integrated using the C language, which is known for its speed, unlike Python, and therefore NumPy is so much faster. Now it also includes built-in code-saving mathematical functions that can be performed with a single line of code. Therefore, no need to do the hard coding. It already includes those libraries which you can just import and perform your computations. NumPy is also known as ND arrays. The reason being, it contains n-dimensional arrays. What do I mean by that? So as we know, a point is a one-dimensional element, right? A rectangle, for example, or a square is a two-dimensional element. When I change a rectangle to a cuboid, it becomes a 3D element, right? So this was a 1D element. This is a 2D element. This is a 3D element. Now, human perception can only see and understand 3D, not anything more than that. Now, there are certain ambiguity related to this. Let us not go there. But definitely, there is a limitations to the dimensions that human can perceive. But NumPy can go well beyond that and create up to n dimensions, where n can be any number. And this is one reason that our journey in data science becomes so much easier using NumPy. All right. So how do we create a NumPy array? There are basically numerous ways to instantiate a NumPy array. The first one we have already seen. We can have a list called li containing several values, let's say 1, 2, and 3. What we do is we create an array li arr, or let's say just a equals to np.array followed by the name of the list. This would create a NumPy array. Next is the uses of aRange function. Another method is to use the linspace, all of which we are going to see over there in the lab session. So these are some of the typical ways by which we can create NumPy arrays. Now, NumPy has certain attributes. The type attribute, so the type attribute, dtype, The type attribute basically tells which class it falls in. The D type tells the data type of the NumPy values, whether it is an integer or string, as well as the number of bits that it can hold. The size tells the number of items. Shape attribute tells us the dimensions, that is row or column, how many rows and columns. And ndim is the attribute that we use to understand the dimensions that are present. Definitely, using the shape attribute, we can know the dimensions, but ndim is again created to know the dimension directly. Now, some important matrices that will undergo in a NumPy array are the zeros, ones, I, and transpose. What are they? So, zeros basically create a matrix with all elements 0. You just need to define the size or the dimension, size and dimension, and you get a matrix with all elements as zeros. As the name says or suggests, ones give a matrix full of 1. What is I? I is an identity matrix. If you know what an identity matrix is, this is basically an identity matrix. That is, it has 1 all over its diagonal. If you want to create a 3x3 matrix, this is how an identity matrix looks like. So this is, again, So write ones along the diagonals and fill the rest with the zeros. This is what an identity matrix is. And you can create that using the I function. What is a transpose matrix? It changes the rows to columns and the columns to rows. For example, let's say there is a matrix called 1, 2, 3 and 4, 5, 6. The transpose of it would be 1, 2, 3, 4, 5, 6. That is interchanging of rows to columns and vice versa. So these were some important metrics in NumPy. There are some special functions as well, each of which we'll be learning. Reshape, it helps to reshape the particular NumPy array. Let's say you had a 2-dimensional array. Let us see in the lab session itself to get a better understanding of the same. Swap access is just swapping the x and y axis, and flatten is used to change any dimensional array into a single dimension, that is 1 dimension. We also have the random functions in NumPy. The random.rand generates numbers between 0 and 1. 1 is not inclusive, that is, it can take 0 up to any digit up to 1, but not 1. 0.99999, anything, but not 1. And random.rand int generates only integers in a random fashion. Now, there are certain operations that we also use in NumPy. Sorting of a NumPy array, finding the sum, performing mathematical operations and statistical operations. And we can also use the function of masking using NumPy. So let us check each and everything one by one. All right. So let us see the different ways how we create a matrix or a NumPy array. So the first method is, as I said, we use the function .array and include a list in it. And voila, it changes into a NumPy array, right? What I've essentially done is np.array followed by a list of items. And that made it change to a NumPy array. It is not a list anymore. Now the next option is the aRange function. It has three attributes: the start, stop, and the step. So what it does is np.aRange followed by the start. Here I've taken 1, followed by stop, that is it would go up to 10, and step is the jump that it would make. So what would happen is it would first take 1 and then compute up to 10 or any digit less than equal to 10. The next digit it would find is jumping to 4 places. Therefore 1 plus 4 gives us 5. The next it would take is 9. The next it would take is 13, and so on. But since we have already made 10 as the dead end, it cannot take 13, and therefore this is where it stops, 159. And this is exactly what we get. So aRange has these three parameters: start, stop, and step. Similar to aRange, we have the linspace. But linspace also take three parameters which are a bit different. So first is the start. Let us put the same thing, 1. And then we have the stop, 10 here. And then the number of items you want, not the jump. So let's say I want 4 items. So it would automatically create a NumPy array with first item as 1 and the last item as 10. And since I want 4 items, so here it would take 2 spaces because the total number of items should be 4. And it would equally distribute all the items. So 1, 4, and 7. If you see, all the items are equally distributed. 1 plus 3 is 4, 4 plus 3 is 7, 7 plus 3 is 10. That is how it does. So I hope the 3 methods of creating a NumPy array is well clear now. Let us move to the next part, which is the different attributes. So as I said, so A, as we know, is the NumPy array containing 1, 2, 3, 4. Now when I print the type of A, what we get is class NumPy.ndArray. So it is the type of this particular array, NumPy.ndArray. Now what is the data type? We get it by A.dtype. So all the data are integers, and that is the reason we get int 32. Now when we want to get the size of the array, we know that it contains 4 digits, right? So the size is 4. What is the shape? For shape we do a.shape, and the shape is 4, nothing has been mentioned because it's a single dimensional array. Had it been a 2-dimensional array, we would have got it 4, 2. What is the dimension? A.ndi, and we get dimension as 1. Also understand, as I said, the shape says the number of elements in the rows and then the columns. Since it has only 1 row, it is not giving any more digit. Now we can also create ND arrays, arrays of different dimensions. So how do they look? So when I'm creating a 1D array and printing them, I get this as the output. How do we create a 2D array? Each row or each dimensional elements should be included within a third bracket. So this can be changed to a 2D by including the first dimension, the different dimensions inside different square brackets. That is exactly what I have done over here. 1, 2, and 4 would be in one dimension, and the next 5, 6, and 8 is taken in the next. And therefore, we get a 2D array like this. For 3D array, the same process continues. You just keep on putting more and more brackets to get the different dimensions. And this is exactly how a 3D array looks. Now coming to the next part, how do we access different elements from a NumPy array? Now accessing elements in a list was pretty simple. And it is as simple in a NumPy array if we have a one-dimensional array, right? What if we have a multi-dimensional array? For a single dimensional array, a of 2 would give me 6. We know that. What if this was the array and we needed to get a certain particular element? How it works is, so if you see the particular matrix over here is 11, 12, 13, 21, 22, 23, 31, 32, and 33. Now let's start accessing elements. Now when we want to access, let's say 23, what we do is, we first move to the row, the index of the row. We know this is the first row. Therefore, what we do is, this is basically A, right? So what we do is A of 1. Followed by the column name, which over here is 2. And this gives me 23. That is this particular point. If you see this is the first row, A of 1 and 2, followed by the column name, we get this particular element. And that is exactly what we get over here. A of 1, 2 is 23. What if you want to get a range of elements? What do we do then? So for you to get both 11 and 12, what we do is, so this was A. What we will be doing is A of 0 to begin with. So we have come to this particular row. Now the columns that we need are 0 and 1, right? So what we do is 0 to 2. Remember, this would be n minus 1. So 2 minus 1, that is 1. So it takes both 0 and 1. Therefore, we get 11 and 12 as the output. So this is exactly how we access elements from a NumPy array for multi-dimensional arrays. Now, a quick note, if you wanted to, let's say, take the values 21 and 31, what would have been your code? So it would have been A, 1 to 3, followed by 0. That would have given me 21 and 31. All right. Moving to the next part, which is A range. Now, yes, we have got a fair idea about A range, but let's understand the extra features that it entails. So what it does is, it returns an evenly spaced element as per the interval. Syntax is start, stop, step, and dtype. Basically, amongst these 4 attributes, only stop is a compulsion. The rest are all optional. So what if I write np.arange of 4? It would give me an array containing 0 to 4, 0 to 3 and minus 1. And that is exactly what it has given me. Now, what if I take 2 elements? It would take them to be start and stop. So exactly that has happened. np.arange 4, 10. And it gives me all the elements from 4 to 10 minus 1, that is 9. And step is what we do to get the jumps. And here I have taken the jump to be 3. Therefore, 4 after the 3 jumps, that is 7. And after that 3 jumps, that is 10. Since 10 is out of the range, therefore 4 and 7 is the answer. We can also take another optional element called dtype, which helps us to give the data type of this particular NumPy array. Let's say you only want all the data to be of integer type. Then you write int 32 or int 64, whatever you want. So that is how arange typically works. Now coming to the linspace, as we have already learned, it does the same thing. np.linspace, this is the start, this is the stop, and this is the exact number of items we want to take. Alright. Now, moving to the different types of matrix that we have. So what it happens is, I've taken a zeros matrix of 2 elements. So it will give me a linear matrix, one dimensional, having all the items as 0. Let's say we want a matrix of 2 dimensional with all 0. Then what we do is np.zeros 2, 2. It gives me a 2-dimensional array. Same is the thing that occurs for ones. Only instead of zeros, we write ones. And we get the matrix with 1. For I, that is identity matrix. So the simple thing that we do is np.I 2, 2 for a 2-dimensional array. We can simply use this for a 3-dimensional array as well. So as I said, all the diagonal elements are 1. We can also use a 4 cross 4. And we can do it for n cross n as well. The only diagonal elements would be 1 and the rest 0. Now what about a transpose matrix? A transpose of a matrix. So we have this particular given matrix. And to transpose it, we do A dot T. A was the given matrix, this. So this was the given matrix, and we do A dot T, and we get this. The rows 1, 2, 3 has been converted to columns, and 4, 5, 6 has been converted in a longitudinal manner, 4, 5, 6. So this was all about transpose of a matrix. Now coming to the reshape, swap, access, and flatten functions. So I've taken a normal matrix, one-dimensional matrix from -9 to -3, and that is the output that I'm getting. Now if I want to reshape it into a 2 cross 3 matrix, that is, this is exactly a 2 cross 3 matrix. 2 rows and 3 columns. So what if I want to create this into a 2 cross 3 matrix? What it does is it takes the first 3 elements in the first row, next 3 elements in the next row. And that is exactly what we get. We can reshape into any type what we want whatsoever. In the next step, we have done a swap access. That is, it is as simple as using the transpose. The rows becomes columns and columns becomes rows. So when I did b.swap access 0 to 1, that is 0 became 1 and 1 became 0. So exactly the rows became columns, 987, 654 became 654 like this. And now when I want to flatten is converting any dimensional array to one-dimensional array. So when I did flatten, this c.flatten, this matrix to be flattened, it created the initial matrix, the one-dimensional matrix. So I hope reshape, swap access, and flatten functions were as clear as well. But this is something that I'm only making you understand what are the functionalities that we can do. Understand and have this particular knowledge. We'll be using each and everything while doing our Capstone project. And in real life scenario also, he'll get a pretty good test of how they're used in practical real life. So he'll get all those tests while performing the Capstone project. Don't you worry. Now coming to the random functions. As I said, random.rand gives you all the values from 0 to 1. All the values from 0 to 1, excluding 1. So this is something you should know. When I write 0 to 1, it means all the values from 0 to 1, including 0 and 1. And when I write this, it means all the values from 0 to 1, excluding 0 and 1. And when I write like this, it means all the values from 0 to 1, excluding 1. Or if I reverse it, it means all the values from 0 to 1, excluding 0. That is how it works. Now for random function, what I have done is, I've taken np.random.rand2, and it takes two values between 0 and 1. Now I have also used a two-dimensional array 2, 3. It takes a 2D array with 3 elements in each row, which are ranging from 0 to 1. Now for random.randint, it does the same thing, only taking all the integers. So what I've done is 10, 99. If you see, there is a bit difference. For random.randint, I can take the starting and ending element as well. That is, I can specify from the starting position and the ending position that your random values should limit from 10 to 99. It should not bypass that particular range. And how many values do I want? 4. So that's what it has given me. 86, 33, 83 and 68. And when I'm changing the side to 2, 3, it's giving me a two-dimensional array with the same dimensions. So this was all about the basics functions that we see in NumPy. Now, in the next lecture, we'll delve into the different operations that NumPy has to offer. Hello everyone. In this lecture, we'll be learning about the different functions that NumPy has to offer. So starting with the most basic function, that is sorting. Unlike list, NumPy can sort based on rows as well as columns. That is quite evident because lists are always one-dimensional, while NumPy can be multiple dimensional. So the basic operation that we use is, we have created a particular NumPy array 1, 4, 3, 2, 1, 5. Right? What if we want to sort it based on the columns itself? So the function that we use over here is np.sort, right? Followed by the name of the NumPy array. So here what we'll do is A, and that would actually sort the column, the full NumPy array. Now when you want to explicitly decide to sort it based on the columns, what you do is A, comma, and give the axis number. For column, it is 0. So what happens then is, you get this particular NumPy array sorted based on axis. So between 1 and 2, 1 is smaller, so it gets sorted like this. Between 4 and 1, since 1 is smaller, it gets sorted like this. And between 3 and 5, it remains the same. That is exactly what you get when you do axis equals to 0. In case you want to sort it based on rows, what you do is np.sort A, comma, axis equals to 1. And what you get over here is it sorts based on the rows. So 1, 3, 4. Then 1, 2, 5. And that is the exact output you get. So if you see over here, and also mind you, if you do not mention any row, the axis number, you get a row sorted matrix. But this is definitely not recommended, so that you get explicitly what you want. So when you do a column sort, you mention axis is equal to 0 and you get the axis sorted matrix. That is 1, 1, 3 and 2, 4, 5. That is exactly what you get over here. Now when you want to do a row sort, you write axis equals to 1 and you get this particular matrix 1, 3, 4 and 1, 2, 5. So this was all about sorting of matrices or NumPy arrays. Now when you want to find the sum, as we know, we can do it by A plus B, right? That is the exact thing. But what if we want to find the sum of a given particular matrix? So here we have a matrix. So NumPy arrays are also called as matrices when it becomes two-dimensional. What is a matrix? A two-dimensional array. So therefore I'm calling it as matrices. So now this is A. What if I want to find the total sum? What I do is A.sum. So I do np.sum of A. And there's also an option to do A.sum if I import it in a different way altogether. In that case, I had to do import NumPy as np and then keep A as the variable for NumPy. Let us not go over there. This is a simple method we can use, np.sum of A. So what happens is, it sums up all the values that are present. That is 1 plus 2 plus 3 plus 4, which gives me 10. What if we only want to find the column sum? We do np.sum of A, axis equals to 0. And in that case, it would give me a one-dimensional matrix having two values, which is 4, 6. 4, 6. And if we put the axis to be 1, we get the summation of rows. So we get the same matrix as 3, 7. That is how we do the summation inside a particular matrix. Now we also have the mathematical operations. So here are the two matrices that we have drawn. 1, 0, 0, 1 and 2, 1, 1, 2. Now when we want to add the matrices, we can do it x plus y. And it would only add the values over here. We have already gone through this in the previous lecture itself. So this is quite the method of addition. We can do the same for subtraction. In that case, what it would entail is 1 minus 2, 0 minus 1, 1, 0 minus 1, and 1 minus 2, which gives me minus 1, minus 1, minus 1, and a minus 1. So x minus y should give me this particular value. That is exactly what we are getting. So in a similar fashion, we can do multiplication, we can do division, we can do floor division. If you remember, floor division is finding only the quotient, and division is the exact decimal value. So we can do all sorts of representation using NumPy mathematical operations. Now, NumPy also allows us to use statistical operations, which is again a huge need in the data science industry. So what it happens is, I have created a particular matrix 1, 4, 6, 3, 7. If I want to find the mean, I hope all of you know what mean means. Mean is simply average. So what I need to do is I need to sum it up. 1 plus 4 is 5, plus 6 is 11, 14, 21. And now I need to divide it by the number of elements. That is 1, 2, 3, 4, 5. So it should give me 4 point something, 4.25, if I'm not mistaken. Okay, it's 4.2. Then it also helps us to get the median value. What is median? Median is nothing. Let me quickly write it over here. So, values are let us understand all the operations quickly. So, the values are 1, 4, 6, 3, 7, right? Now, how do we get all those operations? When we want to find the mean, what we do is np.mean of A. And the computer itself adds up all these values and divides it by the length of the array, which in this case is 21 by 5, which gives me 4.2. This is the mean. What is median? Median is the computer first arranges, the machine arranges all this in a ascending order. So it would be 1, 3, 4, 6, and 7. And then finds the the middle value, which is 4 in this case. So it gives me the median to be 4. Then there is also maximum. Then there is the minimum. There is also standard deviation. For standard deviation, we use np.std of A. So what is standard deviation? Standard deviation is nothing but it's a long process altogether. So what I essentially mean over here is it finds the mean value first and then subtracts the mean from all the elements present. So mean is 4.2. It would do 1 minus 4.2 plus 4 minus 4.2 plus 6 minus 4.2 plus 3 minus 4.2 plus 7 minus 4.2. Then it would divide it by n. That is the number of elements. Here it is 5. And then it would take a root over, and that is exactly what a standard deviation is. So forgetting about the calculation part, standard deviation tells us how much deviation is the mean taking from all the values in general. So instead of computing them, we can use this std function and get the standard deviation. We can also get the maximum value. So maximum value here is 7, and we have got that. And by the function called argmax, we get the index of the maximum value, which in this case was the last element. So here we get index is 4. It should not be 4, right? How do we get 4? Okay, it is definitely 4. 0, 1, 2, 3, 4. So the index is 4. Similarly for minima, we can find the minimum value by np.mean of A, which is in this case 1, and it is the 0th value. So we have got index of min equals to 0. The function is argmain. Now an important function, it's not necessarily a function, but this is a concept we can use to mask. How do we do that? We have created a particular array by a range 10, that is all the digits from 0 to 9. Then we need to find, or let's convert all the evenly spaced even digit to -1. So we have created a mask wherein a %2 equal to 0. That is, it would only take the even placed digits. And then what I've done is a of mask equals to -2. So understand, a is nothing but an array consisting all the digits from 0, 1, 2 to ... up to 9. Mask. What is mask? Mask takes all the evenly placed digits. So 0 it would take, 2 it would take, 4 it would take, and so on, so forth. Now I have done A of mask, which means it would take all the even digits from this particular matrix, that is 0, 2, 4, and so on. And this I have changed to -1. Therefore, all these digits would be changed to -1, then -1 for 2, then -1 for 4, and in the remaining places, it would take the digits that were, and so on. That is exactly what has been, we are getting -1, 1, -1, 3, -1, 5, -1, 7, -1, 9. This is how masking is done using ND arrays or NumPy arrays. So hope all the operations that are present in NumPy are clear. In the next lecture, we'll be learning about pandas, and soon enough, we'll be moving to the use cases of NumPy and pandas so that you get a better understanding and a holistic overview of how do we use them in real life. So that's all for this particular session. We'll see you in the next session. Bye, guys. Hello, everyone. In this lecture, we'll be learning about pandas. The pandas is a Python library used to work with datasets. It is used for analyzing, cleaning, exploring, and manipulating data. The full form of pandas is panel data. So the pandas comes from panel data. And it's also sometimes called as Python Data Analysis Library. It was created by Wes McKean in 2008. Now, some of the important parts that we will be going through in this lecture is how to create our own data frame. There are several methods of creating a data frame. We'll learn all of them. How to read data from an external source. How to export data to another source. What are some of the options of understanding the data? One is describe and other is info. Typically, describe provides us a statistical summary of each column, while info provides us necessary information related to the table of the data. So let's move to the lab session and see each of them. So the first thing that we'll be doing is creating our own data set. So to create your own data set, first you need to import the pandas library, which is simple. Like NumPy, you have to import pandas as, and give your own alias. For NumPy, we used to give that as NP, and for pandas, we typically give it as PD. So import pandas as PD, and henceforth we'll be using pandas as PD. Now, let's say we want to create a particular tabular data set, right? With the headings as country, drives right, and cars per cap. And the data would be in the following columns. All right. So what we'll do is we'll create a dictionary of these headers followed by the data. See what we have done. So first we have defined some list, namely names, DR, and CPC. So these are just the list for this particular headers, right? So for names, what we have done is United States, Australia, Iran, India, Russia, Morocco, and Egypt. For DR, we have written true, false based on the country. And for CPC, that is cars per cap, we have given some values. So note one thing, the number of items in each list is seen. 1, 2, 3, 4, 5, 6, 7. For this 1, 2, 3, 4, 5, 6, 7. Similar over here, 1, 2, 3, 4, 5, 6, 7. So this number should be similar. Now what we have done is created a dictionary. So myDict equals to country as the key and names, that is this particular library, this particular list as the value. Drives right with the value dr. Cars per cap with the value CPC. So this is exactly the dictionary that we have created. Now let's see what the output of the dictionary would be, right? So that we get an understanding of how data frame is created. All right, so let me copy this entire thing out here. Now let's see the output of the dictionary. So if you closely observe, we see a dictionary. It is basically a nested dictionary, correct? With country as the key, and the list of names as the value. Similarly, drives right is the key with the Boolean values as value. Cars per cap as the key and their values as their list values as the value. So that is what myDict is. Now what we want to do is we have to create it into a data frame. So for that we use the Pandas library. So what I've done is I've taken a variable called cars equals to pd.dataframe. So dataframe is basically the function. So pd.dataframe, and in brackets the name of the dictionary, myDict. Now what it does is it creates this particular dictionary into a data frame with columns as the headers. So country would be one header, right? Another header would be drives right. Another header would be cars per cap. And the list of values that you see over here, that is US, Iran, and so on and so forth. For drives right, it would be true, then false, etc. For cars per cap, it would be 809, 731, so on. So all this would become the values. So typically this is what we have got when we call cars in a tabular format. And this right here is the indexing, which we get for free. So this is how we create a data frame from the very scratch. Now, is this the only way to create a data? Absolutely no. Because you might have tons and tons of data, right? And it's not really possible for a person to create lists with those data and then create dictionary and such. Again, the data might be collected in an Excel sheet, which has been used predominantly throughout the industry for a long time, right? So it's not possible for someone to fetch those data in a list. It is though possible, but the process would become something complicated at that point of time. So what Pandas has come with is directly converting an Excel sheet or a CSV file into a data frame. So how does we do that? So let us read this piece of information over here. It says Pandas can fetch data from many sources, some of the common being CSV and Excel. Again, it can fetch data from SQL, from other big data repositories, cloud and everything. But the ones we'll be using here predominantly are CSV and Excel. Although, remember that in the industry, we also use SQL and other stuff, but that would again be another depth of understanding. So let us limit our learnings at a particular stage, and we can learn the more things in a different level of lecture, right? One important thing is, if you want to import n rows, rather, if you want to, if you want n rows to be visible, then what you do is use the head function followed by the number of rows you want it to be visible. And that is for visibility of the first n rows. If you want the last n rows to be visible, use the tail function instead. Right? So now let's understand how do we do that. So let us assume there are again two ways to read data from external data sources. One is you keep your file in the location you want. So for example, I'll show you. What I've done is I've created an Excel file, or rather a CSV file, and kept in this particular folder called datasets. So datasets contain one file called iris. Let us see what it has. When we open this particular data, we find an Excel sheet containing 1, 2, 3, 4, 5, 6 columns, right? And how many rows? There are endless number of rows, right? At least I can see more than, okay, so there are 151 rows, correct? 151 rows, 6 columns. It's fairly difficult for us to embed everything in a list, right? So what if I want to call this particular data into my Pandas library so that we can work with it? So what I do is I use this particular address, right? So what I've done over here is I've created a variable called CSV path. Now CSV path equals to, I'll take the exact location of the iris dataset. Also remember, the name of this file is iris. And since it is a CSV file, how do we know that? Go to the properties, right? And see this particular location over here. Also, go to details and see the name of the file. It is iris.csv. Therefore, the exact location for this file would be, typically, let me bring my notepad over here. So the typical location of this file is this is the location, C, users, Urban Chatterjee, desktop, datasets, followed by the name. Okay, I won't be able to copy it. That's okay. So the name is iris.csv, right? Now what I need to do, I just need to copy the address, paste it over here. Right? Now the next thing that I need to do is I need to change the backslash arrows to slash arrows. So all these slashes should be changed to forward, right? Except, I'll tell you what. So let me do that. Right? And after C, I need to change it to double slash. So this is the exact location that I need to give. And if you watch it, this is exactly what I have done over here. Now the entire thing should be put inside a apostrophe, right? So now CSV path is basically this particular path which points to the iris CSV file. Now, I need to convert this particular path into a CSV file, a data frame, right? So for doing that, what I need to do is I need to create another variable. df is what I have done. df short form for data frame. So df equals to pd dot read CSV. Since it was a CSV file, I have used read underscore CSV. If it were a Excel file, I would have used read underscore Excel, EXCEL, followed by the path address. So here it is CSV path. You can directly put the path address, no worries for that. And then what I've done is df.head. So if you remember, head brings, or let me just write df. So it gives me the entire data set containing all the values. Now it is showing me 150. Why is that? How many data were there, to be honest? Okay, there were 150 data only. 151 was I think it included the header as well, right? Yeah. This is precisely what we get over here. 150 IDs, right? Followed by the 6 columns, ID, okay, 1, 2, 3, 4, 5, 6, and 150 rows. This is also what it's showing, 150 rows into 6 columns. Now, if you just want to read the first 5 rows, what you do is write df.head followed by braces, and you get the first 5 rows. Let's say if you want to read the first 7 rows, then after head, write the desired number of rows you want to read. And now you get the entire thing. All right. So this is how we read data from an external source, pretty much which we'll be using all throughout the course. Okay. So now this is something that I have taught you if your data was present at a particular location. What if your data is already located in the required directory? So what we do in that case is, let's say we have this iris file over here. So as I said, when you open this particular Jupyter notebook, where the Jupyter notebook has been opened, right? What do? You go to this upload button, press it over here. Then you go to your required location where the data was present. So for me, it was in desktop. It was in datasets, this particular folder, right? Now what I need to do is I need to click over here, press on open, and it comes. Then what I need to do is press the upload button. Now since for me, the iris CSV already existed, it's saying there is already a file named iris.csv. Do you want to replace it? For you, it should not be the case. If at all you have a file with similar name, make sure to replace or rename the file, any of them. So for me, since both the iris file are same, I'll just overwrite it. Now it has come somewhere. Iris CSV, right? Now what I need to do is, I need to go back and instead of writing the entire line of address, what I need to do over here is df equals to pd.read CSV followed by the name of the file, which in this case was iris.csv. And I get the similar output. See, the similar output. If I want 7 rows, I get the 7 rows, both being the same, exactly the same. So this is all about how to load a data set. Preferably use the second method so that you have the repository in place. Now, how do we export data to another source? So let's assume that we want to export our data. So as you saw over here, there's another file called export iris.csv. Let me delete it, right? Let me delete it. So if you see, there is no more export iris, no file called export iris, right? Let me go back over here. I can export it to the to directory as I have mentioned. Any directory that I want to give the address of, or to the live directory location where the Jupyter notebook is present. So the first method, I have taken the path. I've given the path as Excel path, right? And why have I written Excel path? Because I now want to change the format. From CSV, I want to change it to an XLSX file, which is typically an Excel file. So I've given the address to be the same address where the iris file was present. So if you closely observe, in this location, only a file named iris is present, which is typically a CSV file, right? Here you can find it, comma separated, which means CSV. The full form of CSV is comma separated something, version or something like that, right? So, and now I just want to export it as an XLSX file. So what I do over here is, I have given the path name, the same path name, and then df dot, there we used read underscore CSV. Now we are writing df dot to underscore Excel, followed by the Excel path, comma, index equals to false. Why we are giving index equals to false? It means we will not take the index into occurrence. And why we are doing that? Always remember to give this particular point, because when you do not mention index equals to false, the next time you load, two indexes come. One, because it was saved like that. The second, because automatically when a file is loaded, Python gives their indexes. So always remember to save a file by giving index equals to false. So now when I run this, also I have exported this to this live location, df dot to CSV. Now it would be a CSV file. To export underscore iris.csv, index equals to false. That is, a CSV file would also be added to the live location. That is here, right? Let's see what happens when I run the file. Let us check over here. So we find another file, which is an Excel file. If you see over here, it is a Microsoft Excel worksheet. It was Microsoft Excel, comma, separated value file. That is CSV, comma, separated value file. And this is a worksheet, which means an Excel file. If you see over here, we'll get the entirely same thing with 150 values. Now, when I want to check in the live location, I see another file called export iris.csv, since I had saved it as a CSV file. So this is how we export a file. So why do we need to export a file? Let's say you have imported a file, you have made some corrections, some data cleaning, manipulation and everything. Then you also need to save that file, or maybe to hand out to someone. In that scenario, you generally use this particular export command. Okay. Now coming to the two most important statistical functions. One is describe, another is info. So what does they do? So the describe function is typically used to describe the entire data set. it provides a statistical summary of each column. To get the description of all columns, use df.describe. To get more details, to get a more detailed description of all columns, also in brackets include this particular line called include equals to all. And let's assume you want description of some specific columns. Then what you do is df followed by the column names and then .describe. These are something that we need to understand. Now let's check all these things. So here, what I have described is the sepal length, sepal width, and petal length. So what I've done is df followed by the two braces, square braces, .describe. And what I've got over here is the count. That is how many times, how many values have been incorporated inside this particular column. What is the mean value of theirs? What is their standard deviation? What is their minimum value? What is their maximum value? What is their 25th percentile, 75th percentile, and 50th percentile, which is also known as median. The 50th percentile is basically the median. This is the 25th percentile. This is the 75th percentile. Now, let's think it this way. If you want more knowledge, you use this particular line as well. Include all. So what happens over here is fairly no change is observed because there is nothing more to be told, right? But in certain data, there are certain things which are missing when you only write describe. And in those scenarios, we use the include all command to get a more comprehensive understanding. Since this data is good, there is nothing else to be required. Let's say there were some missing values or some problematic data. Then include all will actually give those insights as well. Since this is a fairly good data with fairly no requirement of cleaning or doing any manipulation, we get the same output with include all and without it. All right. Now coming to the info. It provides the information related to the table. What it does over here is we write df.info and we get everything that you might want to know. The first thing that it says is the type of data. So it is basically a Pandas data frame. That is what it has mentioned. What is the range? That is 150 entries from 0 to 149. How many columns are there? There are total 6 columns. What are the columns? ID, sepal length in centimeters, sepal length width in centimeter, and so on. How many values are there? Typically, how many non-null values are there? There are all values which are non-null. Null means having missing values. Since there are no missing values, it says 150 non-null. And the D type, that is the data type. So the first has data type integer 64, the rest have float 64, and the final species. So if you just want to check the DF file over here. So the ID is integer. The rest are float values and the species is an object class. That's exactly what it has said. And after that, it has also given a summary that there are 4 columns with float 64, one with integer 64, another with object 1. There is one column with object. And how much memory usage is there. So describe and info is something we'll be using, almost all the time. Whenever we get a data set to understand how the data is, what changes that we need to do, and so on. So this was the very basic beginning to Pandas. Slowly we'll be moving depth inside it. So that's all for today. Bye guys. Hello everyone. In this lecture, we'll be learning about the header and index operations in Pandas. So what are the subtopics that we'll be learning? First, we'll be learning about how to remove a particular header, how to create row as the header, a particular row from the given data set as the header, and we'll also be learning how to create custom headers. Similarly, for index operations, we'll be learning about making any column as the index, creating custom indices, and also to reset an index. All right. Now, as before, we need to import the data set. So we have done that. Import pandas as PD and df, we have called it. There's another data that we have called, that is the cars. So pd.read csv cars.csv, and this is the data that we have got. Now, how do we remove this particular header? Country, drives right, cars per cap. So what I've done over here is df equals to df.read_csv followed by cars.csv comma header equals to none. That is, what we are doing is we are explicitly telling Pandas that import the data cars.csv, but keep the headers as none. That is, do not give the designated headers. That's what we are doing. It's at the time of calling the particular data. Therefore, the line, the row, which previously had country, drives right, cars per cap as the header, now moves to the first row. And instead of having 6 rows in total, we now have 7 rows. So that's one way of doing it. Another way, if you want to, put any particular row as the header, then what you do is you call the data df equals to pd.read_csv followed by the name of the CSV file, comma, header equals to the given row that you want. So here, what we have done is header equals to none. So no header has been put, and the row which had to be used as an header has been used as the first row. Now when I have written it to be 4, so the 4th row has been basically taken as the header. So if you closely watch, this was the 4th row, right? India falls 18. Even this was the 5th row. This is what you are seeing because the 0th row has been interchanged. If you see over this particular data set, the 4th row, 0, 1, 2, 3. That is the 4th, 1, 2, 3, 4. So the 4th row is India falls 18. And this has been taken as the header. Now let's say I wanted the 3rd row. Okay, this is happening because I have not imported the same. Now check it out. So the 3rd row, that is the row before India, Iran falls 588, has been taken as the header. And rest is the data that follows. So this is how you can create any row as the header. Now let's say you want to create your custom headers. What do you do then? You call your data, then create the headers. So since there are 3 columns to be created, what I've done is I've given the name ABC, and then I've written df.columns equals to h. H is basically a list containing the 3 characters. Then when I call df, I get ABC as the headers. And in that case, it actually outrides the actual header. So what I generally mean over here is when I write df we get this particular data set, right? Now what I'm doing, I'm creating this particular list of headers ABC. I'm writing df.columns equals to H. Therefore, what happens is the country, drives right, and per cap, cars per cap is replaced by A, B, and C respectively. And the rest of the data remains as it is. And this is the exact output that we get. So these were all about the header operations. Now coming to the index operations, what are there? So first we can make any column as the index. So as we saw over here, the index is 0 to 6 that the Pandas by default gives the panel data, right? Now let's say you want this particular, okay, let me call the df once more. So let's say you want the country to be the index. Then what you do, at the time of calling the data, you can write, after calling the data by name, you can give a comma and write index underscore call equals to the column number. So since I'm taking country, I'm giving index underscore column to be 0. If you wanted it to be the drives right, you could have given over 1. And in that case, drives right would have been the index. Similarly, if you want cars per cap, you can just give it 2. So this is how it rolls. Now, what if you first get the data and then you want to change it? There is an option for that as well. You first call the data by the name df or whatever you want to. Then what you write is, you use the set index function. So df dot set underscore index followed by the name of the column that you want. Here I want country. So I've given country dot head. Head is for getting only the 5 data set, but you can always just go forward like this. So df dot set index country. Let's say you wanted cars per cap. Just change it to cars per cap. And that is how you can make the index after you have loaded the data. What if you want multiple indexes? That can also be a case, right? Let's say you want to know which are the cars that drives right based on country and cars per cap. So in that case, you need 2 columns to be set as the index. So that's what we do. The same thing, df.set index followed by a square bracket giving the name of the columns that you want. So here country and cars per cap, which gives me both these 2 as the index. Now, what if you want to create some custom indices? What if you do not want any row, any particular column to be the index? You want some customized index. So what you do is, just like headers, you call the function preliminary, then you create a list. Here I've done that using I. Since there are 1, 2, 3, 4, 5, 6, 7 values, I've created 7 items in the list, 1, 2, 3, 4, 5, 6, and 7. And then what I need to do is, I need to replace the index. So what I do over here is df.index equals to I. There it was df.header equals to the name of the list. Here df.index equals to the name of the list. And then when I write df, I get all the data as it is, but instead of the index 0, 1, 2, 3, and so on, I get the names present in the list as the index. So this is quite the method of creating custom indexes. Now, what if you want to reset? Let's say you have already created this particular index and now you just want to remove them. You want the old default index to be in place. Then what you need to do is df.resetIndex. So reset index is the function for that, followed by drop equals to true. So he'll use drop equals to true. And then it moves back to the old format. Df before this particular function that was run was this. So df is like this now. Again, let me write ds. So you see the index is US, Aus, Japan, and like that. But now when you write df.resetIndex drop equals to true, this particular indices is resetted to the default form and you get 0, 1, 2, 3 and so on. So this was all about headers and indices, that is the operations that we use in Pandas. In the next lecture, we'll be learning about the column operations in Pandas. So that's it for this particular lecture. Hi everyone. In this lecture, we'll be learning about the column operations present in Pandas. So our agenda for this session would be to learn the differences between the double brackets, double brackets and single brackets, accessing specific columns, some miscellaneous functions, how to create new columns, how to drop columns, and how to drop duplicate columns. So starting with the very big initial thing, that is the difference between double and single brackets. So this is something that we use when we want the representation to be in the form of a data frame, right? While this is something that we use when we want the representation to be in the form of series. So what is the basic differences between a data frame and a series? So a data frame necessarily forms a tabular data. You see the data in the form of a table that we had been seeing for the past few lessons. While in a series, it gives us, how do we describe? Okay, let's see what is the difference, right? In short, it is not a tabular data as such. So what I've done over here is, I've imported pandas as PD. I've taken the data frame to be the car's CSV, and I've also taken out the data, df equals to df.head, right? So now I'll be working with, instead of the entire data, I'll be working with the 5 rows, since I have limited my data set to df.head. So now, what is the type of this particular data set? So type of df of country. Now when I'm putting double braces over here, it becomes a data frame, as I said. Now see the type that I wanted to see. It says pandas core frame dot data frame. Similar thing if, so let me okay, so the similar thing, if I put a single bracket over here, right? I'll get a series. Pandas core.series.series. Here it was data frame, here it is series. So a single bracket stands for series, while double bracket stands for data frame. Now coming to the exact differences. So see the way it is represented. Now when I'm representing df with double bracket country cars per cap, I'm getting this tabular format, right? However, if I want to represent in the form of a single bracket, we'll get this series. Now I don't know how to explain, what is the exact differences. Obviously a data frame makes the data looks in a tabular column, and a series makes it appear like this. Now, do we really need a series? Yes, we do. There are certain instances when we will be using only series. A data frame cannot be helpful. So we'll come through all those cases. But as of now, we should learn that there are two ways of representation. The first being data frame, which is typically used for visualization and representation. And another is series with single brackets. All right. Now, the second part, if you want to access certain columns, since a data frame would be containing millions of data, it is very difficult for us to, locate certain data with certain conditions, right? Say for example, we want to access only the columns where cars per cap is greater than 588. How do we do that? It's pretty simple. The first thing that we would want to do over here is, we would want to bring the series. Here we'll start with the concept goes like this. Let me just pen it down quickly. First, you need to find the series of data, right? Which are greater than 588. Now, once you find the series of data, you convert it to a data frame. That's what you do. Because a data frame does not necessarily have these operations. Therefore, see what I'll be doing, right? So df of cars per cap, right? Let's see what we get. So we get a series of the header, because I've already I've already made the limitations of the df to the 5 rows itself. Now it contains all the values. Now I only want to get all the data greater than 588, right? So it would be converting the entire data set to Boolean values. So these two are true, the rest are false. So typically we should get the first two values. How do we do that? Now we create a data frame out of this particular series. How to do that? We do ds followed by a square bracket and close it at the end. Voila, we get the first two rows. So this is what we exactly do. Now, why this difference is? Okay, so here I have used greater than equal to, which should not be used because it's clearly mentioned that access only the columns where cars per cap is greater than 588, not greater than equal to 588. This should have been the actual result. So hope you understand. First, you need to create a series of data adhering to the given conditions, then convert it to a data frame. What if you wanted to access only the columns where cars per cap is equal to 200? Then instead of greater than, use equal to 200. Now, what if you want some multi-facet conditions? For example, here it says accessing only columns where cars per cap is between 200 and 800. So what I'll do is, cars per cap, I'll create two series, right? The first series is df cars per cap greater than 200. And this is the symbol that we use. We use and, or. If you remember in Python itself, we use and or like this. But for Pandas, we use and or like this. Okay, so that said, what we do is, the first condition is met, that it should be greater than 200. That's what we have done, greater than 200. And df of cost per cap less than 800, which means the entire data should be between 200 and 800. Now, the entire thing should be enclosed within a data frame. So that's again what I have done. df followed by a third bracket, enclosing all the conditions. And now we get this particular data. All right. Now there's another format. What if you want to access columns that belongs to only India or Australia? So there's this excellent function called isIn. So what we do is, we need to find, so what in this case, so let's say you are given a question that please find me all the columns that belongs to India or Australia. So first what we'll do is find df and see where, in which column is India and Australia located. So we see that it's located in the column country, Australia and India. Now what we do is, we take df.country, all right. We take this series. So df country. Now we want to find the countries limited to India and Australia only. So isIn followed by single braces, curved braces, and then India, Australia. So now you get the Boolean value. And now what we need to do is, we need to enclose it within the data frame so that we get the table. And that's how we actually get it. All right. So there are some miscellaneous functions of Pandas as well. So let's say I take, again, I'll just bring the df over here, right? Now it's quite easy for you to understand that there are, what are the name of the columns, because there are 3 columns. But generally, typically when we take some data, which we'll be doing later in this course, we'll get huge amount of columns, which might range from 20 plus to 30 plus. So it's not actually possible for us to see and check all the columns, right? And in that case, if you want to access what are the columns present so that you can do a manual search over that particular column. Let's say I gave you this particular task that the country should be between India and Australia. Now, let's say there are 30 columns. Would you go on checking 30 columns as such? It's quite difficult. So what you would necessarily do is, you would use this particular function called .columns, which gives away the names of all columns. And then based on your logic, you would try to shortlist, let's say 5 out of this 30 columns. It might be wrong, that's okay. But typically this 5 columns might contain the values you are looking for. If it's not, you might then want to take some other 5 and so on, go on, right? Surely would not start from the 0th column and go one by one until 30th column, because it's quite evident if you see this particular columns that drives right should not contain any numerical value. It would only contain Boolean values. So it makes no sense to search any numerical value in this particular column. Likewise, for cost per cap, you would not necessarily want to search any country or string value, right? So that's what we do. So to get all the columns, we use this particular function called df.columns. .columns is the function. So when we do that, we get all the names of all the columns. Country drives right, cost per cap, and also the type, which is not necessarily over here, but we do get that. Now, another excellent function that we use is .unique. What it does is, so I've used this unique functions over the column cars per cap. So it gives me all the unique values present. Let's say if in a real-time data set, you will always get repetition of various values, right? The unique function would help you to get only the values that are unique. For it is used for different mathematical operations. Now, one important function is value counts. What it does is, so I've used value counts over the drives right. Now, if you see, the drives right has only two unique values, right? True and false, and the rest are on repetitions. So for example, what I mean over here is, had I put drives right.unique over here, I would have got only true and false. Now there are more rows than two, right? So there should be more than one true and more than one false. So to check their values, how many trues and false are there, we use this value count function. So df drives right dot value counts, and it gives me the number of trues and number of false. Here we see 4 trues and 3 false. All right. So these are some important functions that you should take a note of, because we will be using extensively all these functions, and at that time I won't be going back to the basics and making you understand what this does. So these are some functions that are extensively used and you'll be using all the time. All right. Now, how do we create new columns? So previously, our data set looked like this, right? There were 3 columns. What if I want to create a new column? What I do is, I write, just like dictionary, I write df new equals to, and give the function that it should do. So what it does is, it divides car per cap by 10. And new is the name. And now you see this particular output. So new is nothing but cars per cap by 10. And that's exactly what you get. You can change the name to anything like, so by 10. That is exactly what you get. And let's say you just want to subtract 10 from it. So you get the same result out of it. So you can create a new column by this particular procedure. What if you want to drop columns? There are 2 ways of dropping columns. I mean, you can drop columns and rows by using the access method. So for dropping columns, you use access equals to 1, and for dropping rows, you use access equals to 0. So what I've done over here is df, as we all know. Again, let me bring out df so that you get a visualize effect of what is happening over here. Now what I've done is, okay, so df has already changed since I have used a new column. We call df again from cars. So this is what df is now. Now what I've done is df.drop drives right. So drives right column would be dropped. And how would it be dropped? Access equals to 1. That is, the entire column should be dropped. The entire column. Therefore, we should get country and cars per cap as the output. That is exactly what we have got. Now, what is in place equals to true? This is an important argument that you have to mention so that this changes, occurs and stays with it. Unless we explicitly mention in place equals to true, this drop does not really occur. It occurs in this particular line, and then when you call df again, you will see. Let me demonstrate the scene. So what happens is, so you see df like this, right? Now when I say df.drop drives right axis equals to 1 and then call df, you see no changes. Drives right has not been dropped. So for dropping, you need to write in place equals to true. And now it has been dropped. Now what if you want to drop multiple columns? The same way. Drop, after that, use a square bracket and write all the columns that needs to be dropped. So here I have written drives right and cars per cap. Axis is obviously 1 since I want to drop the entire column. And now when I run it, I get only the country. Now in case I want to drop the rows, certain rows, what I do is, instead of the columns, I have written the index of the rows. So 0 and 1 is what I want to drop. And axis should be 0 because I want to drop the rows. And then in place equals to true. And that's the exact output that we are getting. 0 and 1 is missing. Let's say I also want to draw the Morocco. That is the 5th. So I get 0, 3, 4 and 6. 5th is also dropped. So that's how we draw rows and columns. Now let's understand how we drop duplicate columns, right? So this is another data set of dogs. Let's quickly understand. So it has some 5 dogs: Pluto, Goofy, Pluto and Tom. So Pluto has the breed of Chow Chow. Goofy has the breed of Poodle. This second Goofy is also Poodle. So both these Goofies, right, has the same name and the same breed, right? So I presume from this data set, this has been a repetition of data. Now this Pluto has the same name as this one, but the breeds are different. While this is of the breed Chow Chow, this has the breed of Labrador. And Tommy is a totally different dog altogether. Now, what if we want to drop all the duplicate data? Because this is not something that we'll be needing and it might cause bias in our data, right? So dropping duplicate based on a single column, names. So df.drop duplicate. Drop duplicate is the function that we use over here. Subset equals to names. So when I do that, you see the one Goofy and one Pluto has been dropped, right? Pluto, Goofy, Tommy exists, which is correct because I have been dropping them based on names. But is it something that I have done a correct thing? I don't think so, because while Goofy from this data appears to be a repetition of data, Pluto is not, because both the breeds are different. And in this case, what we need to do is, we need to include both the columns. So what I've done over here is, I've taken names, comma, breeds. And now okay, so this won't work actually because I have already dropped it. I need to call this particular function again. Then I can only drop it. Okay. So I need to provide all this inside a square bracket. Now it would work. So now when I'm dropping the columns based on the duplicate columns based on names and breeds, we see there are 2 Plutos because they are of different breeds. However, Goofy has been dropped. Now I'm not saying that these 2 Goofies are the same. This is just a redundance of data. I'm not saying that. But from the data that we have, it appears so. And it's no use of keeping these 2 Goofies here. And that is how we drop the duplicates. So this was all about Pandas columns. And in the next lesson, we'll be learning about loc and iloc functions. So this was all about this particular lecture. Hello everyone. In this lecture, we'll be learning about the loc and iloc functions. And also we'll be learning about the slicing and dicing operations present in Pandas. Typically, loc is a level-based function. We use loc and iloc to locate some data points, some values inside the table. And loc is a level-based identifier, while iloc is a position-based identifier. So the value when we use loc is accessed using labels or names, while for iloc, it is accessed using numbers. So let us understand how do you use that? So first we have imported the cars dataset, and this is exactly how it looks. Now let's understand how we use the loc and iloc function. Now let's say we want to access this particular data over here, United States, right? So by using loc, what we will do is, so this is the name of this particular data set is kept as data, right? That is what we have done. Data is equal to vd.read csv cars.csv. So what we will do over here is data.loc 0, country. So 0 for the position and country for the column. And it gives us the United States. The same thing, if we wanted to use iloc, we will be using the positional arguments, that is row number and column number, which is 0 and 0. And we get the same output, United States. So understand this thing for loc. Okay, let me do it over here. So for loc, what we do is we use the row index or row name, whatever it is, comma, the column name. And for iloc, what we do is we use the row number, comma, the column number. So loc uses the names while iloc uses the column. We get the same output. We need both loc and iloc to perform different operations at different times. Again, which all will be clear to us when we move to the live projects. All right. So some more ideas about the loc and iloc. So Pandas series and data frame that we have already discussed. When I'm using a single bracket braces, I get the series. But when I'm using the double braces, I get the same thing in the format of a tabular column or data frame, whatever you want to call it. Now, what if you want to get the entire rows, right? If you want to get all the columns, you do not want to distinguish between the selective columns, but you want only the first two rows. So you write data.loc 0, 1, which should be embedded within two braces. Why? Because we want a data frame over here. So we get this in the form. Now the actual method of representation is two brackets. The first bracket indicates the rows, while the second bracket indicates the columns. So what I've done over here is data.loc, and I've taken the square bracket, and after that two square brackets. The first one for the rows, that is the 0, 1, first and second row, and the next is for the columns that we want to put over here, which in this case is country and cars per cap. So the first thing, this is for the rows, and this is for the columns. So what you do is rows, comma, columns, and the entire thing should be within another square bracket for it to be acting as a data frame. And this gives us 0, 1, and second row, and country and cars per cap as the columns. Alright. So although in this particular code I have written only one bracket, always remember the actual method is we need to give, after this bracket, there should have been a comma followed by another bracket for the columns. Since there is no limitations or there is no filtration amongst the columns, I have chose not to take any column into account. Alright. What we could also have done is include the name of the 3 columns. So this and including the name of the rest 3 columns is basically the same thing. Okay, so I need to import this thing first. And now see the difference. So we get the exact same thing. Now, if you want some columns, if you want to do some filtration in the columns, you would want to include this particular braces. Otherwise, it's okay just to leave it blank. But for a starter, always try to use it so that you do not get any mistakes in it. Alright, so the format is very simple. Let me grab the pen. So the format is data or df, whatever you want to call it, whatever name you have given, .log, followed by a single big brace, followed by the first brace for the rows, comma, one another for the columns. So this is the exact format. Now, what if we want all the rows to be present and the selective 2 columns, that is country and cars per cap? Then what we do is, after log, instead of putting another braces, we do the colon, which means all, followed by a brace and the names of the columns that you want. And this gives me all the rows and only the 2 columns. So this was all about the usage of loc and iloc. Although I have used loc typically more in this particular example, rest be assured, iloc is just as well used, and we'll understand that once we go to the live projects. Now, what about slicing and dicing? It's nothing. Slicing a data frame using loc, and we can slice a data frame using numbers if we use iloc. Slicing is just taking a certain part from the entire data set. So let's say we have this data, a humongous data, and we want to take a certain part of it. So then in that case, we use slicing and dicing. So what we do is data.log 0 to 2. So we would take 0, first and second column, rows, and all the columns from country to cars per cap, which means country, drives right, and cars per cap. So that is exactly what we have got. Basically, this slicing undicing is just an extension of loc and iloc. It's just a name that we give. Basically, we perform only the loc and iloc functions only. And if we want to do the same thing using iloc, what we do is data.iloc 0 to 2, comma 0 to 3. 0, 0th column, first column, and second column. And that is exactly what we get over here. So one typical difference between loc and iloc is when I'm writing 0 to 2, what it does is it takes all the values pertaining within it. So it takes 0th column, row, first row and second row, and all the columns, country, drives right, and the third column. While here, it takes the n-1th row. So 0 to 2, it takes 0 and 1, and 0 to 3, it takes 0, 1, and 2. So this is a typical difference between loc and iloc. Alright, so this was the end to loc and iloc functions. In the next session, we'll be learning about other aggregate functions. Hello everyone. In this lecture, we'll be learning about the GroupBy functions, sorting functions, and the counts functions. So let us begin with the GroupBy. So the basic syntax for GroupBy is df.groupby followed by columns that groups followed by the third bracket and column that are grouped dot function. That is how it needs to be grouped. The columns that are grouped is optional. What are the different types of GroupBy? We can group by using a single attribute, multiple attributes, and with respect to multiple columns. All right. So let's call the data. I've called the cars2 dataset over here. This is what exactly it looks like. The name is cars. So now, if I want to group it by drives right, that is drives right. If I want to take the mean values out of it, how does it look? Cars.groupby followed by the columns that groups. So drives right is the column that groups. Now it has two unique values, false and true. And for the other parameters, which are typically the numerical parameters, because I've taken the mean. So country itself, Pandas is smart enough to prohibit country from coming into this particular part. Why? Because obviously we cannot find the mean of any country like that. So it only takes into account the numerical columns, which are cars per cap and number of cars. Now, what is the mean of cars per cap? What it does is it adds all the values and finds its average, which comes to be 445.66. For true, it comes to be 281.281. And for number of cars which drives right, which drives left is 500, which is the mean, and which drives right is 287.5. So that's what we get. Now, what if I just wanted the cars per cap? So what we need to do over here is, cars.groupby followed by the columns that groups. So columns that groups. And all the other columns, numerical columns, come into account. Now, what if I want to group only a single column or limited number of columns? Then I also mentioned within square braces, and again remember taking two braces because we want the data frame. So column that is grouped, right? This column will be grouped. This is not the grouping column, but the column that is grouped dot the function that I want to take. So here cars per cap is the column that is grouped. and the function is same mean. So I get the exact same output. Only the number of cars column is removed. Now, as such, we can use different other operations. So other than mean, we can use finding the minimum, maximum, sum, and there are other operations as well. Generally, we use these 4 operations, that is mean, minimum, maximum, and sum. So what I've done over here is I've grouped by cars that drives right, and cars per cap is the column that is grouped. And I've also used the function to be the aggregate function of min, max, and sum. And this is what the output is. So typically it says that there are 2 unique values of drives right. Either it is false, which means it drives left, or it is true, which means it drives right. So the minimum number of cars per cap which is driving left is 18, while that is driving right is 45. The maximum is 731, and here is 809. And the sum of all the cars that drives right, rather that drives left, is 1337, while that for the cars that drives right is 1124. Now, what if we want more than one column to be the grouping column? That is, the column drives right is not the only decider of the grouping, but there are more columns. So that is what we have done over here. I've taken country to be the deciding factor as well. So what I've done over here is cars.groupby followed by the 2 columns, drives right and country. And again, cars per cap is the column that is grouped, and I've used the mean function. So what it does is, first it takes false and the name of all the column countries. And then it takes true and the name of all the countries. Now note, so let me quickly bring the cars. Okay, I hope I have imported. Okay. Now, see here, for false, the countries that have drives right as true has not been listed at all. So you would not find in the false US there, since US was true. So United States fall under the true column, right? Similarly, Egypt, Morocco, Russia falls in the true column. And for false, all the countries that have false as their drives right. Now this is how it has made a group by function. First by drives right, false and true, and then followed by the countries. And cars per cap gives the mean of all the cars of Australia, which drives false, which drives to the left, for India, which drives to the left, and so on. So this is all about grouping columns based on multiple columns. Now comes the sorting function in Pandas. The syntax is very similar. df.sort values, columns that sorts, followed by the columns that are sorted. The sorting can be done based on single as well as multiple parameters. Here what we have done is cars.sort values based on cars per cap followed by the country. Now quickly let us bring cars over here so that we do a comparative analysis of the same. So let's see, I have done an ascending order sorting. So cars per cap, the least is 18, which points to India. So India is at the first position. Then comes 45 with Egypt, and Egypt is in the second position. After that comes Morocco with 70. So this is how it actually does the sorting. Also see the most number of cars per cap is United States with 809. And therefore, it has come at the very last. Now, what if you want to sort the values based on cars per cap and take all the columns into account? One way is to use this particular thing. Which I very much recommend for starters. Otherwise, what you can do is give nothing at all. And in that case, what it would do is it would take automatically all the columns. But for starters, I will generally recommend use all the parameters that are there. So this is how we sort. Now sorting can also be done. Again, this is when you want to sort based on descending order. What you generally do is you give ascending equals to false, this particular statement. This makes the sorting to be done in a descending order, which we have already learned while learning Python. Now, what if you want to sort based on not one parameter or column, but more than one? While putting sort underscore values, put the number of columns you want there to be. So what I've used here is drives right to be the first column and cars per cap to be the second column. Comma, ascending equals to true, comma, false, which means when, so drives right are it only has the values true and false with it, right? And since f comes before t, we generally see all the false values together and then the true values. But let's say if for similar false value, so let us understand how it works. So what I've done is cars.sort values drives right, comma, cars per cap, ascending equals to true, comma, false. So what it essentially means is it would first sort them. Ascending equals to true means in an ascending order. So drives right would be sorted in an ascending order. So f comes before t, therefore all the false values comes before. Now between the three false values, all are same, right? So how do we define which values comes before what? In that case, when there is a tie between the two values, it sees for the second part, that is cars per cap, which is said to be false over here, which means in a descending order. So cars per cap where maximum would come before. So that's what we see, false 731. Since it's its maximum, it is coming before that. Then 588 and then 18. Then comes true and all the values for cars per cap would be again in a descending order, 809, 270 and 45. So that is typically what it does. For the first, it always gives the most priority to the first parameter. When there is a draw, there is a tie between the different values of the first parameter, it takes into account the second parameter. And that is exactly what you see over here. Now comes the counts function. So the counts function is nothing but it tells how many values of that particular column is there. So cars drives right has only two unique values, false and true, and it gives us the value counts of how many trues and false are there. Similarly, if I wanted to take number of cars, then it would have given me the different unique number of cars, that is 100, 700, 200, 250, 600, and the count of each of them. Now, what if you typically want to, what if you have been given a question that find the counts of 100 cars? So one thing is you can write this particular piece of code and get all the values and then check here where 100 lies. I mean, what is the number corresponding to 100? But what if it itself, the number of unique values was in millions? How would you search then? So in that case, what you do is you add the required value over here. So since we wanted 100, I would have added 100 like this. And the value that I'll get is 2 over here, which is exactly the same that it corresponded to here. All right. Now, one more important thing that we need to know is we can also integrate count and sort method. What do we need to do? Cars, number of cars dot value counts. So the value counts gives the number of counts corresponding to the number of cars, and then include the dot sort values method. So it sorts the number of cars in an ascending way. And that is the reason we see 1, 1, 1, 2, 2. So this was all about GroupBy, sorting and counts. So that's all for this particular lecture. Bye guys. Hi everyone. In this lecture, we'll be learning about merge and concatenate functions in Pandas. So starting from the very basic, what are merge and what is concatenation? Merge is nothing but when there are two data sets and you want the two elements from the data sets. So there should be, let's say, the first data set contains many columns, among which name is a column that is present in both. So merging can be done based on this particular column called name. And there might be 4 types of merge, that is inner join, outer join, left join, and right join. While concatenate essentially concatenates the two data. It does not see any particular column or pointer, but it merges side by side the two datas, or maybe top to down based on how you want. So that is the exact difference between concatenation and merge. We'll also see that as we move forward with the lecture. Now, what are the inner, outer, and left and right joins? So people who know SQL or are accustomed by the set theory would know this. Let's say there are two data sets. This is D1, this is D2. So inner join means this particular region, that is the intersection region between data 1 and data 2. What is outer join? Outer join means the entire region. Does not really matter. This is inner join, this is outer join. What is left join? Left join is the intersection position plus the left data set full. So the right data set would be left, which does not have any matching with the left data set. So this is left join. And what about right join then? Some of you must have already guessed the intersection position as well as the right data set, leaving the left data set alone. So these are all about inner join, outer join, left join, and right join. All right. So now I've created two data sets, right? The first one is what I call df1. So this is df1. And this one is df2. So if you see closely, df1 has the name Arijit. Even df2 also has Arijit in it. After that, it has Neeraj, Sakshi, Muskan. It has Meenu, Sakshi, Ranbir. So both Sakshi and Arijit are common names in the two data sets, right? The other columns, here is age and gender, and here is occupation and gender. So now, what if we merge them? So the basic syntax for merging is df.merge, right? Followed by the name of the data set. So df1, df2. And then there is this parameter called the on, which determines based on which column you want to merge them. So here I would want to merge them based on name, right? And then the type is also need to be ensured. So how equals to, let's say I want an inner join. And in that case, I should only get Arijit and Sakshi, right? So let's see. So that's exactly what I have done. Df is equal to pd.merge df1, df2, on equals to name, and how equals to inner. So now, when I need to run this previous cells as well. Right. Now it should definitely work. So I'm getting Arijit and Sakshi as the output. After that, I'm getting the age column and then gender column, gender of X, that is the first data set, and then occupation and gender of Y. Where is the second? Both are similar, obviously. Now, what if, as I said, inner was taking into account the intersection part. So since both Arijit and Sakshi were present in the two data sets, we got only the two. So what if now I want to take into account, let's say, outer join, which means the entire data set would be taken into account. Let's see about that. So I'll change nothing but this particular part. And see, all the names has been listed down. So 4 names of here and 4 names from here, -2 because Arijit and Sakshi would be there twice. So Arijit, Neeraj, Sakshi, and Muskan, right? After that, Arijit is removed because Arijit was already present. Then Meenu. After Meenu, Sakshi has been already present already, so it does not include it once more. And then Ranbir. So there are basically 6 names, right? 4 plus 4 minus 2, that is 8. That is 6. And in places that it does not have any data, for example, it does not know Neeraj's occupation. It does not really know. So it has left NaN over here. And this gender, obviously it cannot take this gender from here. And that's why it has left NaN. Although we find the gender from the X dataset. But occupation is not known and therefore it is left to be NaN. Similarly, for Meenu and Ranbir, the age is not known and therefore these columns are left to be NaN. This column, this particular column. So this is how an outer join works. Similarly, for left and right join, we can use left or right, right? So this is how it actually occurs. Now coming to the concatenate part. So if we want a top-down approach, that is the two data sets that we have seen just now, if we want them to be arranged in a top-down manner, that is one after other, we use the axis to be 0. And if we want a side-by-side representation, we use the axis to be 1. So let's see how do we do that. Again, we have taken the same data set, df1 and df2, with somewhat different names, right? So now what I've done is df.concat, df1 and df3. So this is df3 and this is df1. Access equals to 0. That is a top-down approach. Now see, Arijit to Muskan. So Arijit, Neeraj, Sakshi, Muskan. After that, Karthik, Veer, Preeti. And their age and gender has been mapped as well. Now, this is done since I have written access is equal to 0. If I had written access is equal to 1, we would have got a side-by-side entry. So name, age, gender, again name, age, gender, right? Now one important thing to note over here is, had I wanted to concat df1 and df2, since df1 and df2 has the same column names, it can be concatenated. But df2 on the contrary has different columns, occupation and gender. Therefore, this can not be concatenated. Okay, this can be concatenated. So my mistake, this can be concatenated, but this concatenation has no value altogether because you will find lots of NaN. And this becomes too messy. So wherever you have some different column names, we usually use the merge operation because we typically want to coalesce the data into a proper data set. And we use the concat when there are different chunks of the same data set. Because by looking at these two particular data set, we can understand that if we merge it into a same data set, we'll get a list of all the names, their ages and gender, which would be much easier for the computer to compute. And that's why we use the concat for columns, for data sets having the same columns. All right. Although we can use concat for data sets having different column names, it is never done because see, I mean, it doesn't give any proper indication. There are full of missing values, and there is a chapter which will be going through how do we discard the missing values, because missing values play a very detrimental role in our machine learning process. So yes, that's all for today. The next topic would be Pandas Datetime functions, and then we'll also learn some advanced Pandas functions. Hello everyone. In this lecture, we'll be learning about the Pandas Datetime module. So what we'll be typically learning over here is pulling out the hours from a particular data set, pulling out the day of the year to find the data after a particular given date, number of days in the data, and the number of occurrences each year. So let's learn everything one by one. So the first thing that we'll do is pull out the number of hours. So before that, we need to find a particular data set, and I've taken this particular data set from a website called 4Ports. Now, this is the particular data set that we see. Notice one important thing. Here the time, the column with time, has the data or the date written in this particular format, right? But if you remember the datetime module, the date should be written in the form year, 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 month, month, and day, day, right? So this is basically a mismatch, which in turn Python or Pandas would not actually understand that this is a particular date. So the foremost and the most important thing that we need to do is we need to convert this particular column, the time column, to datetime format. How do we do that? So UFO is the name of the data set. What we do is we pick out the column time. So UFO of time equals to PD dot toDatetime. toDatetime is the name of the function. toDatetime of UFO of time. Now what it does is it converts this particular format into the default format. year, dash, month, dash, day, followed by the time format, right? Now we can do all sorts of operations that we want. So first, we want to pull out the hours. What we do is year4 of time, because it's located in the time column, .dt.hour.head. So head is for pulling out. Since the data is too large, you'll see, let me show you. Okay, let me run the columns first. All right, if I do not put the head over here, the problem that we might face is it's too large. It has 18,240 rows. Therefore, it's best that we use the head to understand them in a proper way. So what we see over here is year4 of time dot dt dot hour dot head. So .hour, dt.hour is the function that helps us pull the hours. So it's 22, 20, 14, 13 respectively. Then if you want to pull the day of the year, what we do is instead of hour, we use day of year. And that helps us get the day. Here you will not necessarily find the day, but if you do the calculations yourself, you would get to this particular value. Here, Python does it for you. So the first 1936th, the month is 6th, and 1st June, I think June, January, February, March, April, May, June, yeah. So 1st June of 1930 is the 152th day. And that's how it finds the day of the year. Now, what if I want to find the data after a particular date only? We do not want all the data, but we want to find the data after a particular date. So let's say the particular date be 1st January 1999. So what we do is I have created a variable called part_date for particular date, pd.toDatetime, and I've converted this to the particular format. Either I can convert it or I can give it in the particular format, that is year, month, and day. But I chose to convert it. That's okay. Now what I've done is year4 of time should be greater than equal to part_date. And now what I'm getting is all the dates that is greater than 1/1/1999. So that's exactly what we are getting. We are getting 1/1/1999, but the time is more than 00 hours. If I remove the head, you will see all the data that is greater than 1999. So now coming to the number of days in the data, the method to find it is .max minus .min. That's what we do. And here it gives me the number of days, that is 25,071 days. Also, if we want to find the number of occurrences each year of the year4. So the data set that we are dealing with, I have not actually described it because we are not finding anything. We are just seeing the datetime property. But the data we are dealing with is actually a record of number of times the year4 has been spotted based on each day. So if we want to find in a generic way, that is in which year, how many times has this year4 been spotted, what we do is we use the value counts method. So what I've done is year4 of year equals to year4 of time dot dt dot year. So I've converted this to the year. And now what I've done is value counts and sorted it in a descending order. Therefore, what I'm getting is the value of year followed by the number of times the year4 has been spotted. So for the year 2000, it has been spotted 26,135 times. In the year 1999, it has been spotted 2,774 times, and so on. And I can also create a graphical representation of how the spotting changes with respect to years. So what we can see is in the year 1930, 1940, the number of spotting is quite less. And as it moves towards 2000, the number of spotting is pretty much more. And we also see this particular depth in 2000, therefore, which indicates that just before 2000, it had its peak, which is also shown over here. 1999 has the highest record, and in 2000, it was slightly less. That's what the graph also shows. Now, I won't be explaining the graph too much because we'll be having a particular lecture on Matplotlib, as well as other lectures on visualization, different tools that we use. So this is just a graphical representation to show you all. So yeah, that's for today. The next lecture would be based on some advanced functions that Pandas entail. Hello everyone. In this lecture, we'll be learning about some advanced functions present in Pandas. The first thing that we need to learn is about the separator. Then we'll learn how to rename the Pandas data frame. Not only the data frame, but the values inside the columns as well as headers and everything. Next, we'll also learn the string functions and how to embed the string functions into Pandas. All right. So, starting with the separators. So, there might be many types of separators. The predominantly what are used are this standing hash and the comma separator. And by clicking, I'll attach this notebook with you for you to go through. By clicking this link, you can get a good idea from the official documentation itself what are the different types of separators possible. All right. Now, for the standing hash separator, first what we need to do is import the data. So this is the data that we have imported. Now, if we see, it is quite not understandable what is happening over here. So the major problem here is the data has been concatenated with this particular standing hash. So we need a hash separator for it. And what we have done is, again, we have imported this particular file, and this time we have used the separator standing hash with it. Now what we get is this particular output. All right. So now the data is understandable. Similarly, sometimes we might see a data which is concatenated with commas. And for that, we need a comma separator. And this is how the data changes from this to this. Now, note one thing. Each time we are using pd.read_table. Previously, we have used pd.read_csv or read Excel. So read table is used for reading any data from website, any kind of data. But if you use a CSV file and you write read table, you will get this similar output because this is nothing but a CSV file. CSV file is nothing but a comma separated variable file that we have seen. Now this is what I have also written, that this particular data, instead of writing pd.read_table and separating it by a comma, right? Separating it by a comma, we could have done pd.read_csv and it would have given us the same output. All right. So this was all about how to use the separators. Now, how do we rename any headers? So for that, I have imported a particular data. Now let's say I want to rename the colors reported, and instead of this gap, I want a underscore between it. So I can use, there are two ways to do it. The first is using a dictionary. So what I've done is taken a dictionary called rename underscore call, and I've taken the names to be the key. So colors reported is basically the key, and the value is colors underscore reported. Here, the same goes there. If you want, you can change some other thing as well. Let's say, for example, I want to change the name of state, right? So what I do over here is state followed by, let's say, I just want to give a fun name called places. Not a fun name, but places, right? In that case, what would happen is, see the differences. Here, colors reported has been changed with the underscore, shape reported has been changed with underscore, and state has been changed entirely by places. All the values remain the same. So this is how we can change using a dictionary. Now let's say you want to change using string functions. That can also be done. So what you need to do over here is, although I will always suggest use a dictionary, that is the most easiest way to do it. But then we should also know how can it be done using string functions. So what we need to do is ufo.columns equals to ufo.columns dot string dot replace. This is the function that we use, dot string dot replace, and I've replaced the gap by underscore. So the replace method in string, and I've got the same output. And this places has been changed to state because I've obviously imported the data again. So now coming to the string functions, we have already learned string in detail, and all such functions can be incorporated inside Pandas by using the dot string method. So first, if we want to change the cases, what we do, I've imported the data again, right, over here. Now, what we want to do is, let's say I want to make all these items in capitalize. So what I do is orders.itemName.string.upper. So always remember .string has to be used and followed by the string function. And head is used because I do not want to take all the values. So when I run this, I get all the values in upper. So here it was chips and fresh tomato salsa in a camel capitalized way. And now all has become an uppercase. Similarly, we can use all the functions that are present in string. So for example, contains. What if I want to find only those items which has chicken in it, because I'm a chicken lover? So what we do is orders of order items dot string dot contains chicken. So dot string dot contains chicken, and I get all the order names with chicken included in it. All right. Similarly, we can also use the replace function, which we have already learned. Now, there is another important function called change data types. So why do we need it? Let's understand this by a good example. So I have called this particular data set, right? And here my question is to find the item with the maximum price. So when I do orders of item price dot max, it should give me the item with the maximum price, right? But it gives me $9.39. So 9.39 should not be the answer, because here I see 16.98 is present, and definitely 16 is greater than 9.39. So what went wrong over here? This is the fact that item price should be a float or numerical value. So here it should be a float value, right? But it wasn't. If I check the type, so if I want to check the type, I'll get a string, right? So it should be a float. That's what we need to do. So first what I have done is I have replaced this $sign by nothing, because obviously a string cannot be changed to float if it has some symbols in it. So I've changed this, replaced this, and then I've used the .asType method. .asType changes the data types. So .asType followed by float. And now when I write the .max function, I get 44.25, which is obviously not present here, but because it's a head, it's just a part of the entire data. So obviously the maximum priced item was 44.25. So this is where we use the asType method. So this was all about pandas. And in the next lecture, we will be learning about a bit about Matplotlib. After having learned that, we'll move to the data cleansing process, and we'll be slowly moving forward to the EDA, that is Exploratory Data Analysis. Hi everyone. In this lecture, we'll be learning about Matplotlib, and the basic agenda that we'll be covering in this particular lecture is how to plot any graph, how to do the basic customizations, how can we plot multiple graphs in a single plot, and how to save the image as a PNG file. All right. So let's move to the topics one by one. The first thing that we need to do is we need to import the Matplotlib library. And this is how it is done. Import matplotlib.pyplot as PLT. Now I've created a dummy data having lists year and population, and the values, the number of items in both the lists are seen. Therefore, they should correspond to each other, which is a necessity. Next, what I've done is I've created a line plot. So plt.plot, it creates a line plot, year, population. What it does is it takes year to be the y-axis, year to be the x-axis, and population to be the y-axis. And then we end it using plt.show. So what we have done over here is the machine has plotted a graph with all these data points, and this is what the graph generally looks. Now, since 2000 and 4000, the reason why 2000 and 4000 has not been incorporated is the dataset range is too much, from 2000 to 40,000. So to incorporate every single data point, it has excluded them. But you do see that the data goes far beyond 5,000. So it kind of suffices for the same. Now, what are the customizations that we can do? So this was just a general graph. What if we wanted some customization, as in we wanted the names of the x-axis. Let's say, what were the names that we took? Just quickly. So year and population, right? Okay. So what if I wanted a heading, let's say population of a particular country. Let it be dash, and here let it be the year, right? So this is the year and this is the population. What if I wanted Matplotlib to plot that as well? So then comes the use of population, the customization properties. Also note one thing, here 18, 16, can population really be 18, 16? Can it be? It should be in, if we are talking about the population of world, right? If we are talking about the population of the world, we might be talking about the numbers in billions, right? We would also want them to be incorporated. Also, instead of writing 5,000, 10,000, 15,000, could we not have written 5K, 10K, and so on? So that are the things that we can do using customization. everything that we do to make our graphs look better. All right. So first thing that we do is the XY levels and title. So this is the graph that we have got. Now what we have done is plt.xLevel year. So now the bottom, the x-axis says year. Similarly, plt.yLevel population. The y-axis now says population. And plt.title as world population. So it also has a title. World population, population, and year. And this is how we do it. Remember, plt.show is a must. Have we not written it? Let's see what happens. If we do not write it, see, Jupyter Notebook will still run it, but it's always a good practice to utilize it. And it gives some weird texts out here. So we would not necessarily want that to be shown. And that is the reason we always include this plt.show. I'm sorry, plt.show. Now, what if we want this values to be changed, as I have written, 5K, 10K, and 4 billion, 6 billion? Then we use the ticks. So how do we do that? It is a method of replacing. What I've done is plt.xticks and written all the values, that is 5,000, 10,000, 15,000, up to all the values that are given, comma, another list containing the values that I want. That is 5K, 10K, 15K, and so on. Similarly, for y-ticks, I have just added the word B for billion in it. And now when I plot them, I get this particular value. We can also use this particular customizations to make the graph look more, better. Then we get a better looking graph altogether. So what if we want to resize the graph? So the first thing we would do for that is plt.figure followed by fig size equals to, and in single braces we'll make sure what are the dimensions we want. So here I have taken 5, 2. The first value stands for the width and the second value stands for the height. So now if you see, this particular graph became smaller, right? This line has to be utilized at the very beginning before you plot. So this is a sequence you need to follow. For changing y-ticks and x-ticks, you should do it before plotting, and the levels, x level, y level, and title should be done after plot. Similarly, the plt.figure, this particular line should go at the very first. And the concluding line should be plt.show. Now, what if we want to change the color or the style of the graph? What we do then is, so here I have written R dash dash, which means R for red and dash dash for a dot, dashed line. I could have also changed the color to, let's say, green. And if I wanted, let's say, star line, I could have got that as well. So there is a bouquet of colors and symbols that you would want to know. And we could get that from the official documentation of Pandas or Matplotlib per se. Nevertheless, while doing the projects and everything, we'll understand what are the important things that we do while doing hand in hand. But in case you are inquisitive about learning all the colors and shapes and symbols of the plot, you can go through the official documentation of Matplotlib. Now we could also change the line width. So had I not given this particular function of line width, I would have got thin line, or I can always increase my line width to get thicker lines. We can also include a grid by introducing plt.grid at the very beginning. So you get the grid, a grid before the graph as a background. Now we can also write multiple graphs. We can plot multiple graphs in a single plot. How to do that? It's quite simple. First, what I've done is imported the NumPy library. That is for a reason. We'll understand why. Okay, so you get the reason here only. So I've taken a range that is from 0 to 5 with a gap of 0.2. An array would be created. Now it's time for plotting. What I've done is plt.figure fig size 16,6. So it would be quite a big graph, 16,6. It should take, should be a big graph, right? Now, the first plot that I want is plt.plot array, this array, comma, array square. So the x-axis would be the values from 0 to 5 with a gap of, or a jump of 0.2. And the first plot would be a squared plot. So the next plot would be a 2 to the power 2.2, then 2.5, then 2.8, and then cube, right? What I have also done is I have used a level. That is, it would also indicate what kind of a graph it is. So for graph 1, it is a squared graph. For graph 2, it is a 2.2 power graph. And for graph 3, it is a 2.5 power graph, and so on. For the graph 4, I have used the line width to be 3. And same for the graph 5. Also, if you closely notice the colors that I have used, for the first graph, it is blue and it is a dashed line. For the second, it's red, and S means, I'm not quite certain about it. Okay, so S means a square. So I've used a square, red colored square. For the third, I have used green with triangular marks. For the fourth, I have used blue with dashed lines. And for the fifth one, I have used only a red colored line. Now, after that, I've also introduced the grid, and I've leveled the y-axis to be different powers because I'm taking different powers of the same array, and the x-axis to be numbers, and title, slope having multiple powers. Now, this is a very important line, plt.legend. We'll understand what it does. And the concluding line has been done as plt.show. See, we have got 5 graphs. The first graph is this one, which is a squared graph. And you can see this legend over here. The next graph is to the power 2.2. So we get a squared graph. The third one is a green colored triangle. The fourth one is a thicker line with blue dashed. The fifth one is a red with a thicker line, having the title and the X and Y levels, right? So this is how you plot multiple graphs in a single plot. Now, what about this particular line called plt.legend? This helps us build this particular legend. So note, if you want to have this particular legend, this is very important if you're plotting multiple graphs in a single plot. So what I've done is, instead of plotting, this is the x-axis, this is the y-axis, and this is the customization, that is blue dashed. I've also given another argument called level. And this levels would be visible here only when you write plt.legend. If you do not, let me comment it out, and then what we get is this kind of a graph without any legend. So plt.legend helps us to bring the comments that I have given, the levels that I have given over here for all the 5 graphs. into existence. All right. Now you might want in a single graph, in a single plot, you might want several graphs in different locations. What I mean by that is, let's say this is your entire page, right? And you might want a particular graph over here, a particular graph over here, a particular graph over here, and a particular graph over here. Or maybe you just want 3 graphs. So one graph over here, one graph over here, and one graph over here. Basically, the point is, in a single plot, you want different graphs as subplots. For that, what we use is the subplot method. So what we do is, okay, first understand the syntax. What we do is plt.subplot, number of rows, comma number of columns, and the figure number. So let's say I'm dividing a particular page into 4 parts, right? So what I will do is plt, okay, let me put it over here. So plt.subplot followed by number of rows. I want 2 rows followed by 2 columns, and this would be the first graph, this will be the second graph, this will be the third, and this will be the fourth. If I want to refer to this particular graph over here, I'll do 2, 2, 4. That's exactly what I have mentioned. So for 2 to 1, it's top left subplot. For 2 to 2, top right subplot. For 2 to 3, bottom left subplot. And for 2 to 4, bottom right subplot. So let's see all this in action. So what I've done is I've taken another figure with fig size 16,6 because I'll be needing a big one. I've given the title. So note over here, previously what we used to do was plt.title. But since this would be a page containing many graphs, you cannot just write plt.title because it would get confused for which graph you want this particular title. So if you want the title for the entire page, what you do is plt.subtitle, SUP title, subtitle. And I've given it to be my subplots, and that is what exactly has been printed over here. Then for subplot 1, what I've done is plt.subplot 2 to 1. Therefore, it is referring to this graph over here, right? So this is referring to this particular graph. Sorry. Now let's see what it has done. So it has done plt.plot ij for I in range 10 for j in range 1000. So what it effectively will do is the I would take from range okay, so what it would do is the I would take all the values till range 9, right, from 0 to 9. And for j, it would take all the values from 0 to 1000. Now, that is what has been plotted over here, right? There has been some sort of a mistake over here. I do not understand. For I in range 10, it should take all the values from 0 to 10, right? Why is it taking up to 10,000? While the y value has been correct, it's taking j in range 1000. Okay, let us forget this as of now. Let me let us focus on this particular part as of now. We'll figure this out later. So subplot 1 is what? plt.subplot 2 to 1. So this is exactly this graph, right? Now when you are plotting the subplot 2, that is this particular graph, that is 2 to 2, I've plotted year, population with r dot. That is, it should be a red colored graph with dot. And that is exactly what we have got over here, right? Now, what if we want to plot the third graph, that is 2 to 3, with a green asterisk symbol? So we will only do plt.subplot 2 to 3, and that is the exact graph that we are getting. And if we want to do the subplot 4, so for subplot 4, I've given nothing, and therefore I've got a blank plot. So this is basically what we do in order to get multiple graphs, that is subplots, inside a single plot. Now, if you want, you can also give the x and y levels over here for each and every graph. Let's say I just want to give the same x and y level as I have given over here, right? So what I do is, let's say I want to give the x and y levels in subplot 2, right? So what happens is, I have got this subplot, I have the x and y levels here. And since I've not mentioned anything else for the other graphs, nothing has been mentioned. Now, one important thing to note over here is, let's say we want to save this image. If you want to save this image to a given path, you know what to do. Just like exporting the, exporting the pandas file, you have to give the location. And in the same way, if you want to export it to the given live location, what you need to do is plt.savefig. This particular function remains the same, that is plt.savefig. And in brackets, you write the path name or the name where you want, by which you want to save it. And you get this particular file, my subplot. So my subplot.png. Let me delete it and show you once again. So I've deleted it. Now when I run this again, it would save this particular picture. So my subplot. If you want to open it, you will see this particular picture that you want. And now you can download it, whatever you want. You can just save this image. All right. So this was all about the basics of Matplotlib. Now we'll also learn how many types of graphs are there, what we can create using Matplotlib in the next lecture. Hello everyone. In this lecture, we'll be learning about the different types of graphs that we can draw using Matplotlib. So there are typically many more, but the most that we use using Matplotlib are the line plot, the scatter plot, the bar graph, and the histogram. The rest, we generally use other types of libraries, which we will be also learning, like Seaborn, Plotly, Express, and many more. All right. That said, let's delve into each of them, right? The first thing that we would want to know is the line plot. If a single list or array is provided, Matplotlib assumes it is a sequence of y values. Therefore, it automatically generates the x values based on the indices 0 to the n numbers, right? So what I've done over here is imported matplotlib.pyplot as plt. And I've set the figure size to be 6,2. Then plotting the y-axis. So plt.plot, I've taken only one list, 2464. It means it assumes the values of the x-axis to be 0, 1, 2, 3, 4, like that. And the y values would be 2, 4, 6, 4. All right. So when I write plt.show, it gives me this particular graph. Had I explicitly mentioned, this can also be done. I can explicitly mention, so 0, 1, 2, 3, and I would have got the same graph. Now here I have done the same thing, explicitly mentioning, creating two lists, year and population, and mentioning them as X and Y axis. The thing that we have already experienced in the previous lecture, right? So this was all about line plot. Now what if we want a scatter plot? What is a scatter plot? A scatter plot is nothing but when we have too many data, it's difficult for a line to represent them. So this data is very simple and very easy. But what if a data, sometimes line plots, and which we will be seeing going forward. Sometimes if we use a line plot, the plot might seem like this. And it really becomes very difficult to understand what is there. It genuinely becomes pretty hazy. And for that, for me to make you visualize, I need the correct data set, which we will be having when we'll work on the Capstone project. So in those cases, what we use is a scatter plot. What it does is, it gives points and places where this mesh or messy appearance occurs. For scatter plot, it is quite simple. There is a lot of points, which helps us to understand that this is the particular point which we might be interested in, because a lot of points lie over here. And typically this is what a scatter plot looks like. So for year and population, since the line was pretty simple, we have got a simple scatter plot, right? Now, what if we want to add some colors and sizes for the scatter plot? This is again often used so as to understand what are the values trying to tell us. So what we do is, we do the plotting, that is x-axis would be year and population would be the y-axis. Then for sizes, what we do is S is the keyword. S equals to population. So based on population, the sizes would increase. So as we see that, let me grab the population library very quick. Let me run the cells once. All right. Now, population. So we see that as we go up, the population increases. So for the first, it is 3.6 and the size is quite small. The last one is 18.1, which is the highest, and the size, if you notice, is bigger. So the size has been done with respect to the size of the population. Again, color, C is used for color. So C is changing with different populations. Wherever you find the same color, it means it has the exact same population. All right. So that is how we can do some customization. Each of this should be noted down by you so that while using them while performing the projects, you should not have any doubts or confusions, right? Now coming to the bar plot. What is a bar plot? So bar plot is necessarily used to plot categorical data. So what I've done over here is, I've taken the figure size to be 6,2, and I've taken two dummy datas, X and Y axis. Now X-Sticks has been done as Ankit, Hans, Joe and Flacco, right? And the color of their bars are lime red, K and tan. Now when I plot them, X, Y, and color as call this, we get this particular plot. The first one, that is 1, is Ankit. Second one is Hans. Third one is Joe. The fourth one is Flacco. So one important thing to notice over here is bar plot is used for categorical data. It does not take two values into account, unlike the line plot or the scatter plot. So the x-axis has typically no usage. So 1, 2, 3, 4, 5, 6, 7, 8 doesn't really matter. And it is generally used for categorical data. That is here, as I have mentioned, Ankit, Hans, Joe, Flacco. Let's say you want to plot a graph for the marks different students in a particular class have got. And in that case, you would want to use a bar graph with y-axis being the marks and x-axis being the names of those persons. So this was all about bar graph. The next, we come to the histogram. Histogram is nothing, but it has certain bins. Bins are used to understand the dynamicity of the data. So here I've taken pretty much number of values, right? And I've plotted this particular value as pld.hist values. So these values would come into existence, followed by bins. And it's my wish how many bins I wish to choose. I have chosen 5 bins. So this is the first bin, this is the second bin, this is the third bin, fourth and fifth bin. Necessarily, by default, if I do not want the bins argument to be there, by default, it chooses how many bins should be there based on its intelligence. But it might be so that we do know, or there is a particular requirement of this number of bins. In that case, we generally give the number of bins that we want. So let me give 4 bins. And this is how the numbers, all these numbers, are divided between the bins. How do we use that in practical real-life scenario? We will come to that while performing the project, right? So these, all the 4 types of graphs, namely histogram, bar graph, the scatter plot, and the line plot, and their init functions like color, size, changing, and everything should be understood well enough so that when it is used the next time, I do not need to go in depth, right? That said, it marks the end of this particular lecture as well as Python for data science. In the next lecture, we'll be learning how do we manipulate or eradicate missing values. We'll be learning more about data cleansing and gradually moving towards the EDA process. Hello everyone. Now that we have already learned about the basics of Python and advanced Python, the type of tools and everything, libraries that we use for data science, we'll be slowly progressing and moving towards how we perceive data, how we work throughout the entire data set. Now to do that, the first and most important thing we'll be working on is missing values. So let's understand what these things are. Now, missing values, as the term suggests, are values that are missing from a particular data set. For example, a data set that we have already seen in a tabular fashion might contain several names. So let's take an example name and their telephone number, an example of telephone directory, right? So it might happen that there are several names amongst which number of certain people is missing. These values are called as missing values. So is there any problem if we have missing values? definitely the basic thing, if we have missing values, we have some missing data, and that is a problem. But more so as we go on to perform any statistical operations or let's say machine learning operations, these missing values may cause serious harm and affect our models severely, right? And that is the reason we need to remove them whatever way we can. Now, they may occur. The reasons of having some missing values might be that there is no actual data, or the data has been missing due to lack of information, and there might be several other reasons for that. So let's understand what might be the possible reasons. The first thing that is possible here is, it might be so that some participants refuse to answer some of the questions, some or all. They might not know the answers. That is one possible. And it is also possible that they might have skipped any answer, or there is some error due to data entry. So these are some possible reasons why the missing values occur. Now, the problems, as I already explained, is that it might severely affect the accuracy of a machine learning models, and henceforth also cause problems for the statistical operations. So there are basically three types of missing values. One is MCAR, which stands for missing completely at random. These are some values which really have no relation with the data whatsoever it is. While on the other hand, the second type of missing values is MAR, that is missing at random. So these missing values might have some relation. So what is MCR? No relation whatsoever. No relation with the other data present in that particular column. And for MAR, it might have some relations. So relation is present. And there is another thing called as MNAR, which stands for missing not at random. So it was missing completely at random. This is missing not at random. Here, these are the best. Firstly, having missing values is a bad thing, but going forward, you would understand that you will have missing values whatsoever. It's very unlikely that you do not have any missing values if you're working in proper real-life data set. So these are perhaps the best type of missing values that actually has some specific relations with the data size. Right? Now, let's understand one important thing. When we have MCAR type of missing values, the problem here would be that in most likely cases, you would need to delete those missing values. So we would want to delete these values. Why? Because, see, deleting is the worst possibility that we might use. But normally it has been seen when there is perhaps no correlation with other data. There is no way of including or manipulating those missing values, and therefore we choose to delete those missing values. In case when these are MAR, that is missing at random, there is perhaps some relationships which might be linear or some other form. And in those cases, we might want to perform some logical operations. We are not sure of what logical operations we might use, but it is possible to use some logical operations or imputations. We'll learn all these terms in detail. And several other operations, maybe statistical operations or something like that, to get into a proper form of that missing values so that we can replace those missing values with other values, possible values. But at times we also, when go to deleting, because sometimes we are unable to actually replace those missing values. But in case of MNAR, that is missing not at random, there is always some specific relations present. And due to this specific relation, there are several operations that we can perform, mainly statistical operations. And therefore, we choose not to delete those missing values. We do not delete these missing values, but we impute or cover them using statistical operations. So this was all about the types of missing values that we have. As I already mentioned, there are mainly 3 ways of handling missing values. The first is to delete them. Next is to impute the missing values using some business logic, which we will be coming to in the lab sessions. And the next is imputing using statistical operations, precisely using mean, mode, median, etc. Right? Now, some important things that we should know about deleting a missing value. So, as I said, deleting a missing value is not perhaps the best option. It is perhaps the last thing that we resort to. So, how do we do that? Some of the problems that it might let us encounter is that it leaves us with a relatively small data set. So, one thing very important is the bigger the data set that you have, the best, right? So bigger data set is the best data set. And the more and more smaller we go to, it's the worst possible scenario. Why do I say so? Because bigger data gives the machine to learn well. It allows the machine to properly estimate or forecast the future proceedings, while smaller data set does not allow that. Also, the data change quite frequently, and it's very difficult for a machine, or let's say a human, to understand the changing trend, while a bigger data set shows some stability in that. Therefore, deleting converts a bigger data set into a smaller data set, and therefore we would want to exclude that. But at times it leaves us with no options other than deleting it, so therefore we resort to deleting such data. Now we can simply delete the columns or rows where the percentage of missing value is very high. So let's say we have a very big data set, but the percentage of missing value, let's say, as I said, let's say we have a telephone directory of name and telephone number, right? And let's say we also have age, right? We also have a column called age. Now, what if the age column, and let's say the total size, the number of rows is 1 million. Now, let's consider this, the age has total number of missing values to be 0.5 million. Then is it would the data of 0.5 million missing values for age column give us any benefit? No, right? Because every alternate times we would not know the age. So what's even the use of taking such a column? And in those cases, what we do is we just completely delete that particular column. So now the data would be consisting of name and telephone number. and the age column would be completely wiped off. So in general cases, when the data is large and the column has 30 to 40% of missing values, we delete such columns. If the size is approximately 30 to 40%, depends. The range is approximately from 30 to 40%. At times, it might go even to 50 or 60%, but it totally depends. Now, when the data set is small and the column has approximately 20% missing values, we choose to delete those columns because small data sets have very high impact. And therefore, if the missing values is about 20%, we choose to delete such columns. However, these rules are not permanent. They vary from different scenarios. And that is what we will be learning, how to understand, how to use business logic and how to delete based on those numbers. It's not pure, it's not a given rule that if the data set is 40%, if the data set has 40% missing values, if a particular column has 40% missing values, we chose to delete it. It's not like that. It's a general trend that we use, but then it totally depends on what we want to do. The aim here is to get a proper prediction. And for that, we do whatever it is necessary. At times we go to the subject matter experts to talk to them how much important a particular column is. And there are several other things that we will be discussing while we'll be moving to the proper Capstone project. Now, this is something that we might also use business logic to impute missing values. Business logic is simply a technique where we rely on business implications or business understanding for solving a problem, instead of using traditional or sophisticated ways of solving the problem, like use of statistics. So we prefer not to go to the classical ways of using statistics or any mathematical operation, but we choose to understand the business and what those columns or the data entails. And based on those things, we choose to work on the missing values. Now let's understand this with a very good example. So let's assume we are doing a rating analysis of a product. Like, say for example, we have an e-commerce, let's say Amazon, which is quite a famous e-commerce platform, right? And various of dealers list their products in Amazon. So let's say one such product B, let's say, okay, let me take a very classic name, XYZ. XYZ is a company which is selling, okay, let's understand with the, okay, fine. Let's see that there is a company called XYZ which is selling a particular product. What is the product? Let's say it is cooking, some cooking utensils or stuff, right? Now, if there are different customers, right? Customer names. So let's say A, B, C, and so on. And there we have XYZ ratings. Let me take the, let's say there's a company called XYZ which has their customer names and their ratings, right? So let's say the customer names are A, B, C, and several more. And let's say A has given 5 stars, B has given 1 star, and C has given, so let's say we have only 3 customers to understand this particular problem, right? Now, let's say A has given it a 5 star and B has given it a 1 star and C has not given any ratings. These are often conditions that we come across, right? Now, you being a customer, you want to purchase this particular good. What should you do? Should you purchase from XYZ or from any other company based on the ratings? The first problem that you would see is there is lack of data. Only 3 customers has given ratings. So how would this help you? Had the data set been bigger, it would have given you a genuine understanding of how good the product is, right? So we always prefer a bigger data. This is the first thing. Second, how would you really understand the product is good or not? Because one has given the extreme good rating, another has given the extreme bad rating. It might be so the product was extremely good and we somehow had a very bad experience with it, or maybe the delivery went wrong or something like that. Or it may be the other way around, that the product is genuinely bad and A is just a paid reviewer for XYZ. So in this case, if the rating of C is missing, should we take an average of both? That is 5 plus 1 by 2, 6, 3. Should we take 3? It gives us no sense, right? We should not do that. So what we need to do in that case is, we might want to delete the missing value. So we would want to delete this particular row. Or what we can do instead is, we can impute it to, let's say, some negative number, -1. Now, several of you might question, -1 is even a bad rating than 1. No, the rating starts from 1 to 5. So -1 is invalid. Why do we use -1? We will then program the machine in such a way that whenever you see any negative value, please exclude those values. So instead of deleting, we could impute them with some unregistered values. So this is also a way we would want to impute values. All right. So this was using business logic in a typical way. Business logic is something that cannot be, there are always methods, there are some examples that can be taught, but there are, when you get to the industry, when you start solving real life problems, you would come across innumerable business logics that you would want to apply. There might be mix and matches of everything, maybe statistics, mathematics, and everything. This is one typical example that I gave for your understanding. That said, we also have some imputations based on statistical functions, mainly mode, median, and mean. So all these things we will be coming across. So for beginners who are not familiar with these terms, mode is basically the maximum occurring value. So where in a data set, there are several values occurring. Let's say the same example that I gave, let's say we have A, B, C, right? D, E, and F. And A has, let's say, given the rating 5, B has given 1, C has not given, D has again given 5, E has given 3, and F has given 4. So if you want to replace C, the rating of C, by mode, we would want to replace the rating with the most occurring rating. So here the most occurring rating is 5 because 1 has occurred once, 3 has occurred once, 4 has occurred once. However, 5 has occurred twice, and therefore the mode is 5. So we would want to replace it with 5. What is median? Median is when we arrange this particular data in an ascending order. That is 1, 3, 4, 5, and 5. Median is the middle. The middle data is called the median. The data which occurs at the middle when the others are arranged in an ascending order. So this is the median. And mean is the average, that is we take the average 1 plus 3 plus 4 plus 5 plus 5, which gives us 18 by 5. So this would be the average or mean, which is roughly about 3.6. So this is the mean. So based on dependency and based on the requirement, business requirement, we choose the different statistical imputations that we would want to do. Now that said, let's move hands-on and see how do we use all these things in practical scenario. All right. So I hope we are all good to go with the basic understanding of Python tools to use whatever functions we want to. In this case, I won't be making you understand things in the tools in detail because we have already done that. If you have any problem, please go back and refer to those particular sessions. Here I'll be making you understand how to go forward, how to understand data and how to treat or handle missing values. So the first thing we would be doing is checking the missing values with respect to rows and columns. So let's say I have imported a particular data set, which is a data set of FIFA. Right? This is the particular data set of FIFA. And what I see over here is it has 5 rows. I'm sorry, since I've used head, I'm getting 5 rows. Let's check how many rows are actually there. So basically, there are 18,207 rows and there are 89 columns. First is ID, then name, then their age, then we have the link for their photos, nationality, flag, overall how many goals they have done, scored, potential, the clubs they have been playing for, and several others, right? Now, what we would necessarily want to do is initially, soon after getting the data, make a habit to check for any missing values if present. So to check for any missing values with respect to rows, what we do is we use the function data.isNull. So data.isNull gives us the entire missing value list. But for rows, what we do is data.isNull.all. I'll be explaining what this all stands for. Axis equals to rows. This is the important thing. Axis is equal to rows. And for columns, we use axis is equal to columns, followed by .sum. All right. So what happens over here is, .all, it means, okay, let me make you understand by painting it over here. So let's say, again, I have this particular data set. I have this many rows, columns. Now, and these are the rows, right? Now, what if a particular row has, the entire row has missing values? That is, not a single column, the values for any column is present. Let's say this is name, this is age, and this is profession. And for this particular, let's say this is the 71st row, and I do not have any name over here. Neither I have any age present. I also do not have the profession present over here. So the entire row is blank. And to get to any such data, we use the .all function. So data.isNull.all. Similarly, I use axis is equal to rows to get through axis. What if I also have a column, right? I have a column, let's say hobby. And in that column, I have the entire column is missing. Entire data for the column is missing. No data. All the values are missing. In that case, we use the same to understand those kind of data. We use access is equal to columns. In these cases, what we do is we straight away delete. Because if a particular row has no data, it's better to delete those rows. Same goes for columns. If a column has, the entire column is missing with data, we choose to exclude those data from our consideration. Now, there might be some rows where a particular data is missing. Let's say name is missing and age and profession is given. To get through those rows, we use the same function data.isNull.any. So here we use .all and here we use .n. And same for columns and access, rows. For rows we use access is equal to rows, and for columns we use access is equal to columns. Alright, so now the FIFA data that we have got, I'm checking for any rows and columns which is entirely missing. So I found none of them is entirely missing. No rows has completely 0 values or columns has 0 values. So the missing part is 0, which means no rows is completely missing or no columns is completely missing. Now when I get through any, the function any, I see that there are some rows. Since it says false, I find that there are some rows which has some missing values. So the data is not perfect. It has rows with missing values in it. Right? So the conclusion that we derived from here is no rows or columns has all the values missing. Some row have at least one missing values since it says false. And all columns, since it says true, since it says true, it says that is null is true. That is, there is some null values present. So some rows have at least one missing value and all the columns have at least one missing value. Since for columns, it says that the only value is true. There is no false. That is, no column is perfectly filled with data. All the columns has at least one missing value. So now, doing a more deep diving into the missing values with respect to rows and columns, what we see over here is, these are the rows that have the missing value present. So what I have used here is data.isNull.sum access equals to columns so that we get through all the rows. Mind you, when I use access is equal to columns, what happens is it takes the column wise operations. Therefore, all the rows are shown. So it shows us that these are the rows which have missing values in it, and I have chose to sort it based in a descending order. So the maximum number of missing values for a particular row is 75, which means out of 89, there are 75 missing values, which is far more than our 40% mark. We should be deleting all those values. Right? Now, since we cannot see all the values because not necessarily Python shows us all the values. Now, if you want to see all those values, there is an option for that as well. But let's understand what we do with this particular value first. So what I choose to do over here is, let's also find out how many rows are actually having those. We find out the number of rows. Now let's check for the number of columns that have missing values. So here we did the same operation and now access is equal to rows for the same reason. And we find that there are some columns which have more than 16,000 missing values. And these are some columns that we would want to get rid of. So one of the conclusions that we have got from here, the maximum number of null values present across our row is 75, as we get from here. The minimum is 1, right? So the minimum is 1. And across the columns, the maximum is 16,943 and the minimum is 0. So there are certain columns which has no missing values. Now, as I said, the total number of columns here is 89 and the max number of null values present across the row is 75. So the maximum number of missing values that we can accept is 35, which is 40% of the 89. Right? So what I mean over here is, so the total number of rows was 89 and the maximum that we can actually take, the maximum number of missing values as per the rules is 40% of 89, which comes to be approximately 35. Here, the number is way more, 75, almost double. That is 80%. Therefore, what we do is we choose to drop those columns or delete those columns. So what I have done over here is I've taken data.isNull.sum access equals to columns, therefore, which means that all those values with missing values greater than 35, please delete those values. That's what I have done. Now, when I pull over the data again, I see that the maximum number of missing values now is 48, not more than 48. All right. Now what it says is, before deleting the number of rows, I found the size of the number of rows to be 18,207. And now when I have deleted the number of rows, I find the shape to be 18,159. Therefore, a total of 18,207 minus 18,159. This value has been deleted. That is a total of 48 values has been deleted as such. All right. So these are basically the number of values that has the columns that has been deleted. All right. Now treating the missing values by deleting columns. So what we do over here is we see how many missing values are there. Now when I write data.isNull.sum, I get a 0, 0, 0 all over. And here this 3 dots shows that there are several columns embedded in between. Now to get access to all those columns, since we already know that there are 89 columns, what we do is we use this particular function called pd.setOption. PD stands for pandas. So what we do is pd.setOption followed by max rows, 89. Here we put the value of the number of columns. And we get the entire 89 columns. Right? So what we see over here is, there are club having 241 missing values. These have really less number of missing values, but columns like loan from has 16,895 missing values. These are certain columns and also these columns. Okay, these are okay-ish columns, but loan from has 16,895 columns, which are columns with values which are missing. Therefore, this is a column we would want to delete. And therefore, what I have done over here is I have chose to delete this particular column. But before that, what I've also done is I've taken a table, a tabular representation of the percentage of missing values with respect to the columns. So what I've done is I've taken X to be the total number of missing values. So data.isNull.sum. Then what I've done over here is I've taken a percentage of the missing values. So what I've done over here is I have divided X. Okay, so let me make you understand this as well. So X is basically the number of missing values. Right? How do we get through the number of missing values? We use the function data.isNull.sum. Now, I also wanted to take another column where the percentage would be shown. Let it be termed as Y. So Y would be X divided by the total number of values, right, into 100, which gives us the percentage. So that is exactly what I have done. X divided by data.shape of 0. 0 gives us the total number of values, that is rows. If you remember, shape gives us rows, columns. So I've taken the function shape gives us row, columns, and shape of 0 would give me the number of rows. That is exactly what I've done. X divided by shape of 0 to get the total number of values into 100. That is exactly what I have done over here. Now I have taken a dictionary by giving header, number of missing values is X, percentage of missing values is Y, and then I have changed it to a data frame. And then I have chosen to sort those values by the percentage of missing values. And this is exactly what I have got. Loaned from, all right, number of missing values and not loaned from, sorry. This is the index that have come to place. So these are the values of all the columns. These are the total number of missing values, and this is the percentage of missing values. So now what I see over here is loan from has a 93% of missing values. All the rest have somewhat 11%, then coming to 8%, then 1%, and then less than 0%. So straight away, I need to delete the loan from column. I could have done that from seeing over here only, since I saw 16,000, which is too great. And I know the total number of rows we had was 18,000 or something like that. But this is again a very good representation so that you understand how much percentage of missing values the particular row is having, the particular column. So the next step, what I have done is I have chosen to delete this particular column. So as per the conclusion, we see that the loaned from column has 93% of missing values, and therefore it is better to delete that particular column. So what I've done is I have dropped that particular column. Before, the number of columns were 89. Now it is 88. Now what I need to do is I need to treat the missing values with business logic. Correct? Since there are certain columns having 11% of missing values, there is also columns with 8%, 1%, and also less than 0%, but we need to completely get rid of all the missing values. That is the best possible thing that we can do. So what I've chose to do over here is I've chose to include some business logic. The first thing that I've done is I've taken out their data types. So data.dtypes is the syntax for it. Now on getting the output, I'm seeing that everything is an object data type, that is categorical, except jersey number, which is a float data type. Right? So the conclusions say that all except jersey number are categorical variables. It is illogical to impute the missing values of the players who has missing value in jersey number using statistical functions. So let's impute the missing values as NA. What I mean over here is let's say there are 5 players, right? Just giving you an example. There are 5 players. Among them, 2 have the jersey number 10, right? Let's say Messi for Argentina and Neymar for Brazil have jersey number 10. Then we have Cristiano Ronaldo with 7. Then let's say we have Iniesta with 6. And the 5th one, I do not know his jersey number. So what should I take? Should I take the mode? Should I take it 10? Would that be a good choice? Or should I take the average or something like that? See, in this kind of scenario, this is again business logic. I can never use any statistical or mathematical or any such operations. Because jersey number is an identification number. It's like a telephone number or an address. We cannot take the average or the mode. Since the most number of food has been ordered from, let's say, a particular address, we cannot say that if we do not know the address, let's go to the particular person's house and deliver the food over there. And therefore, what we choose to do is, we choose to give a NA that is not applicable over here. So although it won't be entirely accurate, the next thing that we'll be doing is changing other missing values with, or rather imputing other missing values with proper values. So what I've written over here is, although it won't be entirely accurate, the following 5 categorical values can be filled with the respective modes. So what I mean over here is, I'm imputing the missing values for clubs, positions, the date of joining, contract validity, and the release clause with the modes. Again, this is not something that you would want to do in a real life scenario. But here in this particular data set, since we are limited with the information, right? We do not have any more information what to do with the data. We are choosing to use mode to, kind of accommodate for those particular missing values. If we do not do that, we would be ending up from a very huge data to a really small data. And that is the reason I'm choosing to use certain operations to show you at least. But let's be assured, it's not what we do in real life scenario. In real life scenario, we have more and more information. We need to do a proper research before providing with any such operations. Now what I'm also doing is, the remaining columns of the dataset have missing values are the scores of different positions of football players. So if we have any missing values here, it is probably because the player do not play for that position. So as I said, I'm taking the particular position to be the mode. So let's say the position of Messi was not mentioned and I had the data set of a lot of defenders. Now, would it be ideal for me to say that Messi is also a defender? It won't be, right? And that is the reason when it comes to this particular field of providing with the number of goals scored, if there is no goals mentioned, I'm keeping that to be a 0. And that is probably because that particular player might not play for that particular position. So it makes complete sense, right? Now let's work on all these 3 things one by one. The first thing that I'll be doing is I need to replace the jersey number with NA. So what I do for that, data of jersey number dot fill NA. It fills all the missing values. Fill NA is the syntax that we use. So fill NA by NA or whatever you want to write. So I wanted to write NA over here. That's why this is what I have done. And in place is equals to true means it would take the data permanently. So I've now converted all the missing values with NA for the column named jersey number. Now filling the missing values with mode. So club, position, joined, contract valid until, and release clause are the columns that I want to fill with the mode, right? That's what I've done. Then for missing values with the goals scored in several regions, I have choose to fill them with 0. So I have taken time. This takes a huge amount of time. I've taken time and compiled all the columns that can be filled with 0 and fill them with 0. And now what I see over here is the number of missing values is now entirely 0. I do not have any more missing values. So the data set that was given to us, right? So the data set that was given to us, it had a lot of missing values. Let's say these are random missing values. I had chose to delete some. I had chose to impute some using statistics, and some others using business logic. By performing all these transformations, what I've got is a relatively similar type of data set. Obviously, the size has been reduced by a bit, but now there is no more missing values. No missing values. Therefore, this data that we have now can be used to do all types of machine learning predictions and forecasts. Right? So this is how we go about working with missing values. So these are parts that I have taught you. There are several other ways to use that. Typically, these are kind of things that we use. One is deleting, another is using statistics, and business logic is a variety. It includes a lot of things. I have included some of them now. With working with other dataset, we'll be using others as well. But this was the entire basics to how we operate using missing values. In the next session, we'll be learning about outliers, which is again an important part in data cleaning process. So yeah, that's it. That's all for today. Bye guys. Hi everyone. In this lecture, we'll be learning about outliers. So what is an outlier? Outliers are values that lie long way outside the other values. So let's see an example. Let's say we have people pursuing BTech, right? So we do know that the people who pursue their career in BTech are aged between 7 to 24. That's an approximate age, right? Now, so what should be the average age? It would be nothing but around 20 to 21, right? So what if someone of the age 50 starts doing an BTech? This particular value, 50, would then be considered as an outlier. Because if we start mapping it in the form of a graph, we'll see that the values lie between 7 to 24, right? Now, a certain value lying at 50 would be considered as an outlier, and this particular value might have drastic effects on the different forecasts or predictions of the machine learning model, and therefore this outlier needs to be taken care of. And this is all we'll be learning in this particular session. So what are the different sources of an outlier? There might be some sources, entry errors in data. There might be measurement errors, or maybe some experimental errors. There might be some sampling errors, or natural occurrence. Natural occurrence as in a person pursuing BTech at a very later age. So that is possible, right? Now, the different problems that come across with outliers is first that it has drastic effects on statistical analysis. It also affects the mean and the standard deviation highly. In short, outliers can induce a state of confusion in the predictive models, which can make the model very weak for decision making. Therefore, the removal or treatment of the outliers is very important. Now, basically, there are two types of outliers. The first is called as univariate, and second is known as the bivariate. For univariate, there are singular points which act as outliers. And for bivariate, the points are generally described via a graphical two-axis graph where there are two variables plotted against each other, and they collectively act as an outlier. All right? Now, there are several methods to handle an outlier. First is just by deleting them. Second is we can cap them. What is capping? So capping is basically replacing the outliers to a near value so that we can keep the points in our analysis, and also it does not skew the data. So let's say there are different points all over here, right? The maximum point lies over here. And since there are 2-3 points outside a certain, threshold, what I can do, let it be 10K and the highest point be 20K. So what I can do is this 3 points can be capped to 10K itself. So technically there is a mistake in the data because, say for example, I'll give you a very good example. Let's say we are doing an analysis of the salary of a particular family or a group of friends, right? And let's say someone very rich. So let's say the average salary ranges from 50,000 to 70,000 per month. And let's say there is a group of 10 friends, right? What if another friend joins in who has got a real good job, having a salary of, let's say, 3 lakhs per month? So do you understand how much more the average salary would increase to? Which is definitely an error. Now, in order to correct it, we might want to delete this value of the friend, or what we can do is we can cap this particular 3 lakh value to, let's say, 70K, so that we get a fair about analysis. Another way is imputing using some of the statistical methods or mathematical methods. And another important method is binning. We can bin different numerical values to categorical values, such as ranges like 20 to 40, 40 to 60, etc. So in that case, when we change it to categorical bins, we exclude the machine to cause any such errors due to the anomaly of outliers. All right. So now we'll be moving to the lab session to see what's there in store. So let's understand what are the criteria to identify an outlier. To identify an outlier, the first thing we need to know is what is an IQR. So the first thing is that we need to know what median is. So let's say there are 10 data. Let's say, okay, let me assume 5 random data, 1, 3, 4, 7, and 5. How do we find the IQR? So first what we do is we arrange them in ascending order. It would look like 1, 3, 4, 5, and 7, right? This is the median, which is the 50%, 50 percentile. So the median or the 50 percentile is 4. Similarly, we can calculate the 25th percentile and the 75th percentile. So the 25th percentile, 50th percentile, and 75th percentile are the data that we would want to work with. Even if you remember in Pandas, the describe function had them listed, the 25th, 50th, and 75th percentile. Well, not necessarily it mentioned 50th, it mentioned median, which actually means 50th percentile. Now, what we need to do is this region, right? This region is called as IQR, that is interquartile region. This is known as the first quartile, that is the 25th percentile, and this is known as the third quartile, that is 75th percentile. All right. So by subtracting the values at the 75th percentile, that is third quartile, with the values present at 25th percentile, that is first quartile, we get the IQR. Now, how do we locate the outliers? So now what we do is we take a long value, which is 1.5 times the IQR. So what happened here is, this is the 50th percentile, this is the 75th percentile, and this is the 25th percentile, right? Now what we do is, we now know the value of IQR. So what we do, 1.5 into IQR, which gives a particular value. What we also do is, here 1.5 into IQR to the left side. That is first quartile minus 1.5 into IQR. It forms the least value that should be acceptable. Any values outside this should be considered as an outlier. Also, third quartile plus 1.5 into IQR gives us the maximum acceptable value. Any value to the right of this particular value would also be called as an outlier. All right. Now, this is one way of understanding or getting hold of all the outlier values. Once we take into account the outlier values, we can work with them. So there is another way of learning what are the outlier values. This is known as using the z-score method. So if the data points lie outside 3 standard deviations, I hope you all know. So if any value lies beyond or outside 3 standard deviations, then those values shall also be called as an outlier. Now, how do we do that in terms of programming? These are all mathematical concepts that I have taught. Now, let's understand the same using the programs, right? Okay, one important thing is we can also identify an outlier using scatter plots and box plots, which will be taught in the next session. All right. So now the first thing that we'll do is detecting outlier with the help of a z-score method. So z-score is basically finding the standard deviation. How do we find a standard deviation? We take the mean. We also take the standard deviation. Now what we do is we take each value and subtract the mean from it and divide it by the standard deviation. This happens for all the values. We take the summation, right? And we do not take the summation over here. We divide each value. We take the difference of each value with the mean and divide them with the standard deviation, and the values which go beyond the particular threshold. Any value that goes beyond a particular threshold, here the threshold is taken to be 3, that is 3 standard deviations. We term that as an outlier. So the process is very simple. Take the mean, take the standard deviation of the data set, then compare each data by this particular mathematical formula x, that is the observation point minus their mean divided by the standard deviation. And if this particular value, let it be termed as z. So if z is greater than 3, call it as an outlier. Else, these are not an outlier. So that is exactly how we write the program. So what I've done over here is I've taken a list, calling it as outliers. I've defined a function with data as the argument, and I've taken 3 as the threshold. So mean is np.mean, and standard deviation, we have a function for that as well, np.std. Now what I'm doing for I in data, that is considering all the data in the given list, this particular data list. This I have not explicitly defined as of now, but I'll go and define. Any data that I take over here would be reflected for all these data points. So for I in data, z-score equals to I minus mean, that is the observation point, minus mean by standard deviation. So this particular formula exists, right? If np.absolute of z-score, absolute means, let's say it gives me 2.1. 2.1 absolute value would be 2. 2.9 absolute value would be 3. So that's how absolute works. So if np.absolute is greater than the threshold, then what I need to do is I need to append that particular value to the outliers list. And in this way, I'll get hold of all the outlier values. So now I call the function detect outlier followed by the data set, this particular data set. And here I found the outliers are 102, 107, and 108. So this is a process wherein we find the outliers using the Z-score method. What if we want to find the outliers using the IQR method, which is also used in the box plot visualization technique, right? So what we do over here is, first we create two variables having the values of the percentile 25th and 75. So this is Q1 having 25th percentile. I also take Q2 having 75th percentile, right? That's what I've done. So it takes the value present at the 25th percentile, and it also takes the value present at the 75th percentile. So I've also printed it for the understanding, Q1 and Q3. So it's 12 and 15. So basically this is 12 and this is 15, right? These are the 25th and 75th percentile. Now IQR is basically Q, this would be Q3, not Q2. You can take any value you want, but generally since it's quarter 3, it's taken as Q3. So IQR would be Q3 minus Q1, which in this case is 3. So I get this particular region of length 3. Now, I also have to put into account the upper bound as well as the lower bound, right? So the upper bound would be 1.5 into 15 plus 15. So 1.5 into 15 gives me 4.5 plus 15 gives me 19.5. Similarly here, 1.5 into 12, which gives me, I think 2.5, right? Not 2.5. How much is 1.5 into 12? Okay, so it's basically 12 minus 1.5 into 12, right? I'm really sorry. It would be 1.5 into 3. So which gives me 4.5. So 12 minus 4.5 gives me 7.5. Is always 1.5 into IQR, right? 1.5 into IQR. So what I get over here is the least value that I can take is 7.5 and the maximum value that I can accept is 19.5. So that's exactly what I have done. Lower bound equals to Q1 minus 1.5 into IQR. IQR is basically Q3 minus Q1. And upper bound is Q3 plus 1.5 into IQR. Which is, so IQR is 3, upper bound is 7.5 and lower bound is, upper bound is 19.5 and lower bound is 7.5. Now all this in place, I get the figure kind of like this. This is 15, this is 12, this is 19.5, and this one is 7.5. So no value should lie beyond this particular range, 7.5 to 19.5. So that is the function that I've written for I in data. If I less than the lower bound, which is in this case is 7.5, or I greater than upper bound, in this case, which is 19.5, outliers.append I. So what I do is I take all those values inside the outlier library, the outlier list. Therefore, I get the same output again, 102, 107 and 108 as I have got earlier. So these are basically the two ways of finding outliers. One using the Z-score. Second, using the technique of IQR. Now in the next session, we'll also see how do we use box plot for finding the same. And we'll also see how you use scatter plot to find the same. And we'll also understand how we deal with this outliers. All right. So that's all for this particular session. Hope to see you in the next one. Hi everyone. In this lecture, we'll be learning how do we get access to finding the outliers using visualization methods, predominantly by box plot and scatter plot. We'll also learn how do we use and handle the outliers. All right. So for that, what I have done is I have imported a particular data set called Bigmont dataset. So exactly this is what I get over here, right? Now, what I'll do is first, I need to understand the univariate outliers. For that, I use the box plot. So how does the box plot work? It's the same concept that I have taught in the previous session using the method IQR. So this is how a box plot looks. It has two regions, the 25th region, the 75th region, Q1 and Q3, as well as the median. And this entire range is called as IQR. And here it has the upper limit, which is 1.5 times the IQR, and the lower limit 1.5 times the IQR. Now any value lying beyond it are called as outliers. Alright, Q3 plus 1.5 into IQR, Q1 minus 1.5 into IQR. Now let's create a box plot and learn the same thing. So what I've done over here is I've created a box plot. This is basically creating several, I've done the basics, that is created the figure size, then creating a subplot, right? So it would take 4 figures in a particular row. Now what I've done is I've taken into account 4 columns. One is item width, second is item visibility, right? First is item width, second is item visibility, the third one is item MRP, and the fourth one is item outlet cells. Now I have drawn a box plot for all the 4. The syntax is very simple. So I've used the Seaborn library. How do you use that? Very simple. Import Seaborn as SNS. Matplot doesn't really have the box plot library in the box plot graph. So we use Seaborn instead. So it's very simple. We write import Seaborn as SNS. SNS is the alias that we use. So now SNS dot boxplot followed by data of the given column that I want. So here I wanted item weight, here I wanted item visibility, item MRP, and item outlet cells. I'm also given a title, which I've already taught. Subtitle, that is the syntax that we use. So while drawing all the 4 figures, what I've found is item width is good to go, no outliers present. Item visibility does have a lot of outliers? It does. Again, item MRP is good to go. So these two are good to go. Item outlet cells also has various number of outliers, right? Now let's check the same using bivariate operation. That is a scatter plot. So what I'm doing right now is I'm using a scatter plot. The syntax is very simple. SNS.scatterplot, and you just need to give the x and y values. So for x values, I have kept item outlet cells, that is this particular column, fixed every time, and the x values I have changed all the three columns one by one. So item weight for the first, item visibility for the second, and item MRP for the third. So understand what I'm doing. SNS.scatterplot, y equals to data of the particular data that you want to give. Here I have taken the fourth column, item outlier cells, and x I'm changing each and every time to understand how the outlier works. Now you could have taken y-axis, the y-axis with any column. But why did I choose this particular column? Because I felt that firstly, you should choose between item visibility and item outlet cells, because these are the two columns having outliers. Now between them, I chose this one because it appears to me that the outliers can be capped, because the outliers reduces as we go towards right. So that is the reason I chose this to be a stable y-axis each and every time. You can do your permutation and combination and see for yourself. So the first thing that I'm seeing over here is this item weight. Does it contain any outlier? Although here item weight says it has no outliers, while doing bivariate analysis, I can see that there is certain outliers present, right? Even for item visibility, here it says there are a lot of outliers, which typically is there. But again, the number of data is huge in it, right? Even that can be seen from here as well. Although these are outliers, there are a huge number of data that are outliers and are pointing to the same mark. So would it be a good decision to delete it or work with it? I think we should let it go. Even that is clear from this particular graph as well. Item MRP also has some outliers. And here it shows no outliers as well. So let's understand the conclusions. In the univariate outlier analysis, we see item visibility and item outlet cells only have outliers. Now the outliers for item visibility, that is this particular section, falls over a range of 0.1. That is from 0.2 to 0.3, right? From 0.2 to 0.3. These are the only outliers. So which can be ignored. That's what I said at the very beginning. Since the number of points is huge, as well as the range is very small, we can ignore to work with this kind of outliers and let it be in the data set as it. But for item outlet cells, the outliers is pretty huge and ranges over a huge value. Say for example 8,000, not even 8,000, somewhat below for 8,000. Let's assume to be 7.5 thousand, 7,500. To 10,000, not even 10,000. If you see this particular graph, you would see it ranges up to 12,000, even more. So from 7,500 to 12,000 is the range, and the number of data points is becoming pretty low as we go up. So what we can do is we can either delete or use the other things that we have already learned, that is deleting, capping, imputing, or binning. We'll be learning all those operations in other case studies that we do. But here, I'll just use capping because that seems the most legit operation that we can do. So what I've done over here is, I've found the maximum value, which appears to be 13,086. And now what I've done is, since I feel that 10,000 is a good restriction, so if I was asked, I would have restricted to 8,000. But for the sake of data preservation, what I've done is I've taken the limit to be 10,000. So what I've done over here is data of item outlet cells dot values. And I've changed this, all the values greater than 10,000 to 10,000, which means the maximum, which was 13,086, and also there were several values present beyond 10,000, is now capped to 10,000 only. And that is exactly what I see over here. So previously the maximum values was 13,086. Now it is 10,000 since I've capped the value. So this is one way of treating the outliers. As we move to different case studies, we'll see other methods as well. So yeah, that's all for this session. In the next one, we'll take a particular data set and work all the way from treating mixing values, outliers, and everything. We'll clean the data set from scratch. So yeah, that's all for today. All right, everyone. In this session, we'll do a deep dive into data cleaning using the Naukri dataset. The one important thing that we need to know is that data scientists spend over 60 to 70% of their time on data cleaning. So approximately 60 to 70% of their time is spent just to clean the data. And for the most elegant part, that is using machine learning, only let's say 5 to 10%, at max it might go to 12% of their time spent for performing the ML activities. So you can be called a good data scientist if you know how to clean your data. That is the most important part. So this is a live example. How do we move forward on cleaning a data set? All right. So that said, let's jump into the topic. So the first thing that I've done is imported some important libraries that we are already familiar with. And I've imported the Naukri dataset. So let's take a look how the dataset looks like. All right. So let me also see the dimensions it has. So it has around 220,000 rows and 14 columns. Got it. So some of the columns are company name that wants to hire, the education qualification that are there in the particular portal that are required for this particular hiring, the experience they need, the industry they operate in, the job descriptions, job ID, job address, and so on and so forth. The salary, pay rate, everything has been given. All right. On close observation of the data, so that is something I'll hand over this particular data set as well as the Jupyter notebook with you all for you to play with it. But upon careful observation, you would find that there are 5 columns that needs serious operations. Other columns might need operations too, but there are 5 columns that need serious need of some operations. Those are the job location address, experience, education, industry, and skills. So let's move one by one. Let's understand what are the problems first. So as of now, the job location address. So if you see in several things, let's say here it says Mumbai, Bengaluru, Kolkata, Chennai, Coimbatore, ... So this particular company called Onboard HR Services LLP has multiple locations of hiring. But if you want to play with this data, if you want to do some analysis, this might become really data-dense. So what we would want is it explodes to different rows having, let's say it should look like Onboard HR Services LLP, Mumbai. Again, this company name, Bengaluru. Then this company name, Kolkata, and so on. Also, you would find on careful analysis, if you expand it, let's say I remove the head, and if you do some careful analysis, you would find the term Bengaluru has been Bangalore used alternatively. Hyderabad, Secunderabad used alternatively. So this should not be the case. One name should be unique for each city, right? So several things needs to be looked upon, all the 5 columns, and we'll walk one by one for each of them. This was just an example, right? So that said, let's see what we have to do and what have been done. So first, it says that job location address columns shows same job availability in multiple cities. Therefore, we need to check the number of job available with respect to cities, right? So when we do some operations, we see that Bangalore has 3775 jobs. Again, Bengaluru and Bangalore has 2026 number of jobs. Why is that any difference? So there might be difference in, we can clearly see spellings are more or less the same. Not more or less, they are exactly the same. But what problems occur is, there might be some space given, there might be some other issues. So we need to pay close attention to all those things and do our work. For example, Bengaluru. Only Bengaluru has been taken as another city. That should not be the case. It should be, these 3 columns that we can see over here should be merged as a single column. And all these values should be added so that we get an understanding that which city has how many jobs, right? So that's what we are going to do. Also, we see that there are several cities where jobs are less than even 10. So such cities, we do not have any, there is no, we should not take into account all the cities which have very less number of jobs in our analysis, because that would only create ruckus and would not help in our analysis as such. See, there are several cities having 1 jobs. That is something we would not really need, right? All right. So what are the conclusions that can be derived? Many cities like Bangalore, Bengaluru, Hyderabad, Secunderabad, Mumbai, Chennai, etc. can be seen as multiple different values. And this needs to be cleaned. So I have taken lots of time to clean all these values. And trust me, it has taken me more than 5 hours of time. And trust me, you would take not anything less time to clean all these things. So what I've done over here is, I've replaced all the values like Bangalore to Bangalore, only Bangalore with a space bar in between, right? Bangalore with Okay, here there is one space before and after. Here is only one space after. So like that, there have been different of values that have been replaced with only the word Bangalore. Similarly, I have done all the similar cleaning for Hyderabad, Secunderabad, and everything to Hyderabad only. Similar cleaning for Mumbai. You can have a check when you get this particular notebook with you. So these are some of the cleaning parts that I have done. If I start explaining each of them minutely, it would again take a lot of time. So do your due diligence when you get this particular notebook, and also try to understand from the dataset itself. All right. So I've cleaned all the cities, and this is the most crucial, boring, and time-taking part that actually occurs. So once it has been done, now when I'm calling the particular dataset, when I want to see how many jobs are available with respect to cities, I see that Bangalore has around 10,000 jobs. NCR, that is Delhi, has around 8,500 jobs. Similarly, it goes down to cities having as less as 2 and 1 jobs. Now, as I said, that there is a huge difference in the job openings across the cities. While Bangalore has the maximum job of 9963, many cities like Puri, Raigad, Amravati, etc. has minimum, that is 1 job. And it's not fruitful to use all these cities. So what I have done is, cities having jobs less than a particular threshold, which in this case is 50, I've removed them. I've just dropped those cities. So now what I see over here is, these are the, instead of so many cities, right? Instead of so many cities, now these are the only cities that are present. So cities having more than 50 jobs are only this much. Now our analysis becomes very easy. So now what I've done is, I've taken a visual analysis. I've simply used the count plot. Now we can see that Bangalore has the maximum job openings, followed by maybe NCR, then Mumbai, Hyderabad, Chennai, and so on and so forth. So this was a visual representation of the number of jobs with respect to cities. Now, when we come to the data cleaning part for the experience column, what we see is, so we first take into account the experience column, and we see that there is a variety of experiences that is required: 0 to 1, 0 to 0, 4 to 8, 5 to 10, etc. Now, what we would want to do is, we want to drop off this particular experience column over here and use the minimum and maximum column instead. So instead of a column named experience, what I would want to do is exclude this particular column and use minimum experience and maximum experience instead, so that we get an idea of the number of jobs based on cities let's say 140, 10K, etc., etc. So there is no job 10K, 9,900 something is the maximum. Anyway, and it should also tell us the minimum requirement, the minimum experience required. Let it be 0 or 1, whatever it is, and the maximum, let it be 7 or 5, whatever it is. So I want this particular arrangement. And for that, what I have done is, I have splitted everything. I have taken into account the minimum experience, that too, the top 3 minimum experience that is required. All right. So for minimum experience with 2 years, we can find jobs. There are 7,256 vacant positions. For 0 minimum experience, there are 6,000 plus jobs available. And for minimum experience 3, there are more than 5,000 jobs available. Similarly, for max experience, 5 years, we have more than 6,000 jobs available. And for max experience more than 7 years, we have 4,000+ jobs available. And again, for max experience of 8 years, we have 3.7K jobs available. All right. Now, we would also want to do some corrections, which are, while cleaning the data, I also found that there were some job experiences wherein it said not. That is, no jobs were required. No job experiences was required. So this becomes a categorical value, right? And we would not really want a categorical value to take our place. And that's the reason we change all sort of categorical values to numerical values. So not can be easily replaced with 0. That's what exactly I have done. Also, there were certain job experiences which mentioned as, again, in the maximum category, which said mentioned or -1, which actually gives me no clear indication. So for them, what I have done is I have changed with the mode. That is the maximum vacancy for the max experience, which was 5. So I've changed mentioned and -1 to 5 both. And I have also taken time to convert them to the int data type, because I would be working with them numerically. I'll be using some numerical operations on it. And for that, I need the int operator. I'm not going into deep making you understand the syntaxes that I have used, because that is already covered in the previous sessions. If you do not understand, feel free to watch the previous lectures. Everything would be understood by you then. All right. Now I have also dropped the experience column, because I already have the minimum and the maximum column in hand. So the experience column is no longer required, right? So now what I see when I, call the data, I see no experience column is present. Instead, I see two columns called minimum experience and maximum experience. Now let me visualize the same. So for visualizing, I see that the maximum experience that is required, the maximum job vacancy for the experience, for maximum it is 5 years, then followed by 7 years, and so on. For minimum, it's 2 years. 2 years, people having 2 years of experience have the maximum number of job vacancy, followed by freshers, that is 0 years of experience. And so on we go forward. All right. Now moving to a third column that needs to be cleaned, that is the education. So on working with the education column, I found that it's pretty much messy out there. Also, it has some null values. It is 3,000 plus null values. So what do you expect? When you get any null values as such, what should they indicate? Null values means either, null values for education means either they do not have any specialization or any graduation, right? And that is what I have used. So all the null values, I have filled them with UG, any graduate, any specialization, because they either are not graduate or they can be from any field whatsoever. And now, since we know that a job would not take anyone without any graduation, right? Therefore, I have made a point to change it to any graduation, any specialization. Now, to be very precise, it can be so that you do not need any graduation. But again, then the data would become, too large, too expensive, too time-taking to work with. So just for the working sake, I have taken it to the any specialization, right? Now when I see Now when I see the education counts, we see that people with any education is 24,000. So people who do not have any specialization vacancy for them is more than 24,000. Followed by BTech, that is 8,000. Followed by BCom, BSc, and so on. Now what I also need to do is, if you see here, you might find columns written not or dash, which makes no sense. So I also need to correct them. I also need to clean them. And that is exactly what I have done. So for BTech, BE, and columns like that, I have included them in the BTech. And similar changes I have made, like PGCA, I have changed it to CA, and diploma, BCom. Okay, so columns like diploma, comma, I have changed it to only diploma. And I have done the necessary corrections as such. Upon which, what happens is, we find that NE remains the same, 24,034. BTech has been increased to 9,438. BCom has also increased by 5. And such is the case, right? So on performing all these cleaning operations, now when I want to visualize the same, what I get is, so the job opening for candidates with any degree, any graduation or any specialization is the maximum, followed by BTech, and then comes other specializations, right? So that was working with the education column. Now when we come to the industry column, what we see over here is the industry column has not been correctly mentioned. Media, entertainment, internet, advertising, PR, MR. So it might give some wrong impressions as well. Like IT software, software services. What do you exactly mean? So we also need to correct them. We also need to do a pretty much good cleaning of this particular thing, right? So what I've done over here is, the first thing that I've done is, I have seen if any null value is present, and I've seen, yes, there is one null value present. And I have, since it was only one, I have filled them with the mode, that is the maximum number of job that was available. Although I could have dropped it, but there was no point in dropping just one. That's the reason I have changed it to the mode. You might pretty well want to drop it. That's no issue. Now what I've done is, I have used the split function to take all the, so split using the forward slash. So now I'll get media, entertainment, internet in different rows. And that's exactly what I've done. And on doing that, when finding the value counts of all the industries that are present, we find that the industry for IT software is the largest, having around 14,000 plus vacancies, followed by BPO, then banking, then education, recruitment, and so on and so forth. Now what we would want to do is a pretty much visualization of the same. So why am I doing a visualization? Visualization is very important because that is how you would want to provide the data to your stakeholders. Let's see, because they would not understand these numbers, or they might, but don't you think a visualization would be much better off? That's the reason we would always, whenever we get the perfect thing in numbers, we would want a visualization of the same. So that's what I have done. Now it's pretty much easy for us to understand that software, IT software has the most number of vacancies. Not only that, it's highest with a great distance, right? Followed by BPO, banking, education, which are kind of same. Now coming to a last column, that is skills. So for skills, we see the number of null values is 799. again, what I intend to do is fill them up with the mode. On doing that, I find there is no more null values present. Now, what I need to do is I need to find the count of all the industry, right? Sorry, not the industry, but the skills required. So I find application programming is the most sought after skill, followed by sales, then ITES, then production, accounts, HR, and so on and so forth. Therefore, I also do the required visualization, and it appears quite like this. So application programming is the most sought after skill, with again a distance, followed by sales, ITES falls way below, and then as we move towards the right, the distance or the gap lessens. So this is exactly how we do data cleaning. Although I just explained you what I did, take a, activity, work out this particular notebook yourself, and then pause the videos, work out yourself, and then see whatever has been done in this particular notebook, so that you get a clear understanding how things are done. Because just by seeing the video or seeing the notebook, you would understand nothing. It's pure practice that makes you perfect. So that's all for the data cleaning session. Thank you, guys. Hi, everyone. Welcome to this lecture on visualization. Now we have already learned about the basics of Python, the advanced tools or libraries we use in Python for data science, and we have also learned how to clean our data. Now, we would learn how to visualize those cleaned data so that we could use them for analysis, and well after that for EDA, that is exploratory data analysis. So let's dive into the topic. So a quick theory firsthand. What is data visualization? So data visualization essentially refers to visualization of the data. It is a graphical representation of information and data. By using different tools such as charts, graphs, maps, animated charts, etc., we can find and understand the different hidden patterns and trends in data. So this is essentially used for descriptive analysis. So till now what we have learned, like the libraries like Pandas, NumPy. So essentially what we have learned to do is descriptive analytics. That is, we have our data set and we want to understand what this particular data set entails. This data might tell us some story. And to understand this story, what we use is descriptive analytics. There is something else called as prescriptive analysis. And before that comes the predictive analytics. So what is predictive analytics? This is where we use machine learning to understand the trends that is going to follow. So descriptive analytics, as its name suggests, tells us about the given data, while predictive analytics helps us to predict the future. And there is something called as prescriptive analytics, which essentially prescribes us the steps that needs to be taken to change the prediction. So in simple words, let's say you are in your college and you are getting a grade of 8.0 CGPA, right? What let's say this varies, like sometimes you get 7.8, sometimes you get 8.2 and stuff. So what the machine learning will predict is that you might end up with an 8.0 CGPA. But what if you want to sit for a particular company which demands you to get a minimum of 8.5? The course of action and the steps you might want to take will then be called as prescriptive analytics. So this is predictive analytics. This is descriptive analytics. I'm really sorry. This is predictive analytics, right? This is what the machine predicts. This whole story of your data is descriptive analytics, and this, the way, the path, the modifications is called as prescriptive analytics. So I hope you understand the basics of the three terms: descriptive, predictive, and prescriptive analytics. Now, visualization basically helps us with both descriptive, predictive, with actually three of them: descriptive, predictive, and prescriptive analytics. But here what we will learn is how descriptive analytics can be done using visualization. Once we learn machine learning, we will be using visualization again to understand the looks and the feel of the analytics that the machine shows. All right. One more important thing that you should understand is visualization is nothing but a way to represent your findings to the stakeholders. All right. That said, let's understand the three categories which entails visualization. The first is univariate analysis. Next comes the bivariate analysis. And the third is in multivariate analysis. So what are they? Univariate analysis is when only one variable is in action. So when we are finding the analysis, when we want to conduct the analysis for a particular variable, let's say there is a data set given, right? There are several columns. Let's say, let me draw it over here, right? Let's say here you have your name, you have your CGPA, and let's say you have your marks, right? So when we want to understand only the CGPA, we would be using univariate analysis. That is, we would be taking only the CGPA variable into action. What is bivariate analysis? So bivariate analysis is when we take two variables into action. So let's say we take CGPA and marks together. Well, this is not a very good example. Let's say I take a better example. Let's say the sheet for the employees of a company. So name, years of experience, age, salary. So now if I want to just understand the compensation given by the company, I would want to do a univariate analysis using this particular column or the variable. What if I want to do a bivariate analysis of how much salary you get based on your experience? So I might want to take these two columns, salary and years of experience. So essentially it takes two variables into account. What is multivariate analysis then? What if I want to take more than two variables into account? So more than two. This is what multivariate analysis is. So what if I want to take more than 2 variables into account? Since here I have very less number of columns, it might not really look that good. We will understand this once we go to the lab session. We'll see good data sets. But as of now, just understand. So what if I want to understand the correlation between the age and the years of experience? Maybe someone with 2 years of experience might have an age of, let's say 24 or 26. And someone with a 3 years of experience, or let's say 2 years of experience, it has an age of 24. Why is that? Because it might be so that this particular person has done some higher studies, and that's why he has lost 2 years. And let's say this particular company treats each one same. No extra compensation has been allocated for higher studies, right? For people coming with greater number of degrees. So both of their salaries are same. Let's say 100K, right? So we can find the correlation between years of experience to be 1. That is, as the years of experience is increased, the salary increases. But how is the age and the salary related? They are not really, they do have some good correlation, but they are not absolutely the best as of years of experience. And that is something we can find using the function called as CORR, which stands for correlation. And there are other visualizations such as heat map to understand the same. So we'll see all of them as we move to the lab session. So that said, let's see the types of packages or libraries that we will be using for visualization. The first thing that we'll be using is Matplotlib. This is something we have already covered. As we know, this is the very basic library for visualization. Some of the important graphs we have also learned in the past is line plot, scatter plot, bar plot, and histogram. There are many more, but these are something that we use in our daily routine. Now, what we will be also learning is about Seaborn. So Seaborn is an awesome library for visualization. This is an advanced library which is based on Matplotlib. That is, it's created on the top of Matplotlib, but it provides a high level of interface for drawing attractive, interactive, and informative statistical graphs. We'll see how it looks once we go to the lab session. Now, in order to use Seaborn, the first thing that you all need to do is install Seaborn. And how to do that? Go to your terminal, type pip install Seaborn. That's how you start installing Seaborn. I'll show you how to do that as well. We also have another great library called Plotly. Here, it performs super interactive plots with tons of other features. We'll see how Seaborn and Plotly differs. You have already learned about Matplotlib, right? Which was good. However, it was quite basic. Now what we'll also learn is Seaborn, which is one step ahead of Matplotlib. You will totally enjoy Seaborn. Once you start enjoying Seaborn, we'll also learn Plotly. And what is Plotly? Plotly is again one step ahead of Seaborn. Now there are other libraries for visualization as well, but we'll be restricting our curriculum to Plotly, because this would be enough for us to gather more than enough information to apply in our Capstone project and in our daily life as well. So that said, let's head to the lab session. All right. So the first thing that I want all of you to know is, what you need to do is go to your place where everything has been installed. Go to New, go to Terminal. So here you'll find the location where your Anaconda has been installed. Now what you need to do is write this command with me, pip space install Sabor. All right, this is what you need to do. Press enter. For me, it's showing requirements already satisfied. If you have Seborn in your account, it would show the same. If you do not, it would get installed. While you're at it, also install the Plotly. So what is the command for Plotly? Pip install Plotly-express. So what it'll do is pip install Plotly express. Press enter. For me, it would again show already satisfied, but for you guys, it would install the entire package. Now, once it has been done, what you need to do is move to your Jupyter notebook and start using it by importing the same. All right. So what I've done here is, so let's understand the codes. So what I've done, I have imported a data set, and the libraries that I have imported are Pandas as PD, import Seborn as SNS, that is the alias we use. And what we have also imported is import warnings. What is this for? So when you use several types of visualizations, sometimes it gives you warnings because some of the visualization tools might get deprecated. Now, it's still not deprecated and it can be used widely. And therefore, we tend to tell Python to stop giving me warnings because I want to use them. You don't want to ask me to change to any other visualization. I'm okay with it. Let me use it. And that is when we use this particular line. Warnings dot filter warnings followed by ignore. That is, ignore the warnings. You do not need to give me warnings. I know this is a deprecated version of the visualization that I'm using, but I still want to use that. All right. So make it a habit to use this particular two lines everywhere. Import warnings, warnings dot filter warnings followed by ignore. Now I've been reading this particular data set, that is employee.csv, which kind of looks like this. It has 35 columns: age, attrition rate, business travel, daily rate, department, so on and so forth. All right. Now, I want to do some univariate analysis. What are they? So, as I said, univariate analysis is where we can only visualize a single variable at a time. It helps us to analyze the distribution of variables present in the data. So how do we perform that? Performing univariate analysis on numerical variable, that is age. So I want to perform a univariate analysis on the variable age, which is a numerical variable, right? So I've used is a dist plot. What is a dist plot? So there are lots of mathematics behind creating a dist plot, but as of now, just understand this. It gives you a histogram, a histogramic representation along with the normal curve. So as the frequency of the data increases, the height of the graph increases. So it says, what does this particular representation say? It says that the employee in this particular company the average age or the maximum employees has an age of about 30, let's say 35 years. So what does this say? So when I'm performing a univariate analysis using the dist plot for the variable age, I'm getting a graph of this sort. It says that my maximum employees has an age of about, let's say, this is a very bad line that I've drawn, but it's around less than 35, I would say, 34-ish. So most of my employees has an average age of 34. It's not an average age, but it's an absolute age of 34. Most of my employees are aged 34. And people with age of 20 is pretty less, as same as people with age of, let's say this is what, 57, 58 is pretty less as well, perhaps the least. So this is how visualization or univariate analysis helps us. All right. Now what we'll also see here is how we perform univariate analysis on categorical variables. This was a numerical variable, and that is the reason we have used a dist plot, which is nothing but an amalgamation of histograms and the normal curve. Now for categorical variables, what I've used is a count plot. What does that do? So I've taken the variable to be business travels. So there are essentially 3 types of business travels, if you see. How do we know that? So business travels here has a long list. We can also check it out. Let me run this particular cell first. Right? All right. So business travels has 3 basic types. One is travel rarely, one is travel frequently, one is non-travel, which means a count plot. What have a count plot done? It has summed up all the counts in the form of a bar graph. That's what a count plot does. And it says that the total number of employees who travel rarely is 1,000. Employees traveling frequently in business, for business purposes, is slightly more than 200. And employees who do not travel at all is less than 200. So a count plot gives us the count of the categories of data that we have. Now we come to bivariate analysis. What is done over here? Here we visualize 2 variables simultaneously. So as I said, we'll be taking 2 variables. Here I have taken the department and the monthly income. So monthly income is a continuous variable, a numerical variable, and department is a categorical variable. So I've been performing a bivariate analysis of categorical versus continuous variables. And here what I have found is, so the monthly income based on the different variable, the departments is what I'm looking for. So the different departments are sales, R&D, HR. And their monthly sales are as follows, not monthly sales, but monthly income. So the sales department has the highest monthly income, followed by HR, and then comes the research and development wing. What does this particular, let me again grab the pen. So what does this particular thing shows? It's nothing, but it just gives us the estimation of how the outliers are situated, right? So it typically tells us that normally, on an average, the salespeople get something around 7,000 monthly income. but there are people who gets this much more, that is slightly more than 7,000 as well. For HR, the average income is not quite, but again, nearly 7,000. But there are people of HR department who gets something north of 8,000. So this is what this particular ping-like structure tells us. So this was about categorical versus continuous bivariate analysis. Now, how do we do continuous versus continuous bivariate analysis? That is when both are numbers. Well, we use a scatter plot for the same. So here we'll be seeing the same. What I've done is age versus monthly income. Now here, what it tells us is, if you see closely, nothing much can be derived, right? But still, what I can derive is, as the age increases, you see this area also keeps on increasing. Therefore, the monthly income also increases. So we can kind of tell that with increase in age, the monthly income also increases. Although it's not quite true. It's not absolutely true. Because let's see, for the age of 40, someone is getting 2 lakhs of income, while someone with 60 is also getting 2,500. So it's not an absolute representation, but it shows the trend, right? This is quite like predictive analysis. When you know the trend, you can say that when you can probably, if you're an employee of this company and you know this trend, and some of your friend wants to join this company, you can tell that with, let's say, when you turn 30, you might be earning somewhat around this, 7,500 or something like that. So this is kind of using it in the predictive analysis, but there's much more to learn. How do we use it? As of now, this gives us the visualization of descriptive analytics, which says that some people of age 60 earns 2,500, while some earn this much amount. Some people of 40 might earn this much amount. So this is what the data tells us, as simple as that. All right. Now we go to multivariate analysis. So multivariate analysis is when we use more than 2 variables. Now here what I have done is I've taken department monthly income as it was for bivariate, and I've also taken into account the attrition. So now what it says is, for sales department, the attrition rate is greater than the people who do not leave the company. Same for R&D. People who leave is less compared to people who do not leave. And same for HR as well. So I can take more than more than 2 variables into account. While it also tells me this fact, it also tells me the people who leave the company gets less paid. See, that's what the data tells us. Although it might be wrong in real life or real world scenario, the information the data gives is people who are leaving the company has a monthly income less than people who are not leaving the company for all the for all the departments. And probably this is the reason that they want to leave the company. That is the reason they are having attrition rate. The most important thing that I would want to make you learn all is the use of heat maps. That is correlation. So what is a heat map? Heat map is a data visualization technique that shows the magnitude of phenomena as colors in 2 dimensions. So what it essentially does is, it gives us an understanding of how age is related to daily rate, right? So if you see age, all the columns have been listed in the y-axis as well as the x-axis. Now what it does is it compares all the variables with each other. So if you see over here, age versus age, this particular cell, it's 1. Obviously, as age increases, this age will also increase because both are the same. If you see this particular diagonal line, everything is 1. Why? Because this diagonal actually shows the correlation between the same variables, age versus age, daily rate versus daily rate, then comes distance from home versus distance from home. So everything would be 1. Now, if I want to check age versus, let's say, education. So education, that is the third column. Sorry, fourth, this one. So education versus age. How these are correlated? By a factor of 20% or 0.2. So what it also says is the values lie from -1 to +1, where -1 means strong negative relation and +1 means strong positive relation. What it again means is, let's say there are 2 graphs, right? This is having a slope of +1, while this has a slope of -1. So both are good graphs. One shows the absolute negative relation, that is the wrong relation. You might want to change it by a factor of -1. And this shows the proper relation that it has. However, factors which are less than 1, which is the usual case, do not quite give us an actual answer how the trend is. And this is the actual, if you find although it lies between 1 and +1 and -1, you might never find a +1 or a -1. It's very difficult to find. We can obviously neglect the same columns when are compared, because that is never the case. We would not want to compare age with age. When we compare age with any other variable, it's very unlikely to find a factor of 1 or -1. How close it is to + or -1 is what we are looking for, so that we want to take those parameters into account while doing our predictive analysis. So as we said, age versus education has a correlation of 0.2, that is a 20% correlation. Let's say this particular thing over here. So what is this? Daily rate versus job in development has no correlation at all. This particular thing over here, what are they? This is performance rating and percentage salary hike. So performance rating and percentage salary hike has a 80% correlation, which makes sense because as high your rating is as high as your hike is. So that is how we get the correlation map. All right. The heat map. So what we do here is I have imported Matplotlib. I've given the size. I've imported Matplotlib only to set the figure size, nothing else. Followed by sns.heatmap of data CORR, that is correlation. That is, we take the correlation data and find its heat map. Annote equals to true, that is the annotation, that is this 0.0, 0.1 has been given. And format is 0.1f, that is, it would take only up to 1 decimal point. So let us also understand what it does, right? So data is the given data set. I hope, yeah. Now, what we want to do is data.correlation. It gives me the entire chart of how they are correlated. It's quite difficult for us to understand how these are actually correlated. And therefore, what we use is the heat map. So what we use here is sns.heatmap of the entire data set, of the entire correlated data set. And this is what we get. Now, since the figure size and everything is so small, it's very hard for us to understand However, through the heat map, we kind of understand that here we have a good correlation, and these are places we have very bad correlation. If you want to annotate and do every stuff, what we do is we use this annote equals to true over here. So what we do is annote equals to true, and we also need to set the figure size for that. So what we do is plt dot fig size. Let me take one I have taken earlier because that was a very good size. 19,18. All right. Okay, so I have not run this particular cell, and that is why Matplotlib is not taking into account. All right. So now it would run well. Now that's what you see over here. Now, why there is a difference between the graph that I had shown earlier and this one? This is essentially because it's taking the entire format. And that is the reason I had actually used the format of 0.1 up to 1 decimal places. 0.1s. And now you get the best graph that you would want. So this is how you create a heat map. So in the next set of lectures, we'll learn more about other graphing methods and everything. So that's all for this particular lecture. Hope to see you in the next one. Hi everyone. In this lecture, we'll be learning about line plot and area plot using both Seaborn and Plotly. Some of the most important things that we will be learning about is how to create a simple line plot, how to customize that, changing the confidence interval, colors of the line, styles of the line, and also the width of the line. We'll also create the line plot using Plotly and see the customizations thereafter. And we'll be also creating an area plot using Plotly. So that said, let's dive into our agenda quick. So first, what we have done is imported the necessary libraries, that is Pandas, Matplotlib, Seaborn, and Plotly. Also, we have imported warnings as instructed. Now what we do is we import the dataset. Now see one important thing, here we have not imported any dataset as such. Why? Because Plotly provides us with its own list of datasets. So what I've done is df equals to px.data.gapminder. So Plotly in itself has this particular dataset called gapminder, and we did not want to separately upload the dataset and use it. So when we write px.dataset.gapminder, it automatically takes in this particular dataset, right? Now we will be working with this particular data. So first, we'll be using Seaborn. A very simple plot using Seaborn is sns.lineplot. On the x-axis, I have given years, and on the y-axis, life expectancy, and data equals to df. So what I've done is line plot followed by x is equal to this, y is equal to this, that is the names of the columns that I want to, followed by data is equal to df, that is which data you want to take. Conversely, what you could have also done is, both would actually give you the same results. So it's up to you what you want to follow. The convention x equals to, let's say, data dot year, and y equals to data dot life expectancy or data followed by brackets and take into account life expectancy. And in that case, we would not put it. I'm sorry, it's not data, it's df. df is what we have allocated the variable to. So it's df in both the places, and that's the exact graph that we get. So there are basically three ways of creating this kind of plots in C1 altogether. First is you call SNS dot whatever plot you want, scatter plot, line plot, bar plot, count plot, whatever it is, followed by x equals to dataset dot the column you want to call, or x equals to ds followed by the square brackets followed by the name of the column that you want to access. That should be enclosed within inverted commas. Or the third method that I generally tend to follow is x equals to give the name of the column that you want, obviously inside your inverted comma, followed by y equals to the column that you choose, followed by data equals to the data set that you want. Now, it's absolutely your choice, whatever you want to do. All right. So it gives me a line plot. It says that from year 1950 to 2000, the life expectancy has been increasing in this particular manner. And so I get it that this is what the graph says, that in 1950, it has been slightly short of 50. In 1960, it has been slightly north of 50, and so on. It has been increasing like this. So this is the line that we are talking about, right? But what is this region, shaded blue region? This is nothing but the confidence interval. What is confidence interval again? Confidence interval is nothing, but it tells us how confident the model is that the life expectancy for this particular year is lying in this particular region. So let's say in 2000, right? In 2000, again, please excuse my drawing. So in 2000, it's around, or let's say this, right? It's slightly short of 65. Let me call it to be 64. So in 2000, the life expectancy is 64. That is, it is estimated that if you are an individual living in 2000, in your 19th century or 21st century, what it is called. I think it's 21st century, right? From 2000, it would be a 21st century. So your life expectancy is 64 years. You would be living total of 64 years. But is it really you would be living 64 years? You might live for 65 years. Your friend might live for 68 years. Someone else might live for 58 years. And the average of all might come to 64, right? The point here is how confident the model is that everyone will be living for 64 years. So this is the confidence interval that it says that the maximum I can understand that someone will be living is this. Let's say this to be 67 maybe. And the minimum is this, which is apparently maybe greater than 60, 61 maybe. So it says that I'm confident that you would be living somewhere between 61 and 67 years. And I'm putting a line that the best fit line you would be living is 64 years. But my confidence is such, it says me that you would be living from 61 to 67 years. That is what this confidence interval tells us. So if this is very, very clear to you, let's move into the customizations of a line plot. So what are the different customizations that we can do? there are mainly three customizations. One is LW, which gives me the width of the line. Color, that is what color I want to choose for the line. And alpha, which is for the transparency, how much transparent you want your line to be. So what I've done is I've taken the same thing altogether, sms.lineplot, and everything given same, followed by a comma, LW equals to 4. If you see, this was a thin line. Here, the line has become thick. Let me show you even more thick. Let's say it will be 40. So you can understand how thick the line has become, right? For better understanding, let me put it to 14, and let's see how thick the line has become. Color. You can change the color of your line as you want. So this is hexadecimal coded color. You can also write your own color. Let's say I want a red line, right? So I write red over here and I get a red line. I am not sure if yellow, yeah, I think yellow is supported. So I can get a yellow line as well. Sorry. So like this, we can take different colors. What is alpha now? Let me change the color to something we can understand, because it is kind of flashy. Let me take green. All right. What is alpha? So alpha tells you the transparency you want. If you take 1, it won't be transparent at all. So do you see? Transparency is, if you take it to be 0, see how transparent it has become. You cannot actually see it. So when I take something like 0.8, you can see it is well enough visible. So this is all about the customizations that we can do in a line plot. Now changing the confidence interval. What if I want to change the confidence interval? I do not want such a huge confidence interval. So the theory says that confidence interval that confidence interval is the interval that we are X% confident that it will contain the data for that particular given name. So when we take confidence interval to be 90, it says I'm 90% sure that my data would be, for 100 odd samples, 90 of them will have their requisite life expectancy to be this particular point. If we do not want to give any confidence interval, it would show a huge threshold. So for example, here what we have done is I've taken the same data set, the same line plot, and I've given CI to be 50. That is, I want to be 50% at least sure. So see how reduced the confidence interval has become, because I just want a 50% assurance. What if I wanted a 90%, 99% assurance? What if I wanted that? See how much thick the confidence interval has become. Because in order, if you want me to be 99% sure, I cannot give you such a small range. That's what the computer tells me. I would say that your life expectancy would be at max this and at minimum this. That's how the thing occurs. Now, if you want to change the colors of the lines, that is also possible. Instead of drawing a single line, we can draw lines based on the different continents. So we have 7 continents, and this is a graph keeping all the continents, taking the average of all the continents. Now, what if we say that let's say I belong from Asia and I want only the data for my own continent. So I've taken another parameter called hue to be as continent. So hue actually gives hue to your graph. Hue means color. And therefore you see 7 different colors. It's 5 actually, 1, 2, 3, 4, 5. Okay. So obviously 7, Antarctica and Arctica has not been taken into account. There are 5 continents of whose data has been published, and their life expectancies are as shown over here. Clearly we can see that Africa has a very less life expectancy compared to its counterparts, wherein Oceania has the best life expectancy compared to all its counterparts. Asia is the second worst. All right, so that's all about how we can use hue to spice things up. Now we can also use changing the, we can also change the styles of lines. How do we do that? So I've used the parameter hue. From now onwards, I'll be only adding the parameters that I'm talking about. So everything else will remain the same. So what if I want to change the style as well? So in that case, I have done style equals to continent. Therefore, by changing the continent, the styles of lines will also change. And that's what exactly has happened. While Asia is a clear line, Europe is a dotted line, Africa is a more dotted line, and that's how the styles change with each continent. Matplotlib, or SNS, does it all by itself. Now, what if I want to change the width based on the different continents? I'll add another parameter called size. Size equals to continent. And then the size of the lines has also changed. Now, what if I want to draw a line plot using Plotly? So the syntax for that is px.line. Instead of sns.lineplot, it's px.line, followed by the dataset, df, comma, x equals to this, y equals to this. So the same thing for SNS, what we write is sns.lineplot, followed by x is equal to year, y is equal to life expectancy, and data equals to df. This is what we write for SNS, C1. And for Plotly, what we write is px.line, followed by the dataset name, followed by x and y axis. It takes a while to draw, but once it's prepared, it gives me a line like this. So why such a, messy graph? What does this actually mean? What Plotly does is it points each and every line based on each and every data points that is present, not even based on the continent. Therefore, using Plotly at times might cost you, right? That might not be suitable. So you need to know that Plotly, unlike Seaborn, does not take the average. It plots line for each and every data point. And that is the reason this looks so much messy. But what you can see is it is interactive. It shows me when I hover over the data, it shows me both the year as well as life expectancy. I do not, like in Plotly, like in C1, I do not need to draw the coordinates to understand what is the point. It shows me in a GIF. Now, what if I want to do some customization? What if I want to change based on continents? In that case, we'll still get a messy line, but we can understand that Africa falls way below, followed by Asia, these blue things that you see over here, then somewhat America, and at the top, we find Europe and Oceania. Now, better thing if we want to do the same using Plotly is an area plot. So what I've done over here is px.area followed by the same thing, df x and y axis. I've changed the colors for continents and grouped them using countries. And this is what we get. So hope this was understandable. This is how we use a line plot and a area plot, both in C1 and Plotly. In the next lecture, we'll be learning about scatter plot, box plot, and Violin plot. Till then, bye-bye. Hello everyone. In this lecture, we'll be learning about scatter plot, box plot, and Violin plot. We'll be learning each of the three techniques using using C1 as well as Plotly. To end things up, we'll be also learning about how to draw a 3D plot. Alright? So let's dig deep into the topic. As such, we have already installed the necessary packages, namely Pandas, Matplotlib, C1 and Plotly, along with the warning package. And we have introduced the dataset, that is the dataset for Iris, which is an inbuilt dataset inside the Plotly library. Now, when we want to view the first 5 lines, we write df.head, and this is what we get as an output. Now let's understand this data through visualization. So let me tell you something about this data. So what it tells us is, so it essentially tells us about the 4 things that we have. One is the sepal length, the sepal width, petal length, and petal width. So based on all these 4 parameters, based on these 4 parameters, we need to determine if the species is a Sentosa or there are different species which we want to determine. Alright. Now, determining falls under predictive analytics, but here we are doing descriptive analytics. Therefore, what we are doing is we are analyzing that what kind of parameters fall for what kind of species. What combination of parameters are used for a particular type of species. Alright. So let's understand by first using a scatter plot. A simple scatter plot would be sns.scatterplot followed by sepal width and sepal length. What it tells us is how the sepal width and sepal length varies across the dataset. So this is what it looks like. It's kind of messy again. It does not really follow a trend line. But yes, we can say in a general sense, it follows with increase in sepal width, sepal length also increases in most cases, although not all. Now, what customizations can we use? The first thing that we can use is S, which is the size of the marker that we want to use. So here, the size of the marker is uniform. Again, here the size of the marker would be uniform, but the size here is a default one. We can change it. We can try to increase it or reduce it. We can change the color of the markers. We can change the type of the marker. We can change the age color of the marker. And again, alpha, that is the level of transparency we can determine. So what I've used over here is I've done, let me keep all these things. Commented as of now. And let's see what happens. So the size of these markers, both the graphs are same, only the size has increased, nothing else. You wish to reduce it, you can do that as well. It has become more reduced than it was previously. So that's all about markers. I'm sorry, that's all about the size factor. What if I want to introduce a factor called as color in it? I've taken red as the color. So that changes the color of the balls given. What if I want to change the marker itself? What if I want to do that? I've done a star over here and see the, okay, so let me increase the size. If you can see, the marker from circles has now become star, right? We can change to other styles as well. Let's say I want to create a plus sign. Can we do that? Yes, we can do that. There is another factor. Let me keep it to star so that I can show you the next factor clearly. All right. So what if I want to introduce its edge colors as well? So now the edge color, you see the edge over here, which is in black, right? A black edge for red stars has been created. Now we can also reduce its transparency as such. And it becomes slightly invisible or slightly transparent, whatever we want to call it. So these are the customizations that we can do in a scatter plot. Now let's move to the different things that we can do based on another column as such. So we already have X as sepal width, Y as sepal length. And what if we want to take hue, that is changing the colors based on species? So now we actually see what we want to. We see some proper analysis. We see that with flowers having more sepal width and less sepal length. Let me grab the pen quickly. Yeah. So what we see over here now is flowers having more sepal width and less sepal length are generally centosa. So these are centosa flowers, right? So these are flowers which has less sepal length and more sepal width. Centosa. We also have versicolor. Versicolor is the orange colored flower, the dots, which is scattered, but it says that it has somewhat less sepal width, but more sepal length. So more sepal length and less sepal width are versicolor. Also, the green ones stand for virginica. Virginica are the flowers which has sepal length to the maximum and a considerable amount of sepal width. So max sepal length, right? Max sepal length and what do I say? average, right? Average sepal width are flowers called virginica. So now actually we can distinguish between the three species of flowers. When we see flowers with less sepal length and more sepal width, we classify them as centosa. Flowers with more sepal length and less sepal width as versicolor, and maximum sepal length amongst these flowers obviously, and average sepal width are virginica. So let's do you understand how interesting this is? Just by adding another factor, hue, we actually get to classify all these three classes of, or the species of flowers. All right. That said, let's move to the next part, wherein I want to change the styles of the points. So here, with everything remaining the same, I have added another factor called styles equals to species. So with changing in species, the styles would also change. So if you see, centosa has blue balls, versicolor has orange crosses, while virginica has squares of green color. And that is how it helps us identify things. Now, what if you want to change the sizes as well based on species? All this, see, if we change the color, it's good to go. However, these are things we are doing some more, we are adding some more stuff to make the graph look a bit more attractive. So maybe we want to change the sizes also based on species. So you also see that here I have removed the style part. So I've only added the size. So centosa has here the legend says that centosa would be more bigger balls, versicolor is smaller, and virginica is the smallest. Now, if we wanted to remove the hue as well, still we could understand. Although it would be a bit difficult, but still we can understand. That's the entire point. Even here, if we wanted to remove the color, we can still identify. Now, this data set is pretty small. What if there are several other things to identify as well? For that time, we can use hue as one parameter, styles as another parameter, and size as another parameter. So we'll use hue for species, maybe style for the name of the flower per se. I'm just giving you as an example. And size for, let's say, places where they are found. So we can actually use these parameters to identify between different other parameters. Essentially, we can analyze data better. All right. So this was all about all the three kinds of, the customizations present in a scatter plot in Seaborn. Now, when we move to box plot, what is a box plot? So let's understand how a box plot is constructed. Based on data, a box is drawn. This is the median. That is 50%. 50 percentile, where the data percentile is 50%. This is called as Q2 as well. This is said to be Q3, that is the third quadrant, which has 75 percentile of the data. This is the Q1, which is the first quarter, which has 25% of the data. This region over here is called as IQR. That is interquartile region, which is essentially all the data in 75% of the region minus data of the 25% region. In short, Q3 minus Q1. This line that you see over here is basically Q3 plus 1.5 times IQR. This data over here, this line over here, sorry, is Q1 minus 1.5 times IQR. Any data lying outside this is said to be an outlier. This is an outlier. So I hope you get the internal construction of a box plot. So now this line is the median. This is Q3, that is the third quartile. And this is the primary quartile, Q1. This is Q1 minus 1.5 times IQR. This is Q3 plus 1.5 times IQR. These points over here are termed as outliers. What is an outlier? Outliers are those points which highly change the actual data representation. So let's, for example, you have 5 friends who has their salary or who are aged. One of them is of age 24, second one is of age 25, third one is of age 24 again, fourth one is of 26, and the fifth one is of 25. So what is the average age? Let it be 26. So 26, 26, 24, 24 and 25. Therefore, the average age would be 25, right? What if you also have another friend? This is quite absurd, but please hang on. Who is of age 100 years? What would be the average then? It would be highly different. It would be, how much is it? 25 into 5, that is 125, 225 by 6, which is approximately 30 plus, right? 45, which is 37. So for one friend, the age is greater than 37. This does not give us quite the right result, does it? So this can be termed as an outlier. If you remove this particular age, I get quite a good number, 25. And all the ages actually revolve around this particular age. So that is all about an outlier. These points are outliers, which are far beyond the point all the other points are. All right? So if this is very, very clear, let us get back to how the box plots are constructed. SNS.boxplot, we give the x-axis. So this is used as an univariate analysis. We can use it for bivariate as well. This kind of looks different then. So let's understand for a univariate, which is proper. So I've taken sepal width to be the varying factor and df is the data. So this is what I'm getting. It tells us that there are 4 outliers. The median, the 50 percentile mark, is having a sepal width of 3 units. What are the customizations that we can do? We can change the width, the line width, and the filler size. Sorry, the flyer size. Flower size means the size of the outliers. So I've also done SNS.set style as white grid. Now you will see a grid altogether. Now what I am doing is I'm using boxplot x is equal to sepal width. So the same thing. Color I have changed to green. Width I have changed to 0.5. Width means the width of the box. Let's say I want to put it to be, let's say 5. See how the box becomes long, right? So let me get back to 0.5. line width is this particular width of the line. So let me bring it to again 5, if that is okay. It will be very thick, let me tell you that. So this is 5. Flyer size is the size of the outliers. So I've taken it to be 10. Let's take it to be 1. You would understand how small it looks, right? And I'm taking the data from DF. So this is all about the various customizations that we can do in a box plot. Now, what if I want a bivariate analysis using both the axes? Even that is possible. So I've used the x-axis to be sepal width and the y-axis to be a sepal length. And this is what I get. Different box plots for different kind of changes. Ideally, we do not use box plot for bivariate analysis. At times we do. Here, in this case, it is not recommended at all. We should ideally use box plot for a single variate. Just to let you know how we use and the possibilities of a box plot, I have plotted the same. Same thing if we do x is equal to this, y is equal to this, and we get the bivariate box plot. We can also use hue in addition in box plot. Again, not recommended here in this particular dataset. This varies from dataset to dataset where we want to use what. Once we know what kind of graphs we can compute, it's our own wish, it's our own creativity, how we want to create or visualize or make our data appear. All right. So by the hue is simple. We use the hue parameter as we have done for scatter plot as well. So this was all about box plot. Now coming to a Violin plot. What is a Violin plot? Violin plot is as same as that of a box plot. In addition, it has a KDE, that is kernel density estimation. So what it also does is a box plot. What a box plot says is it gives me the median. A Violin plot also gives me the median. Let me draw the Violin plot as well. It can be of different shapes, right? Based on the... So Violin plot gives us the median as well. It gives us the Q3. It gives us the Q1. This is the Q3 and Q1. This is Q3 and Q1. We'll write it. And these are the extensions. Violin plot is as same as that. However, it also gives us a plot, a KDE, a kernel density estimation, that how the plots within are stored. If it is a right skewed or a left skewed. Right skewed, left skewed. If you don't know, we'll learn all of this in the statistics chapter. So a Violin plot also helps us understand how the data inside the Violin plot is distributed. For example, here the distribution is quite uniform. The middle only gets tapered to the up and bottom. Therefore, the distribution is quite uniform. So this is the extra benefit of a Violin plot. Apart from all the functionalities that a box plot has, a Violin plot in addition also tells us how the data is distributed inside the plot. All right. So now we can also customize the same things as we did for box plot. The width, line width, flyer size, we can change as we have done for box plot. Everything is as same. We'll get the notebook with you. Do play around to understand what happens. I've explained you the basics. You can change parameters and try to do stuff from your own. Now, what if we want to do a scatter plot using Plotly? We have already seen the scatter plot of using SNS, that is seaborn. Now let's see the same for Plotly. So this is the scatter plot for Plotly. In addition to what seaborn does, it gives me interactivity. So when I put my cursor or hover my cursor over these points, it gives me every knowledge that I want to have. What is the species? What is its sepal width? What is sepal length? Same for each and every points out there. So this is the interactivity that we get when we use Plotly. The rest is all simple. What if we want to use, so Plotly also allows us to use box plot and Violin plots along with the scatter plot together. How do we do that? px.scatter for the scatter plot, give the data set, x equals to what you want, y equals to what you want. If you want to include the color, that is hues for seaborn, here we write color. And then I have taken Violin plot to be in the y-axis. So marginal y equals to Violin. And for the x-axis, I have taken box plot. So marginal x is equal to box. I'll see what happens. So now you can see that the scatter plot is as we have seen. In addition to that, we also have box plot for all the different groups. 3 box plot for 3 groups based on species. The same when we wanted to do for seaborn, it became quite cumbersome, right? Several number of boxes came in. But for Plotly, it gives you 1 box for 1 species. And same with the Violin plot, which has been plotted in the y-axis. So I hope this particular usage of box plot and Violin plot inside scatter plot is clear. Now what we can also do is introduce a trend line. As I was saying, as I was drawing all the trend lines, right? What the trend says. So I said that this is the basic trend. This is the basic trend over here. This can also be done using visualization itself. So what we do is we use another parameter called trend line equals to OLS. And boom, this is what we get. So the trend line for setosa is like this. The trend line for versicolor is like this, and that for Virginica, it is like this. It also, if you see closely, it also says the R-square value. Here it's 0.2 for versicolor, it's 0.27, and for for setosa, it's 0.55. So you also get the R value. What are this? We'll also learn in the statistics chapter as well. But I hope you understand how the trend line and how accurately we can draw them. All these are typically used for analyzing stuff. We'll also learn them when we do our Capstone project, how useful these are. All right. That said, we can also plot a 3D plot. So right now we had seen only 2D plots. What if I wanted to do a 3D plot? This is what we get. If you see closely, we can move it around and see how these points are distributed. Right? So if you see, Virginica lies towards this parameter. We can change sepal length, sepal width alternatively as we require it to. right? So when we take Sebel width here, we get that Setosa lies more to the right. When we want to check between Virginica and Versicolor, which was very difficult from the 2D graph itself, right? The 2D graph had it all mixed up. Now we can have a very clear understanding and clear look. Can go here and understand this. We can maybe zoom in and understand stuff, wherein the points are located, how closely they are located, and what to do with them, right? So 3D plot can also be done using PX, that is Plotly Express. Last but not the least, we can also use some symbols for the different petals that we get, the different species that we get. So if you see closely, although here the usage of the symbols does not make much sense, just for your understanding purpose so that you can use in different data sets, I've utilized it as well. So you can also take a look at the different symbols that it entails. Now let's understand this. How do we create this 3D plot? This is what 3D plots are about. Now in order to create them, what we do is we write px.scatter_3D followed by the name of the dataset, x and y, and the z-axis that we want, followed by the color if we want to, or we can leave it as well. This is optional. So this is the symbol syntax, pd.scatter_3D. If you want to include the symbols, you can do that very well. So that's what I've done over here. So all right, this was all about scatter plot, box plot, and Violin plot. In the next lecture, we'll be learning about how to plot maps. So hope to see you in the next video as well. All right, bye guys. Hi everyone. In this lecture, we'll be learning about how to visualize maps. So the very prerequisite to draw a map is a data having latitude and longitude. So here what we have done is we have imported Plotly. I've not imported Matplotlib or Seaborn as such because we do not need it. And I've also not included Pandas because here Plotly anyway provides us with the data that we require. So I have already read the data. This is quite what it looks like. So it has a latitude, a longitude, the hours for which this is a car data set, how the cars are shared, and what are the peak hours in which the cars are shared, right? All right. So now, what if we want to actually plot it in a real-time map? Python or Plotly per se has this feature which is engraved in scatter mapbox library. So what we do is px.scatterMapbox. We put the data df, lat equals to the latitude, long equals to the longitude, and everything has been done. So it would now take the proper location from the map you get. Now what I'm trying to do also is I'm taking color to be as peak hours, size to be as car hours, and size max. These are the customizations that I'm doing to be 15. I'm taking zoom to be at a level of 10 and the style to be Carto Positron, right? Now that said, let's run this particular cell and see what we get. So this is what we see. This is an US data set, and therefore these are the exact positions in that particular US market. These are cars with hours of 1705. This is with 1657, and everything has been mapped based on a heat map cells. We can change several factors in this particular map box. So lat and long has to be there. Color is your own wish, whatever you want. Size is similar. You can, these are optional features, right? And map box style, these 3 map box styles are available. So one is this Kato positron, another is white BG, that is, it takes the very basic. You can maybe try this on your own. I'll just show one. When we run them, we see nothing. The very basic visualization is found. And there's one more called OpenStreetMap, which gives a very realistic overview. Let's see that. This is the most realistic overview that you see. And all this latitude and longitude are of real time. All right. So that is what it is. Now, we can also take into account a scatter map. So for this, I've taken the Gapminder dataset into account, which kind of looks like this. Now, for this, I can take the world geographical map, and the syntax or the particular library that I would want to use is, library is obviously Plotly. The particular function of the library that I would want to use is scatter_geo, followed by the data df, locations equals to iso alpha. Okay, this is the location column that I have to give based on the country name. Color, hover name I have also given. What would be shown when we hover over a particular place. Size should pop. I mean, based on the column population, pop for population, the size would be shown. And for projection, I've used natural art. There are many more projections you can choose from. This is the website you would want to visit for that. I'll hand over this notebook to you as well, so that you can just copy paste it to your maybe Chrome extension, your Google search, and perform all the projections that you need. So let's see what we get over here. This is what we get. So if you see closely, what we have done is, as I said, color is based on continent. So all different continents has different colors. Hover name, when we hover, we see country at the very top, right? Size of these pointers are based on the population. We know China has the maximum population, and therefore China is having the largest circle, followed by India, which is here, the second largest circle. And this is how everything looks. So we can also take into account the continent or the world map. Now, what if you want to see an animation using your scattered map? We can do that as well. What we want to do is, we want to add a new line called animation frame equals to, based on what you want the animation to be. All right. So if you see over here, I might want to just bring the data set again. So the columns present are country, continent, year, life expectancy, population, GDP, ISO alpha, that is the country, continent name, ISO num. I have taken year to be the animation frame. That is, based on the year, the bubbles would actually increase. The size of the bubbles would increase. So let's see. This is what it looks like. Now see the magic. See how the population increases. It shows how with change in years, the population has been increasing. So see this. In 1957, okay, so see this, in 1957, it was less. It is increasing as the year increases. Obviously, we know that population all throughout the countries mostly has been increasing. And that is the reason every, plot is increasing in their size. So this is how you can actually play around using different sort of animated graphs. These are stuff we use while presentation, but for analysis purpose, we normally tend to stick to the 2D graphs because there is a lot of things to be analyzed, and using 3D graphs necessarily takes our time and, most importantly, the resources of computer. You would need a high GUI and more usage of your RAM. Therefore, and CPU as well. Therefore, it's advised that use this type of graphs, animated graphs or 3D plots, only when needed, and especially during presentations. So with this marks our end to visualization. There is a lot to cover in visualization, but these are some of the basic things that we would want to know in order to get along in some of our real life projects. Okay, so this was quite it. The next topic we will be taking into account is statistics, the much awaited thing, which will also help us clear some of the doubts that we might have had during this particular series of lectures. All right, that said, bye guys. See you in the next lecture. Hello everyone. In this module, we'll be learning about statistics for data science. Now, statistics play a very major role in data science. It helps us to understand the different operations that we would want to perform and the mathematics behind it. So let's understand the crux and the basic stuff that we need so as to move forward in our journey. All right. Now, before understanding statistics, let us understand the different types of data that we would encounter. So data can be broadly classified into two types: categorical data and numerical data. So as the name suggests, categorical data are qualitative in nature that cannot have any mathematical functions as such, while numerical data are quantitative in nature, wherein we can perform all sorts of mathematics. Now, categorical data in turn can be subdivided into another two types. The first being known as nominal data, and second is ordinal data. So what are the differences between nominal and an ordinal data? Now, nominal data are categorical data or qualitative data that cannot be ordered. For example, the example that is given, male, female, or maybe the different departments present in an office workspace. While on the contrary, ordinal data can be ordered. For example, minimum, medium, maximum. So when we say that it can be ordered, we would want to say that, let's say we want to classify something. Let's say we want to classify a length. So I suggest that the client suggests that if length is less than the threshold, it should be classified as minimum. If length is between the maximum threshold and the minimum threshold, it should be classified as medium. And in case length is greater than threshold or the maximum threshold, and let this be minimum threshold, in that case, term it as maximum. Therefore, although minimum, medium, and maximum are not numbers in itself, but they can be used to contain a group of numerical data, which in turn can be ordered. Hence, these are called ordinal data. So this is the very basic difference. Names, different names, like let's say Jacob. Let's say Jacob, Julie. This can be classified as nominal data. Whereas, let's say, what can we say? Okay, this is a good example, that minimum, medium, and maximum. This is an ordinal data. Now, coming to the next part, that is numerical data. This can again be classified into another two types, discrete and continuous data. So discrete are those numbers which are discrete but not continuous. For example, 1, 47, 52, right? All this. So yeah, 1, 47, 52. All this are discrete data. And continuous data are those which are continuous, which cannot be which cannot be discretely pointed out. For example, 1.7, let's say 36.71 and stuff. These are called as continuous data. All right. Now, if we draw a graph, I just want to plot a graph. Okay. If the numbers are discrete, or if the data type are discrete, then the points would somehow look like this. It would be discrete points, like we saw in scatter plot. However, if these are continuous, the data would be it can be represented using maybe a line graph or something like this. It will be continuous. This is the entire structure of data. Categorical and numerical, categorical being divided into nominal and ordinal, while numerical being divided into discrete and continuous. All right. Now, so these are some stuff, the theory which I have already explained, what nominal and ordinal data is, how numerical data can be classified into the two types, discrete and continuous. So these are what it is. Now that we have learned about the types, various types of data, let us understand what statistics actually is. So statistics is the study of collection, analysis, interpretation, and presentation of data. In other words, it is a mathematical discipline to collect, analyze, and summarize data. All right. Now, statistics in itself can be divided into two broad parts: descriptive statistics and inferential statistics. So I've already introduced about predictive and prescriptive analytics. So predictive and prescriptive analysis falls under inferential statistics. There is a slight difference. Descriptive statistics and what I have explained is descriptive analytics, right? So statistics mainly are of two broad types, descriptive and inferential. And inferential contains prescriptive, predictive, and stuff like that. Now, what we will be dealing with in this particular course is descriptive statistics. Some of the most important parts of descriptive statistics is measure of central tendency and measure of variability. So, what do you mean by central tendency? We'll understand this as we move towards the next slide. So basically, these three are the measures of central tendency: mean, median, and mode. While measure of variability are several, for example, range, variance, dispersion, standard deviation, and stuff. All right, let's understand each step by step. So descriptive statistics allows us to analyze and summarize data and organize the same in the form of numbers, graphs, bar plots, histograms, pie charts, etc. Descriptive statistics is simply a process to describe our existing data and not what the future entails. It transforms the raw observations into some meaningful data and can be further interpreted and used. What is inferential statistics? It is used to draw conclusions based on small samples collected from the entire population. For example, during an election poll, maybe people would want to predict who the winner would be, even before the winner is actually found out. So that can be done based on inferential statistics, based on the surveys, based on all the data collected from various parts. So maybe whole of India is this, the total amount of data. And we would want to collect some amount of sample from this to this. So if total there were 100x data, I have collected only 10x, 10% of the data. Now this particular data can be, inferential statistics could be used into this particular data set. And by using inferential statistics, we could gain some insights on the likelihood of the winner. Do we get that? We take from the whole sample of data, let's say the vote for Prime Minister is being taken from whole of the India, and instead of taking all the data, I take 10% of the data from each city and use some inferential statistics into play. It would help us gain some insights on the likelihood of the winner, not the exact winner. It can never actually predict the exact winner, but it would readily give us a likelihood of the winner. And in most cases, that would be the winner if you follow the data properly. So that's what inferential statistics does. All right. Now, descriptive statistics, under it falls the measure of central tendency. So what is central tendency? It is a single value that attempts to describe a set of data by identifying the central position within the set. What it essentially tells us is, we will understand through the example itself. So mean, median, mode are valid measures of central tendency. So what it tells us that there might be a data set. For example, the data set that is given over here, 4, 7, 5, 6, 5, 81. And if we want to know the tendency of this data set, like in physics, we know that, let's say we have a particular man, right? And there is something called a center of mass, right? The determination of whether body could stand or will fall or where the weight it is all determined by center of mass. Similarly, the central tendency is the tendency of the data, the entire data set. This is a very small data set that I have taken, but generally, central tendency is the central tendency of the data, what the data wants to show us. Not all the data would agree to that. However, this is the tendency of the data. So 3 measures of central tendency are mean, median, and mode. What is mean? Mean is simply the average. So what we do is 4 plus 7 plus 5 plus 6 plus 5 plus 81 divided by the total numbers present, which here is 6. So on computing the same, we find 18 to be the mean. When median, for median what we do is, first we need to make them arrange in an ascending order. So 4, 5, there are 2 5s. So 4, 5, 5, right? 4, 5, 5, 6, 7, 81. 6, 7, and 81. And now what we need to do is we need to find the midpoint. So the midpoint is the average of these two numbers, which is 5.5. And that is exactly what the median is. Again, what is mode? Mode is the most frequently occurring number. That is the number which occurs most frequently. Here, all the numbers occurs once except 5. Therefore, 5 is the mode. Alright. So these are the basic measurements of central tendency. Central tendency helps us to tell what the data actually tends to suggest. Now, measures of spread and variability. If the spread of the values in a dataset is large, use median. What we mean by this is, let's say we have a dataset wherein all the values lie near about, let's say 24. So let's say 24. The next data is 25. The next data here is 23. Again, there is a data called 22 and 26. So we can take mean over here, right? Because mean would actually suggest that it doesn't really matter if you take a mean or median, but you can take mean because the process is quite simple. You do not have to arrange it and then use all those stuff. You can genuinely add them up and divide by the total number of numbers present. And it will give you proper value, a proper result. However, what if the data is not uniformly distributed, if it is very large? Let's say one data is 1, the next is 25, the next is 371, the third one is, okay, even if this is what the data is, wouldn't it be difficult to find the mean and tell that this is what the data says? It's typically not. For example, what if we take this particular data set, 22, 23, 24, 25, 26. Obviously, we know that the mean here is 24 and the median is also 24, right? What if another friend adds up whose age is, let's say, 60 years? The mean would shift highly in this case. However, the median would just be the mean of 24 and 25, which is 24.5. Therefore, in this case, we might say that the median has not shifted. Therefore, the central tendency of the data is still protected. However, in case we use mean over here, the central tendency would not be protected. I hope you get the idea when to use mean and when to use median. Now coming to another concept called range. What is range? Range is the upper limit minus lower limit. So here the upper limit is 81 and lower limit is 4. Therefore, range is 81 minus 4, which gives me 77. That is quite the range. What is variance? So variance has a typical process to be followed. First, we need to find the mean. The mean here is 18, as we found out earlier. Add them up, divide by 6, we get 18. Next, what we need to do is subtract each number from the mean and square the result. So what we do over here is 4 minus 18 whole square. That is 14 whole square, which gives me 196. Then 7 minus 4 whole square. That is, I'm sorry, not 7 minus 4, 7 minus 18. 7 minus 18 whole square, that is 11 square, which gives me 121. And so on and so forth, it would go on and on. And these are the numbers that we get along the way. Then what we need to do is we need to add this number up, all the numbers. And on summation, we get 4, 7, 6, 8. Now what we need to do is we need to divide the result by the total number of digits present. Now note, if the number of digits present is very less, then what we do is divide by n minus 1. Here, since the number of digits present is 6, we use n minus 1. However, if the digits is greater than 30, we use divide by only n. So here it would be n minus 1, that is 5. And this gives us 953.6. So this is our variance. Here is a step-by-step illustration. First, find the mean, then subtract each number from the mean and square the result. This is what we get. Add these numbers, we get 4768. Divide the result by the total number of numbers in the dataset. In case the sample size is small, divide by n minus 1. Here it was small, so we divided by n minus 1, and it gave us 953.6. So this is entirely what variance looks like. All right. Now coming to inferential statistics. One important part of the inferential statistics is the Gaussian distribution or the normal distribution. It is also known as the Gaussian distribution. Also known as Gaussian distribution or bell curve. Normal distribution kind of looks like this, which is also called as Gaussian distribution or bell curve. Why bell? Because it kind of looks like a bell. And from there, the name came bell curve. It is essentially a probability function that describes how the values of a function are distributed. A symmetric distribution wherein most of the observation clusters around the central peak. So in normal distribution, most of the data actually centers around the central peak, right? Let's move to the next slide and see how a Gaussian distribution actually looks like. So this is an example of a Gaussian or a normal distribution. It also states that if you actually, the midpoint is the median. So it has a 68% of confidence of being correct. If you want your correctness to be 95%, go one step, one standard deviation, both left and towards right. And this would significantly increase your confidence to 95%. All right. Okay, I'm very sorry. So this is the median. And if you go by one standard deviation, your percentage of answering becomes 68%. The percentage of confidence increases to 68%. If you go 2 standard deviation on each sides, so what happens is your confidence level increases to 95%. And if you want a 99.7% confidence, move each side by 3 standard deviations. So this is a very important thing. When we want very accurate results, we move 3 standard deviations on both sides, which is also called, the standard deviation is also called as sigma. So it is said to be 3 sigma. You perhaps have heard about 6 sigma. So this is on the way to move to 6 sigma. All right. Now, one important thing over here is standard normal distribution. What is a standard normal distribution? It is same as a normal distribution that undergoes a standardized process. What is a standardization process? A standardization process is a transformation wherein the mean is transformed to 0 and the standard deviation is transformed to 1. So instead of the mean being any number, it has been, whatever the number is, it has been transformed to 0, and the standard deviation has been transformed to 1. In that case, the whole data has been compressed and that is called a standard normal distribution. So I hope this part is clear as well. Again, one more concept that we need to understand is skewness. What is skewness? Skewness is the degree of distortion from the symmetrical bell curve. That is, normal curve usually should look like this, but it isn't always the case. There might be sometimes it might have a long tail on the right, or at times it might have a long tail to the left. So these are skewness. All right. How is skewness measured? Skewness is equal to 3 times median minus mean by standard deviation. So 3 times median minus mean by standard deviation. Based on the value of the skewness, SK value, skewness can be of 3 types. If the value, this is called as SK. If SK is greater than 0, we call it positive skew or right skew, which looks like this. Here SK is greater than 0. If SK is equals to 0, we call it zero skew, which is a normal bell curve. And if SK is less than 0, we call it a negative skew. So this is a negative skew. Alright, so this is all about skewness. Now let's understand properly how the graphs looks like. So no points for guessing. This is a positive skew because the tail is towards the right. So we will have SK greater than 0. Here, the median will always lie in the midpoint. The mean will lie towards the right of the median, and mode is always the point which is at the top with maximum frequency. This is a symmetrical distribution wherein SK equals to 0, that is no skewness is present. Here all mean, median and mode lie on the same point, which is the ideal case. And this is negative skewness wherein SK is less than 0. And here mode will always lie at the point where the maximum convolution takes place. Median lies to its left and mean further left. This is all about skewness. Now, an important theorem called the CLT or the central limit theorem. What it states is that the distribution of the sample means approximates to a normal distribution as the sample size gets bigger and bigger. What it means is when your sample size, as I said, for the voting example, there were 100x total data and I was taking 10x from it. So I had taken only 10%. What if I had taken more? What if it showed some skewness in it? Let's say it was a less skewed data. What if I increased it to 20x? Slowly, the skewness will try to be removed. What if I increase to 30x? It would get better and better. If we include considerable amount of data, let's say more than 50x, let's say 60x data, the graph would be proper bell curve. That's what the theorem says. Doesn't really matter if the data had skewness in it. It would still be a bell curve. So sample size should be greater than equals to 30 for CLT to hold. That's what it says. As I said, this will hold true regardless the source population is normal or skewed. Even if the source population is not normal, even if it is skewed, the graph would still be a normal curve. One key aspect of CLT is that the average and standard deviation of the sample means is equal to the population mean. That is, what it tries to say is that even if you take 60% of the data, the mean that you get, the standard deviation that you get, is in line with the mean and standard deviation of this original data, the population data. That's what it says. So I've taken an example over here. Assume an investor wants to analyze the overall returns of a stock index that comprises of 1,000 equities. All right. In this scenario, the investor may simply study a random sample of stocks to cultivate the estimated returns of the total index. At least 30 randomly selected stocks across various sectors need to be sampled for CLT to hold true. What it means is the trader or the investor wants to analyze the returns of the stock index. And there are 1,000 equities, right? So there are 1,000 equities. What the CLT tells us is that if he at least takes 30 output data, 30 sample data from all these 1,000 equities, instead of how many data are there, the inference that these 30 into 1,000 equities, 30 data for each 1,000 equities, that is 30,000, would show the inference shown by this data would be in line with actual data. So many a times the data is so humongous that we have to stop from taking all the data. In that scenario, what we do is we take parts from the data set and perform all the activities. This part should be at least 30 from each data. And as a result of which we get also what the CLT theorem states, that is the central limit theorem states, is this particular data will act in line with the original data. Its mean, its standard deviation would all synchronize with the original data. That's how things work. All right. Now we'll be moving to the the lab session to see how we import the mean, median, and mode and everything. So here, what we see is the first thing that we'll be understanding is the measure of central tendency. So first thing we import is the statistics library. And I've taken a sample, the same sample that I've been using all the time. So I've taken sample 2 times. Let me remove once. So import statistics and sample is equal to this particular list. Now, if you want to find the mean, we use the function .min. Statistics .mean of sample, that is of this. It instantly gives me the value 18. What if I want to find the median? I write statistics.median of sample, which gives me 5.5. What is the mode? We can see 2 times 5 and all the data once. So statistics.mode sample, we get 5. Now what if we want to find the variance that we have already found? It would be statistic.variance of sample, and it automatically gives us the value. Now, there is something also called as standard deviation. What is the relation between variance and standard deviation? So typically, standard deviation equals to root over of variance. So that is exactly what it is. 953, root over of 953 gives us 30 point something, which in this case, statistics.standard deviation, STDEV, STDEV, standard deviation. So statistics dot standard deviation of sample gives me the value of the standard deviation, which is root of the variance. All right. Now moving to the inferential statistics. Here we'll be understanding how skewness works. So the libraries that we need over here is SciPy. So what I have done is from scipy.stats import norm. Norm is for normalized function. I have also imported NumPy. I've imported Seaborn and Matplotlib and warnings as the usual. All right. So SciPy actually is the full form for, is the abbreviation for Scientific Python Library. Here all sorts of computational libraries functions are present. Now, what I'm doing in this particular form is I want to create a normal distribution. All right. So what it shows here is I've taken data equals to norm dot RVS. Size I've taken 1000, LOC equals to 0 and scale equals to 1. So this line of code generates a sample of 1000 random variables drawn from a normal distribution with a mean of 0 and a standard deviation of 1. Therefore, what it essentially means is it draws a normal distribution with 1000 odd data with mean being 0, that is a standard normal distribution, and standard deviation to be 1. Now data is the collection of all this data that forms a standard normal curve. Now when we want to plot it, what we do is sns.distplot of data. I've taken 100 beans instead of 1000. For 1000 data points, I've taken 100 beans. Therefore, each bean would contain 10 data points. KD equals to true. KD is this particular plot. And color I've taken to be green. I've also taken the X level to be as value, Y level to be as density, and the title to be as normal distribution. Now, when I say plt.show, I get this particular normal distribution. All right. So this is the process of taking a normal curve. Essentially, data holds all the data points that, when visualized, will give us a normal curve. Now, what if we want to draw some skewed curve? So for skewness, we do understand that the value cannot be normally distributed, right? So what I've done over here is I have introduced some skewness, some defects or outliers, whatever you want to call. So I've taken data to be all the data from 50 to 100 with interval of 2, that is 50, 52, 54, 56 up to 100. And then what I have done is I have appended 200 to it, right? Now when I do a KDE plot with data, let me first show how the data looks like. Then you'll get quite a good understanding. We do that first. So this is what the data looks like from 50 to 98. Now what I've done is I've appended 200 to it. And now the last point is 200. So previously, my average, my mean, have I imported the statistics library? Let me check real quick. If not, let me quickly copy it. So import statistics. Okay. sorry. I need to import statistics. Now statistics dot mean of data, right? Let me comment this out. What I also want to do is find the median. Perfect. Okay, I need to print it as well. Otherwise, only last thing would be shown. Right? So we see that both the mean and median are same. Correct? And this data would be, okay, quickly. So if you see, this data is a normal distribution curve, right? Now, what if I actually append, right? What if I introduce an outlier? You see, my mean is now 78, while median is 75. So there has been introduction of some outliers. Let's see how the curve looks like. This is how the curve looks like. Now, it is typically right skewed, right? The tail is towards the right. So it has been skewed. It is skewed towards the right. Similarly, if we want a zero skew, what we do is we do not introduce any anomalies as such. And if we want a negative skew, that is a left skew, maybe we would want to introduce something as, here what I have introduced is 2. Because the data starts from 50 and I have introduced 2, it gives me a left skew. So I hope this process altogether was clear. What is inferential statistics? What is descriptive statistics? What is the CLT, that is central limit theorem? The different types of data. If all these are very, very clear, we'll, in the next session, meet with hypothesis testing, which is again an important chapter for data science. Hope to see you all in the next lecture. Bye, guys. Hi, everyone. In this module, we'll be learning about hypothesis testing. So what is a hypothesis testing? To understand this, let us first understand what a hypothesis is. A hypothesis is basically a guess or an assumption about something that can be tested or proved to its sanctity. So it's not just any ordinary assumption, it's an assumption that can be proved or tested. So there are basically two types of hypothesis: the null hypothesis and the alternate hypothesis. The null hypothesis is a general statement which states that there is no difference between the two samples derived from the same population. What it essentially means is that, as I said, there would be a big population wherein, let's say, there are 100x data. From it, we have taken a small sample of 10x data. So and let's say I'm claiming that the data here, the data of the sample, is exactly same or gives the same result as the data of the population. In case you do not know, the larger data is always called the population and the smaller data is called a sample. So what the null hypothesis does is it syncs with me. It says that yes, whatever you say is correct, that the sample data is in sync with the population data. What the alternate hypothesis does is it states the completely opposite statement to null hypothesis. It states that what you are saying is wrong. This sample data is not a representative of the population. All right. These are the basic two terms. Now let us understand how do we use them. So let us take a scenario. Let's say there's a bulb manufacturer who claims that the bulbs produced by them has an average lifespan of 500 hours. All right. So what does the null hypothesis does? It says, yes, you're correct. The average lifespan of the bulbs is equal to 500 hours. The alternate hypothesis says, no, what you're saying is not correct, and the average lifespan of the bulbs is not equal to 500 hours. This is as simple as this. All right. Now, there might be some errors regarding it. So there are basically two types of errors, type 1 and type 2 errors. The type 1 error is represented by alpha, while the type 2 error is represented by beta. What are these errors? Type 1 error occurs when we falsely reject a null hypothesis. So let's take the previous example. Let's say that this manufacturer was right and the null hypothesis was correct, that the average lifespan of the light bulbs is 500 hours. However, we falsely rejected this particular hypothesis. Then we would undergo a type 1 error. And what if it was actually false and actually the alternate hypothesis was correct? But still, we chose to accept the null hypothesis. In that case, we say it is a type 2 error. Now let's understand the definition. It occurs when falsely rejecting a null hypothesis. So when you falsely reject a null hypothesis, type 1 error occurs. And type 2 error occurs when you falsely accept a null hypothesis. So the example has been given here as well. From the previous scenario, if the average lifespan of the bulbs is 500 and we reject it, we undergo a type 1 error. However, if the average lifespan of the bulbs is not 500, but we accept it, we undergo a type 2 error. So that's all about type 1 and type 2 errors. Now, what is level of significance? It is basically the degree of significance in which we accept or reject a null hypothesis. No hypothesis, right? A null hypothesis cannot be 100% accurate. So we need to have a level of significance attached. And this degree of significance is what we call as level of significance. We usually take a value of 5%. So a level of 5% significance is kept as the threshold level of significance. This is normally denoted by the alpha. It is same as the previous alpha that we understood, that type 1. The source of the alpha is same. All right. Now, so let's understand this particular curve. This is the bell curve as we see. So this region over here is the non-rejection region. So if our data falls here, it would be not rejected. It would be accepted. However, these are the critical regions out there. This is said to be the rejection region. Now the rejection region might be one-tailed or two-tailed. Okay, we'll come to this in the next set of slides. So this is what you need to understand. The rejection region or the critical region is denoted by alpha. And since it is a two-tailed region, the alpha has been divided into two parts, alpha by 2 here and alpha by 2 here. As I said, this is also known as the critical region where the test occurs. So critical region is an area which gives us the statistical significance to reject or fail our claim. Now the tailed test, as I said, one-tailed test or two-tailed test. The graph that we saw here earlier was a two-tailed test where both the ends were rejected. So alpha was divided by alpha by 2 and alpha by 2. In case only one end is rejected, we say we give this value to be alpha. And this is a one-tailed test. It can be either way. it can be as such. This can be alpha as well. So for one-tailed test, a test of a statistical hypothesis where the region of rejection is on one side of the sampling distribution, only on one side. E.g., a college has either greater than equal to 4,000 students or less than equal to 4,000 students, but not both less and greater than 4,000 students. And a two-tailed test is a statistical hypothesis wherein the region of rejection is on both sides of the sample distribution. E.g., a college does not have 4,000 students. That is, it also has greater than 4,000 students and also less than 4,000 students. So if this is the region for 4,000 students, let's say for two-tailed test, some data lies over here as well, some data lies over here as well. But for one-tailed test, the data lies either here or here, this being the 4,000 level data point. So I hope the tailed test theory is clear. The same thing has been drawn over here. So this is one-tailed test and this is a two-tailed test. Now coming to another important concept called p-value. What is that? So we'll be using this p-value concept a hell lot of times. And there, mind you, there is a way of calculating p-value, but we won't be learning all those things because this is beyond our scope of learning. We would only understand the significance of p-value, and Python for us will compute the p-value. If you are from statistics background, you would know how do we calculate p-value, and you would want to calculate it by pen and paper. But right now we have Python to our rescue, to our aid, and Python will help us calculate the p-value, and based on that, we will decide if we want to reject or accept the null hypothesis. So before that, let's understand what the p-value is. Just a basic understanding. P-value, or the calculated probability, is the probability that the null hypothesis is correct. So p-value basically suggests if or if not the null hypothesis is correct. Right? And how does it do that? Okay, so it stands in support of the null hypothesis and it lies between 0 and 1. Now, if p-value is less than the significance level, all right, we reject the null hypothesis. And if the p-value is greater than equal to the significance level, we fail to reject the null hypothesis. So the significance level is 5%, right? We chose it to be 0.05. So if p-value comes out to be less than 0.05, we reject the null hypothesis. On the contrary, if it is greater than or equal to 0.05, we fail to reject, that is, we accept the null hypothesis. Another important concept is degree of freedom. What is degree of freedom? It is basically the number of values in the final calculation of statistics that are free to vary. We calculate the degree of freedom by the formula n-1, where n is the sample size. So for example, let us take there are 10 values, the average of which is 5, right? 5 is the average. What is the total? It would be simple, 10 into 5, that is 50. Now, the first value can be anything, right? Can be anything. It can be minus 999 or something, even less than that, or maybe it's 999 or even more than that. Nothing, anything. It can be anything. Still, the rest of the 9 values can compensate and have the average as 5 or the total as 50, right? Similarly, the second value, so this is the first value. Similarly, second value can be anything as well, right? Because even if the first and second value both are anything, the rest 8 values can compensate for the 2 values and bring the average down to 5. The third value can be anything again. Fourth value can be again anything. So what do you think? For how many values can we take any values? If the total number of values here in this particular data set was 10, we can take 9 values as we like. And the last value, that is the 10th value, would be readjusted in a way so that the average becomes 5. That is possible, right? Therefore, if in a data set there are n values, n minus values can be allowed to vary as it likes. But the last value should be constant or should be dependent on the n minus 1 values so that the average and the total remains the same. So this is what degree of freedom is. The number of values that are allowed to vary. And in a dataset which contains n values, n minus 1 values are allowed to vary. Therefore, the degree of freedom is n minus 1. So in a sample size of 10, the degree of freedom is 10 minus 1, that is 9. Now, how many hypothesis testing are present? The different types of hypothesis testing. So we have t-test, which is also called as student t-test. We have the z-test. We have the ANOVA test, analysis of variance. So ANOVA stands for analysis of variance. And we have the chi-square test. The t-test is used when we do not know the standard deviation. Alright, the standard deviation is not known and the sample value is less than equal to 30. But probably less than 30, not less than equal to. The z-test is done when standard deviation is not known and the sample size is greater than equal to 30. ANOVA, that is analysis of variance, is done. So both this can be done using single data set or 2 data sets, paired t-test or z-test. But if we have more than 2 groups, what we do then? Obviously, we can do a series of t-tests or z-test as we like, but that would give us type 1 error, that is prone to type 1 error. Therefore, what we do is we use another kind of test called as ANOVA test, which helps us actually test more than 2 groups. Right? And what is the significance of chi-square test? It is used for testing categorical variables. Now, all these 4 tests have a complicated way of computation, which we will not be learning in this particular course. All right. That is primarily because this would become very much overwhelming and we need not know the internal working at this particular point of time. Just understand when do we use which test. And if you have any interest, you may very well go and Google it out. And there are actually, these tests are taught in people who study statistics, bachelors of statistics. These are semester-long programs wherein all these tests are taught. So as it is, we do not have enough time to cover all these tests. But what we will do is, we will understand what these tests do and where can we use it. All right. So let's move to the lab session and see how do we apply these tests. All right. So now we come to the hypothesis testing. These are the theory that I have already taught. I have a free will to go over and check what is written. So t-test. What is a t-test? It is a type of inferential statistics. So a t-test is a type of inferential statistics. It determines if there is a significant difference between the means of two groups which may be related in certain features. It occurs when the sample size is less than equal to, okay, so it is less than equal to, I keep on forgetting if it is less than equal to or less than, and therefore z-test would be greater than 30. Anyway, so it occurs when the sample size is less than equal to 30 and the population standard deviation is unknown. The different types of t-tests that we would undergo are one sample t-test, two sample t-test, and paired sample t-test. One sample t-test. It says that one sample t-test determines if the sample mean is statistically different from the known hypothesis, from the known hypothesized population mean. So we would know we already have an hypothesized population mean and we have a sample data set. What we need to, let's say we have a hypothesized population mean of cutoff score for entering into a particular college, it will be 95%. And I also took out some sample data wherein all the people here got into that particular college. Now, the mean of this data would be compared with the population mean using t-test. And if the p-value is greater than the threshold, that is 5% or 0.05, then we'll say that the null hypothesis is true. That is, this sample mean is an exact representation of this population. Otherwise, we'll go to the alternate hypothesis. So the example that has been taken over here is, we want to calculate the blood pressure of 20 first-year resident female doctors and compare it to the general public population whose mean is 120 mmHg. So the null hypothesis here is there is no significant difference between the BP of the two populations, or the BP of the resident female doctor and general population. And the alternate hypothesis states that there is a significant difference between the blood pressure of the resident female doctors and the general population. What we do over here is we import the statistics library, and from some SciPy we import stats. Now the list of the blood pressures of the female doctors has been listed down, and now what we do is we perform the t-test. The syntax for it is stats.t-test underscore one sample, because it is a one sample t-test, followed by the sample, that is female doctor BP, followed by the hypothesized population mean, which is 120 here. When we do that, we get the value of, we are interested in this particular value, just ignore this as of now. So we get the p-value to be 0.002, which is far less than 0.05, which is 5%. So the conclusion is, p-value in this case is 0.002, which is far less than the standard threshold of 0.05, and therefore we reject the null hypothesis. That is, we accept the alternate hypothesis, which states there is a significant difference between the BP of the resident female doctors and the general population. Now, what is two-sample t-test? Two-sample t-test or independent sample t-test compares the means of two separate samples in order to determine the sample means are statistically different from one another. So here we already knew the population mean. What if we do not know? What we do then is, from the population itself, right, we take two samples. small samples. And we compare these two samples using two-sample t-test to understand if these are in sync. And if these are in sync, they will automatically be synced with the data, the population data. So what we have done over here is, we want to compare the blood pressure of male consultant doctors with the junior resident female doctors that we explored above. So null hypothesis is there is no significant difference between the BP of male consultant doctors and resident female doctors. Alternate is that there is a difference. So the same list has been taken for female doctor BP, and for male consultant BP, we have taken another 20 different data. Now what we have done is stats.tTest followed by underscore IND. This is for independent or two-sample t-test, whatever you want to call it. And we have taken the two variables into account, female doctor BP and male consultant BP. The p-value that we have got over here is 0.001, which is again far less than 0.05, and therefore we also reject this null hypothesis. The two things is in line with each other. Had this had a p-value greater than 0.05, there would have been a problem, because in that case, this particular data says that the female doctor VP is in sync with the male consultant VP and hence with the population generally. While the one sample t-test says that the female doctor VP is not in accordance with the hypothesized population mean. So both this one sample t-test and two sample t-test would not have been in line had the p-value here been greater than the threshold. Since it is not as such, the statistical parameters remain valid. Now we come to the paired sample t-test. What are they? The paired sample t-test, or the dependent, it was the independent and this is the dependent sample t-test, compares the means of two related samples in order to determine if the sample means are statistically different from one another. So here they were independent and here it should be dependent. Let's look at the problem statement. We want to compare the amount of sleep got by patients before taking a sporotic drug to help them sleep. So the question is, if sporotic drug have any effect in the sleep cycle of the patients. The null hypothesis says it does not, while the alternate hypothesis says yes, it does. So we have taken two data sets. One is the control statement, that is before taking the drug, and one after taking the drug. And now when we compare the two, we get a p-value of 0.005, which is 0.5%, which is again less than the threshold p-value, for which we can say the alternate hypothesis is true. We reject the null hypothesis and the alternate hypothesis is true. How do we use this paired sample t-test? It's stats.t-test underscore ren, or relative. So hope this p-test, the three types of t-test, are clear to you. Now we move to the z-test. What is that? It's same as t-test, but the only difference is the sample size should be greater than 30. Everything remains same. Here we perform the one sample z-test and the two sample z-test. Now our problem statement is, we are testing whether the mean of house prices is 18 something, unit in 100, okay, 180,000. If the mean of the house prices is 180K, this is what our problem statement is. So the null hypothesis states that yes, the mean is 180K, while the alternate hypothesis states that it is not 180K. Now we have taken a data set, because the data should be greater than 30 and it's very difficult to calculate by hand, and therefore I have taken a data set. Now what I have done is, I've taken from stats model.stats import weight stats as stests. And from there, I have taken the z-test and p-value equals to stests.ztest. So stests.ztest is the method of computing the z-test. And here we get the p-value. Now what I have done is I have printed the p-value as well. And I have written a conditional statement which states if the p-value is less than the threshold, which is 5%, we reject the null hypothesis, else we fail to reject the null hypothesis. Now when we have computed, we get the p-value to be 0.65, which is 65%. And therefore, we actually fail to reject the null hypothesis. It gives me automatically, which states that the mean house prices is not 180K. It might be greater or less than 180K. But it is not 180K. Now we come to the two sample z-test. Here, the same thing we do. The problem statement that has been mentioned over here is we need to check if an association between the prices of the first and second floor houses per square feet. So we need to check if there is an association between the first and second floor houses. The null hypothesis says that the mean of first and second floor houses per square feet are equal. That is, the mean of the prices of the first and second floor houses are equal. Alternate hypothesis says that these are not equal. Even without undergoing the test, one would think that alternate hypothesis is true. Because obviously, the first floor houses normally cost more than the second floor houses. So let's see what it says. It says, I said the reverse way, right? The second floor houses, if there is 2-floored house, it would cost more. So what we do over here is, we do the same thing and we take into account the first floor and second floor. And on finding the p-value, we get that it's 0. There is absolutely no correlation. So p-value is absolutely 0. Therefore, we reject the null hypothesis. That is, the means are not equal. We reject the null hypothesis. That is, these are not equal. So this was quite about the z-test. Quite similar, only the difference being the sample data is greater than 30. Now we perform the ANOVA, which is analysis of variance. As I said, if there are more than if there are more than 2 groups, we use ANOVA. So let's see the problem statement here as well. It says, examine the means of weights of plants under control and 2 different treatment conditions is similar or different. So we need to examine if the mean weights of the plants under control and 2 different treatment conditions is similar or different. The null hypothesis says there is no difference, while the alternate hypothesis says there is a difference. So the values for the control statement has been given, and that for the treatment 1 and treatment 2 has also been given. What we do is we have imported stats library from SciPy, stats.f_one-way, which is the syntax for ANOVA. And we have taken all the 3 into account: control, treatment 1, treatment 2. Now we find the p-value, which is 0.015, that is 1.5%, which is again less than the threshold 5%, and therefore we reject the null hypothesis. That is, there is a difference. So this was, again, ANOVA is similar to the previous 2 tests, only we get to choose more than 1 group here. We could have chosen to, as I said, we could have chosen to use first control and treatment 1 and then with the result treatment 2. But then it would be susceptible to type 1 errors, and therefore we choose ANOVA instead. Now we have the chi-square test. This is used for categorical variables. There are basically two types of chi-square test. One is goodness of fit test, and another is chi-squared test of independence. So the first one tests if these are good to fit, and the second one tests if the two variables or the two samples are independent or dependent. So the formula for goodness of fit is chi-squared is written like this, chi-squared. E here stands for the expected value, right? And O stands for the observed value. So basically, what we do is observed value minus the expected value whole square divided by E. That is the expected value. So this is the formula to test goodness of fit. How good it is to fit. All right. So what we have done over here is I've created a data set consisting of white, Hispanic, black, and other population for a national territory. And inside this national territory, I have taken another sample data of state, which contains the same groups, but in different proportions and in different numbers. Obviously, a state cannot contain as many people as there are in a nation. But I've also chosen to differ the proportion, right? Now what we do is we use this cross tab so that a cross culmination is done. And now when we create the data frame, we get, this is a series frame that we have created. So what we get, the national counts to be black as 50K, Hispanic as, this is 50K, this is 60K, 35K, and 100K. And for states, these are quite less. However, the proportion is also less. Now what I have done is, I have increased the number of state data to the number of national data in the same proportion though. So what I've done is observed is equal to state table, national ratios is equal to national table, that is this table, divided by the length of national, that is we get for 1, and expected equals to national ratios into length of the state. So we take the summation of the data to be same. Now what we do is we do the chi-squared test in it. So chi-squared, what do we call it? This sign, squared stat, and we take the formula into account. That is observed minus expected whole square divided by expected. And we take the sum for it. And this is the output that we get. So this is how we test, is it good to fit or not? Clearly 17 is not enough. The threshold is obviously declared by the problem creator or the client, if whosoever is the owner of the data. But 17 in itself is a very less value. So this is not good to fit. Next, we come across test of independence. What is test of independence? Independence is a key concept in probability that describes a situation where knowing the value of one variable tells us if we know anything about the other variable. Example, our height probably does not tell us anything about the web browser that we use. Therefore, they are independent, right? Our height, the different heights of a people in a school, let's say, does not tell us about the web browsers they would want to use. However, our height probably do tell us if we excelled at a particular sports in school. For people who are tall, generally are seen playing basketball. So these are dependent somewhere. So the task of the chi-square test is to check whether the two variables are dependent or independent. So let's understand the same by a problem statement. Let's test if knowing land contour, which is the overall flatness of the property, tell us anything about the price. Null hypothesis says it does tell us something about the price, while alternate hypothesis tells us that it does not tell anything about the price. So what I've done over here is I've taken the data. This is what the data looks like. Now what I've done is I've created a function for computing the chi-square test, and in it I have taken the p-value. I've taken the cross tab for x and y. All right. So this x and y has been replaced here by the land contour and the sales price. And it gives me, by virtue of cross tab, the p-value, which is printed. So the p-value, if we see, is 0.086, which is 8%, which is greater than the threshold of 5%. So we accept the null hypothesis, which is the land contour does tell us something about the price of the property. So the conclusion is the two variables are not independent, and it does tell us something about the price. That is, it is dependent. The two variables are dependent, land contour and sales price. So this was all about hypothesis testing. And this marks the end of our module of statistics. In the next lecture, we'll be learning about EDA, that is Exploratory Data Analysis. Hope to see you in the next one as well. Bye guys. Hi everyone. In this lecture, we'll be learning about Exploratory Data Analysis, in short, EDA. So the main goal of EDA is to obtain confidence in our data so that we can apply machine learning algorithms confidently to the dataset. It also refines the selection of features which will be used to build the ML model. Now, some of the important features of EDA are as follows. It helps us to discover patterns, spot the different anomalies, test our hypothesis. It helps us create a summary of statistics, and most importantly, it helps us present graphs, the data in the form of graphs. Now, skipping EDA might be a very bad choice because our data that we have might have some outliers. It might also contain some missing values, and mostly the data might be skewed. So EDA, on performing EDA, it helps us get rid of all these three elements. And therefore, EDA is a very important part of data science in our data science journey. Now, some of the best practices for EDA are using the Pandas profiling library. This, although we will be learning, this is used at a very later stage once we actually learn how to perform EDA by our own. And for instance, in our Capstone project, we won't be actually using the data profiling library. However, on usage of this particular library, you will see how beautifully and how quickly we can actually discover an overall report of our business problem. So basically, the Pandas profiling library provides us with an instant overall report of the data. the time-based features. So basically, a lot of information such as year, month, etc. can be extracted, which can improve our analysis and predictive power. The color gradients. Using color gradients, results can be evaluated. On using color gradients, the results that we get can be evaluated with just one glance, as it provides with clean and elegant visualizations. So performing analysis is on the one part, while visualizing the stuff using graphs and color gradients is another part. It actually enhances the beauty of the representability, and therefore we use color gradients. Interactive plots does the same. It helps us, it creates an interactive plot, and as we have seen in Plotly, when we hover our mouse over the graph, we see different values for different regions. Therefore, interactive plots also play an important role in the course of representability. All right. Now, two important libraries that we would want to know here are the DABL library and the Sweetviz library. So what is DABL? It stands for Data Analysis Baseline Library. It basically focuses more on the exploratory visualizations and pre-processing, and has the following featured columns. So basically, it focuses on exploratory visualizations and data pre-processing. And these are the following columns that it has. The first is continuous, in which the continuous values with high cardinality lies. Second comes the dirty float, wherein float variables that takes string values, that is, fake float values at present, and that is why its name is dirty float. Next comes the low cardinality integers. Columns with integer values and low cardinality are the ones, data with integer values and low cardinality falls under this particular column. Next comes the categorical column. This said without explanation. Columns with categorical values in an int, float or string. Date. So columns with date falls under this particular column. Free string. Columns which contain multiple string values falls under this particular category. Useless. So constant or integers values that do not come under any category falls under useless category. Now we come to the Sweetviz library. So this library essentially is an open source library, and it generates beautiful high density visualizations. It also creates a ready-made report per se, like the data profiling library. It has the following functions. The first is analyze, to analyze a single data frame. Compare, to compare two data frames, usually the train and the test. And compare intra, to compare two subsets of the same data frame. So while compare actually compares two data from other sources, compare intra, what it does is, there is a single data set, it divides the data set into two subparts and compares them for better understanding of the data parts. All right. So now let us quickly move to the lab session. All right. So now what we are doing over here is, we have imported all the important libraries, and what we are doing is basically we are targeting the numerical target column. So this is a data set of insurance parts, and here the expenses is the target column, which essentially means that based on all these columns, age, sex, BMI, children, smoker or not, and region from where the person is booking the insurance, the expense for the insurance is determined, and therefore it becomes the target column. All right. Now we will be understanding how do we manipulate all the data to get to the target column. All right. So the first thing that we are doing is we are doing a descriptive analytics of the entire data set. And the form that we use for that is data.describe. And what we are getting here is age, BMI, children, and expenses, and the different statistical analytics for the same. Now, if we want to analyze the expense column only, obviously we can see from here, but a more better way of representing would be using the expense column only. So that's what we do, data of expense.describe, and we get the pure statistics of the expense column. Now here we see that the 75% falls below 20,000 while the maximum value falls above 60,000. There is a big difference altogether. So let us check for any outliers if present, which should be the case, no doubt. And on performing box plot, we see that there is indeed a lot of outliers. So these are parts of EDA that we do, and we'll be putting everything together when we perform the Capstone project. So we also perform the dist plot to understand if the data is skewed or not. And yes, we do see that the data is right skewed, which was again evident from the expense column altogether. The reason being, the median value is below 10,000 while the maximum value is 63,000, which is too much. Also, the 75% value is denoted below 20,000. So there should be a right skew, which is evident by the visualization of our dist plot. So this was all about taking the target column as a numerical column. What is our target column was a categorical column. So in this data set, what we are doing is we are taking a data set wherein the target column, that is species, is a categorical column. What kind of analysis would we do? So first we'll be doing a describe. However, in this particular describe, we would get only values which are numerical columns. If we watch it closely, the species column has been removed. So how do we take the analytics of the categorical column? What we do is we include object inside describe. So data.describe gives us an analytics of the numerical columns, while when we write in the parenthesis include is equal to object, we get the analytics of the object column. So now what we see is the count is 150 like others. There are 3 unique values for the species column, and the frequency is 50 for each. Since 3 unique, 50 for each, therefore 150. Makes sense. Now let us also understand what are the unique values. So what we'll be doing here is, we'll be taking, so the column is species, right? So data of species dot unique. It gives me the 3 unique values that are present. One is iris setosa, the second one is iris versicolor, and the third one is iris virginica. One important thing to add on it is, what if we want to get both the object and the numerical columns? So what we do then is we take data.describe followed by include equals to all, and then we also get the categorical column along with the numerical values, numerical columns. All right. So if you see closely, the first part, that is unique, top, and frequency, are NaN for all except the categorical column, and the rest, which was there for the numerical column when we wrote data.describe, are present for all the numerical columns, while it's NaN for the categorical columns. Therefore, include equals to all is something we do not necessarily would want to use all the time. We can separately use .describe and .describe include equals to object for handling categorical as well as numerical columns respectively. Now coming to the most important library for EDA, that is data profiling library. Again, just a short note. This library should not be used until you have become a pro in EDA. This automatically generates a report which might be very kind of difficult to read, because when we are novice in doing an EDA, we would want to do it ourselves, and later on when we become on the verge of being a pro, it's okay to use this kind of libraries. Right, that said, let's understand what it do. So data profiling is the process of examining the data available by performing descriptive statistics, informative summaries about the data. Data profiling helps us to make a thorough assessment of data quality and helps us understand the content, structure, and relationship about the data in the data source we are analyzing. So how do we go about it? First, we need to install the data profiling library. And how do we do that? We take a different cell altogether and write pip install pandas profiling space followed by 2 dashes and user. So since I already have this installed, it would show the requirements has been satisfied. But for you guys, do care to install it. So it would take a while to install this particular library. So it says that the requirements has already been satisfied, and that's all. So for you guys, it might take a little longer and it would get installed. Once it's installed, you have to import the library. That is, import pandas profiling. There should be an underscore between pandas and profiling. All right. So when we import it, this library is ready to be used. Now what we do is pandas profiling.profile report followed by the dataset that you are working on. The name of our dataset is data, and therefore when we run this particular cell, the process begins. All right. So it's summarizing data. It takes a while, but let's see what kind of resource that we get out of here. So now everything has been generated. Now let's see what beautiful structure of a report has been generated. So first, it gives us the overview, number of variables present, number of observations, missing cells if any, the number of numeric columns and categorical columns. You may want to hover over different sections as well. So this is the overview class. You can also go to variables, interactions, correlations, missing values, and sample. So variables, it says what kind of variables has been used, what is the maximum value, any zeros if present, negatives, what is the memory size, what is the mean value, infinites if any present, what are the distinct number of values present, and everything. It also gives us interactions. So you may want to choose 2 columns to interact. So let's say I choose sepal length versus sepal length versus, let's say, sepal width. So it gives me a scatter plot with sepal length, sepal width, and sepal length. Let's say you want to choose a petal length with petal width. So it gives me a, have I chosen the same thing? Yes, I've chosen the same thing. So obviously the graph would be very understandable. So let's take a different variable altogether, sepal length versus petal width. So it gives me a scatter plot like that. We can also take the correlations. So it gives me a heat map, and also we can take it in the form of a table in a tabular column, which gives me the values. So the heat map also gives me the values, but it may be a bit difficult. You cannot, if you create the heat map yourself, as I have taught in previous modules, then we can actually render the values over the boxes. But here, unfortunately, that cannot be done. However, we have the table in place, the same thing, so we can see it in a tabular column altogether. We can also see what kind of missing values are there. Since there is no missing values altogether, everything shows 150. And we also see the samples, the first few rows, last few rows, and everything like that. So I hope you understand the power of the data profiling library, but it does have some limitations. What are the limitations? As for instance, for correlation, in the heat map, we cannot render the values. And there are many other limitations. We cannot do whatever we want to do. And therefore, doing EDA from scratch, as we will be doing in the Capstone project hands-on, is quite important. All right. So that's all for this lecture. See you in the next, where we'll be exploring the two libraries, that is DABL and Sweetviz library. Hello everyone. In this module, we'll be learning about the DABL library. So first things first, we install the DABL library in the same way that we have installed the Pandas profiling library. We do pip install DABL followed by space followed by -- and user. So once we do that, it would get installed. I'm not doing that because it's already installed. Now what we need to do is we need to import all the important libraries and also the DABL library. How do we do that? Import DABL is the syntax for it. Now what we do is we read the data. So for this section, we'll be taking the diabetes dataset. So now when we read this data, what we get is a dataset of this sort. As we see, the outcome column is the target column. Now, how do we use the DABL library? So I'm creating a variable called data clean, which actually does the cleaning for the DABL using the DABL library. So it does dabl.clean followed by the data. The name is data. That's what we have taken over here. Followed by the target column name. Since it's outcome over here, we have taken outcome, and verbose equals to 1. We are taking the 1 as the verbose. Now, what we do is we clean the data. We get the output of this particular command. So data clean.head, and we get how many columns fall under which category, as we have learned in the previous session. So we see that the 7 columns are continuous. One is low cardinality integer and one is categorical. That's it. And the head has also been given. Now, we do not really know which column falls under which category, right? To do that, what we do is we also ask the DABL library to show us which column falls under which category. So for the command for that is dabl.detect types followed by the data clean, which actually segregates which column falls under which category. So when we do this, we get the different, which column falls under which category. So we see that pregnancies fall under low cardinality integer. We also see that glucose, blood pressure, skin thickness, and everything up to age falls under continuous data types. And the outcome is a categorical value. All right. Now, what we would want to do is we would want to see a plot, not a plot, but a series of plots determining comparing all the columns together. So the command for that is DABL.plot followed by data clean, that is the data set of the segregation data, followed by target column. And here it's outcome. So we have taken that as the target column. When we run this, we get series of plots. So the first thing is the target distribution, how many are ones and how many are zeros, followed by how glucose level actually impacts the target column, how the BMI impacts the target column, how all the others impact the target column. The scatter plots for the same has also been taken, and other things like PCA, LDA, that is linear discriminants, and everything has been taken. So we have not actually gone through what is PCA and linear discriminants, so do not worry for that. These are topics that are taken necessarily in machine learning. It's not even useful in EDA as such. So if we see that the scatter plot and the histogram plots for all the columns with respect to the categorical columns has been plotted, and the different insights can be drawn from that there. All right. So this was all about the DABL library. Now we move to the Sweetviz library. So the same thing, we import Sweetviz library by simply writing pip install Sweetviz. Now what we do is we install it. Now we import the library and pandas as well. And I've taken two data sets, that is train and test. Now let's see what kind of data or how the table looks. So for the head, we get a data set like this. And for the test data set, we get a data somewhat like this. Now when we want to generate a report on the same, what we do is the Sweetviz library helps us generate a beautiful report based on the comparison. Or as we have learned, it can compare, intra or inter, and do other stuff as well, analysis. Okay. So here what we do is, I've taken a variable, my report equals to Sweetviz.compare followed by the train and test data set, and I've taken the survived as the target column. All right. So when I let me quickly run all the cells as such, because it might give me an error if I'll not run all the cells together. Let me run it once more. Okay. So now it's generating the report. And once the report has been generated, we would want to render this. So it's on step 3 of 3. It has been generated, done. Now, how do we render this report? So what we do is my report is this particular thing that has been generated, .show_HTML followed by the name of the report that we want. So here I have taken report.html. Mind it, the extension should be HTML. Now once it's done, we get a report. Here we get a detailed comparison of all the columns of both train and test. So I can see what are the associations of train and that of test. How many have actually survived and not survived? 1 means survived and 0 means not survived. The detailed for the passenger ID column, P class, names, sex, age, parts, ticket, and everything, fare. We also see the detailed report on the right-hand side, the visualizations and everything. So these are libraries that we would want to use once we get a clear understanding of EDA from scratch, once we learn doing that. These are advanced libraries which helps in advanced report generation and in a very quick time. However, for specific reports that we want, with respect to the business cases, these libraries may not be that useful. However, it is always useful to generate some important insights. So that said and done, the topic of EDA is over now, guys. The next thing that we'll be doing is we will be performing an end-to-end Capstone project with the business case and everything. So we'll see how a business case is given in an industry and how that is performed. So get ready for that. All right. Bye, guys. Hope to see you in the next video. Hello, everyone. In this module, we'll be performing a Capstone project together. So the steps involved in a Capstone project is that we essentially have a business problem which is scattered by the client or customer. What we need to do is we need to understand the problem statement correctly, need to ask questions if any doubts are there, and then brainstorm on ideas as to what could be the actual reason for the said problem. Once we do that, we need to get relevant data based on our ideas. These data may be taken from Google, web scraping, or surveys as such. Once that is done, the data would be messy, containing a lot of unclean, dirty data. And we need to explore the data and clean the data. Once that is done, we need to analyze the data and derive some useful insights out of the same, using visualizations and other tools, whatever is necessary. Once that is done, we need to present our key findings in the form of reports or dashboards, whatever suits us. So for this module, we are given a data set. We are given a business problem. And for our aid, we have also been provided with a data set, which in real life is not done. So one of our problem of finding the data or doing survey, field survey and everything has been scattered. So let's work on understanding the problem statement and brainstorming some ideas, exploring and cleaning data, analyzing the data, which is perhaps one of the most important logical tasks that we need to do. And then we need to create a report based on our analysis that we would want to present to our client. All right. So the business problem given was that in recent years, city hotel and resort hotel have seen high cancellation rates. All right. Each hotel is now dealing with a number of issues as a result, including fewer revenues and less than ideal hotel room use. You were hired as a business analyst to analyze the situation and help them lower the cancellation rates and increase the efficiency in generating revenue. So what it essentially tells us is that there are two types of hotels, city hotel and resort hotel, which essentially means city hotel would be perhaps those hotels which are present inside the cities, and resort hotels are hotels which contains resorts. Now, both of this type of hotels has been seeing high cancellation rates, which is resulting in a decline of their revenue, and their rooms, the hotel rooms, are not being used as it should be. So maybe the hotel rooms are vacant. And you have been hired as a business analyst to analyze this particular situation, and your task here would be to lower the cancellation rates. How would you do that? We need to find out ways based on the data, what the data tells us, and find out ways to increase the efficiency of generating revenue by lowering the cancellation rates or increasing the revenue in any other additional ways if possible. So that is what our report should contain. So there has been some assumptions given. Unusual occurrences between 2015 to 2017 will not attempt our findings substantially. It essentially means that if there is any outlier, that should not affect the data much and therefore can be removed. All right. So let's head on to the Jupyter notebook and let's analyze the data. So this is what it is. Now what we will be doing is we'll be exploring and cleaning the data. So the first step for that is we have imported all the necessary libraries that we have been using so far, and we are seeing the output. Reading the data. On reading the data, we see that this is kind of what the data looks like. All right. Let's quickly understand what is the structure of the data. There are total 32 columns. Let's see that as well. Okay, so it would be df. I've named the data as df. So it tells us that there are more than 1 lakh rows. That is more than 1 lakh resort and city hotels, right? And there are 32 columns altogether. Let's also quickly check how many different types of hotels are there. So df of hotels unique. Okay, so there are basically 2 types of hotels, resort hotel and city hotel, right? Now what we would want to do is we would want to find out basic info about all the columns present. So let's do that. Okay, on using df.info, what we find over here is, so as we see, there are total 119390. So these columns do not have any null values as so. All right. There is certain null values over here, over here, over here. Okay, so there are null values present in this particular data set. One important thing to note is that reservation status date, which ideally is a datetime column, has been marked as object. So we necessarily need to change it to a datetime column so that we can perform further analysis. So what are the remarks? This is something we would be doing while moving forward. We will be making our own remarks so that we can actually incorporate them in the report. So there are some columns with null values, correct? And columns reservation status date, okay, this particular column is in the form of object but needs to be in the form of date time. So now our task would be converting the data type of this column to date time. How do we do that? We use pd.toDateTime. And on doing that, what we have got is this column has changed to date time. Okay. Now we also need to change or fill up the null values. There are several ways to do that. Let's see how many null values are actually there. So we see that the column company has more than 1 lakh null values. And as such, it's really difficult for us to fill those gaps. Also, agents have 16,000 null values. What we can do about this is we can maybe drop them out, right? These 2 columns can be dropped as such. The column country has comparatively less amount of null values. So these are only the 3 columns that have null values. We can maybe fill this up or remove the rows that have null values. That would be the best thing to do over here. Because as such, country cannot be imputed or done something or the other. So what we choose to do is we choose to remove all the null values present in the column country, and the rest 2 columns we remove directly. So the same remarks has been given by us. Columns, company and agent has too many null values to handle, and these are not that important with respect to the business case. Therefore, we can drop them. For columns like children and meal, okay, So for columns like children, even children has some null values. I totally overlooked it. So for columns like children and it should not be meal, rather it should be country, right? So for columns like children and country, we can drop the null values. Makes sense? So how do we do that? We first drop these two columns in place equals to true, and the null values, we also drop them. So for children and country, we drop the null values or any null values that is present altogether. And then we perform the sum of sum to get any null values if present. So when we do that, we get 0 null value altogether. All right. Now what we need to do is we need to find the unique values of object type columns that are present. So what are the object type columns? When we use df.describe include equals to object, we get all the columns that has object. And here we see we have, these are the columns that has object. Now let us find all the unique values that are present in the object, right? How do we do that? Maybe we can loop through this particular table throughout this column, and inside this column we'll get all the unique values. How do we get the unique values? By .unique method. So what I've done is for call in def.describe, this one include equals to object. So it would take a loop inside this particular table, print columns, that is print all the columns, followed by, I've given a blank space, followed by print df of call, that is the unique that is the unique values of all the columns. And to generalize, to give a demarcation of end, I have also printed this. So let's see if I did not use this, what is the difference that would have happened. So this is what you would have got. It's rather difficult to understand, and that is the reason I have chosen to demarcate the end of each column. So it looks a lot neat right now. And for this one, I have to give this gap over here. I have used a blank print statement. So now what we see is there are two types of hotels, resort and city hotel. The arrival date month are this, one of this. The meals are either of this, country are from this, so on and so forth. All right. Now let us take a descriptive analytics to understand how the data, what story does the data want to tell us. So let's do that. Now we see that here we see that columns like adults, children, babies, they show huge difference between the 75 percentile and max value. So while for adults, 75 percentile of all the adults that visits the hotels are two adults at a time, while there could be 55 adults as well. So this is an outlier, right? Similarly for children, there is absolutely 0 children visiting, but at times there might be 10 children, which makes no sense. Similarly for babies, similarly for many columns. But the columns that are important to us are adults, children, babies, and most importantly, ADR. What is ADR? Average daily rate. Okay. So average daily rate, here it says the mean is 95. The 75 percentile is 126, while the highest is 5,400, which makes not a lot of sense. So we might want to exclude the outliers. So let's see how do we remove the outliers. Let's do a box plot out of the same. So when we do a box plot, we are shown the outliers. So we see for adults, while the majority of adults are below 10, there are outliers going up to 55. What we can do is we remove all the adults when they are more than 10. That is exactly what we have done. And let me plot a box plot again. Now we see that it is more or less pronounced. We do not have so many outliers as such. We do have, but that is very less and very close to each other. For children, the same when we perform a box plot, we see this is the kind of outlier that we get. So we see the maximum number of children falls under 4, and that is the reason that I have taken 4 to be the endpoint. Now let's plot the box plot again, and we see that everyone lies with a 4, and it's a good representation. Now for babies, what we see here is, we see maximum of them again lies between 4, and therefore we have taken 4 to be the cutoff. Now the box plot makes a lot of sense. Similarly, for ADR, we see the maximum number of value for ADR is below 1000. But here it goes above 5000. So what I've taken is, I've taken it to be, the cutoff to be 4000. I could have taken 1000 as well. So let's see what it shows me. Yeah, even if I have taken 4000, it is quite below 1000. It's just crossing 500%. Now let us do the describe again to see if any big time outlier is present. When we do that, we see adults, no, the outlier is okayish. For babies, children, okay. And mainly for ADR, from 5400 it has reduced to 510, which is okay. So this marks the end of our cleaning of data. Do remember, this is an example data set that I have taken. In real world, cleaning is really a difficult task, and I have shown this time and again in other modules, especially the module where I took up cleaning as a part, right? So this is just for you guys to understand how we move forward with a case, okay? Even the analysis is not very detailed. You would want to do some further analysis and create a better report than what I have created. So that would make a lot of sense and enhance your learning process as well. So now what I have done is, I've taken the reservation status. So what I've done, I'm creating a count for how many people has reserved, cancelled, and how many people has not cancelled. All right. So this is essentially a bar plot, and it shows me that not cancelled is around 7000, while cancelled is around just north of 4000. If we want to change it to percentage, what do? We use the normalize method. So instead of value counts only, so let's see what happens is, this is an important thing that we need to know. So if we wanted the values to be printed only, all right, it gives me the values that are shown in the graph. But the values alone do not make much sense. So what we do is, we use the percentage. So normalize, what it does is, it lowers the value to 1. Okay. And if you want a percentage, we multiply it with 100. Now what it shows is, about 62%, or rather 63% of people had not cancelled, while 37% of people had cancelled, which is a huge number. Although less than not cancelled, but 37% of cancellation is really a huge number. And that's what the remarks has been made. Now let's go forward and understand what kind of cancellation was done. So reservation status in different hotels. What kind of cancellations has been done in different hotels? Mainly the city hotel and the resort hotel. So on performing the same, we get a bar graph which shows that resort hotels had less number of people reservations, right? Resort hotel already had a less number of reservations, while city hotel had more number of reservations. Therefore, the cancellation rates of resort hotels in absolute terms is less than city hotels. But if we see the gap in between, right? The gap is higher for resort hotels while it's less for city hotels. Now, why can this be the case? We see that cancellation rates is higher in resort hotels compared to that of city hotels. So let's see the numbers. So when we do a percentage of cancellation, we see for resort hotel, non-cancellation is 72%, while cancellation is 27%. While for city hotels, the non-cancellation is 58% and cancellation is 41%. All right. Now let me do one more thing. What I want to do is, okay, so what I want to do is, I just want to take an analysis of the percentage of cancellation with respect to not cancelled. So when I'm giving the value counts, I'm getting cancelled versus non-cancelled, right? So what I can also do is, let's say I take another variable called as cancelled. Okay, and another, this would be 0, and another variable as not cancelled. All right. So this would be essentially the first one. So 1. Now the ratio, let it be, okay, ratio, fine, equals to not cancelled divided by cancelled, right? And I also need to print the ratio, which gives me a 38%. If I perform the same with the city hotels, what do you think the ratio would be? So what if I want to perform the same with city hotels? Just copy it and paste it over here, and I get the value to, okay, one second. Because I have taken resort hotel. So what I need to do is, I need to take city hotel for that matter. So instead of resort hotel, I take city hotel. And I also need to take this line. Correct? I also need to take this line. And instead of resort hotel, I need to take city hotel. Okay. Now let me get the ratio. So the ratio here is huge. It's 0.71, that is 71%. 71% has not cancelled, right? Maybe I have taken the wrong ratio. Let me take the ratio to be cancelled upon not cancelled. That would make a lot more sense, right? That would make a lot more sense. So what I would want to do over here is cancelled by not cancelled. The ratio is 2.57. And here, cancelled by not cancelled, it is 1.39, which shows me that the ratio of cancelling to not cancelling in city hotels is primarily less than resort hotels. So many people, more than people who cancels on city hotels are people who cancels on resort hotels. So the problem lies with resort hotels more. Why can this be the case? Maybe what I'm thinking, although I cannot be certain about it, but maybe what I'm thinking is it's due to the money, maybe the ADR, the average daily rate. Since resort hotels are a lot of comes with a lot of premium, a lot more prices, people might feel, overwhelmed with a lot of price, and therefore they would want to cancel it. So let's see what the data tells us. So now figuring out reasons for cancellation. So ADR, that is average daily rate. So when we plot the ADR for both the hotels in a line graph, we see that, so I've also taken the legend. So the resort hotel is with blue and the city hotel is that with the orange. And on plotting, we see that in general, resort hotel costs way more than city hotels. Throughout, you can see the city hotel costs way more than, the resort hotel costs way more than the city hotels, right? So the remarks is, price of resort hotels are usually higher to city hotels. Also, one important thing, what do you think these spikes can be? Why it's not a straight line? Why are there spikes? Maybe because the prices change, prices are not uniform. Maybe during holidays or weekends when people actually visit places, the prices soar up, and therefore the spikes are there. All right. Now let us also check reservation status per month. How does the reservation status work? So when we plot it, we see number of reservations per month. We see that for month 1, so the orange one is the cancelled and blue one is the not cancelled. So we see for month 1, cancelled is way more than not cancelled. So people in month 1, that is January, prefers to cancel. Why? Again, maybe the price in January increases because there is a lot of rush. People wants to celebrate their New Year's and everything, and therefore the prices increase. And as a result of which, many people cannot afford that and prefers to cancel their trips. See here, the ratio of non-cancelled to cancelled is with not cancelled being more, is highest in the month of 8, which is January, February, 8th, August. Month of August, not cancelled is way more than cancelled. So the remarks here is month 1, that is January, has the highest cancellation rates and lowest non-cancellation rates, while month 8, that is August, has the highest non-cancellation rates and lowest cancellation rates. All right. Now let us check the ADR. Since I said it might be due to the prices, whether I was right or wrong can be statistically verified by the ADR. So when we create an bar graph of the ADR based on month, we see, I just used the group by month, right? We see the prices of January is indeed the highest. And the prices of, the prices of 9th, that is September. Month of September is the lowest, not 8th. So yeah, there's a very less difference. But again, the not cancelled in August is way more. So what typically we can understand is, although the prices is lower in the month of September, people still prefers to go in the month of August, maybe because the places are more beautiful, or maybe August is a month when you get your holidays or something like that. But essentially, we do understand that the prices in the months of 8 and 9 is very low. So month 1, that is January, has the highest ADR, while month 8 has a very low ADR, correct? Therefore, we can conclude that price plays an important factor in determining cancellation rates, correct? With price rising up, people tend to cancel their reservations. That's what we inferred, right? Now, let us also see the cancellation rates with respect to different countries. So there are around 170 countries, right? That's what we saw in the descriptive analytics. not this one. Okay, let us quickly create df.describe. Okay. So let us quickly create how many countries are there. So df.head, let me know the column for countries. Okay, df.describe, let me do it this way. Include equals to object. I will get the name for the country. So country is the name. Okay, we also get how many unique countries are there. There are 177 unique countries, right? And it is not feasible to name all the 177 countries. What we can do instead is we can take a pie chart for the top 10 countries. And that's exactly what I have done. So top 10 countries with maximum cancellations. A pie chart for that has been drawn. And we get PRT, that is Portugal, with the maximum cancellation rates, around 70%. Followed by Great Britain, Espanol, that is Spain, France, Italy, so on and so forth. So most cancellations can be seen in Portugal. All right. Now let us also understand the market segments where customers are coming from. What do I essentially mean by that? There are different market segments or vendors like online travel agents, offline travel agents, directly coming, or groups, corporate and everything. So let us see where are the most people coming from. On doing the analysis, we find that the maximum people are coming from online, followed by offline, then groups, then direct, so on and so forth. And if we take a percentage of it, we see that 47% are from online, while 20% are from offline. Groups contribute 16%, direct 10%, and corporate 4%. Now, that is not done. We also need to know not only from where the people are coming, but people who cancel their booking are coming from where. And that when we want to do, we get, again, online is the one that is contributing the most, around 47% only, 46.98. Followed by groups, then followed by offline, and then direct. Which perhaps leads me to think that perhaps when people are booking online, there might be wrong information given, or maybe more beautiful pictures and everything has been given, which are not true. Or online bookings are a lot easier, so people tend to book their rooms or hotels, not thinking about they might want to cancel. But for offline or for other modes, direct, for offline, they would have to go to the travel agent. So there is a cost entailing the transportation cost while going to their transport agents, maybe pay something upfront. And so people who are really sure of going books through offline, and therefore they do not cancel that much, even for groups. And direct is perhaps very less, and the reason being, when you're going to somewhere, you might not want to cancel on your booking because you are there, you need a hotel. If the hotel is really very bad, only then would you want to cancel it out. All right. Now we check on the ADR, if the ADR is high for cancel bookings or non-cancel bookings. So that would also let us know if price is the foremost thing for cancellation. And we see that for non-cancelled, so this is the ADR column. I mean, the y-axis is for the ADR. As high the graph goes, the high the prices are. And we see that for cancelled, the orange part has more ADR. Therefore, price does play an important role for cancellation. And that is what remarks are made. ADR is high for cancel bookings compared to non-cancel bookings. So this proves that the prices are the most important marker for the cancellation. Now, how would we actually go forward and make a report out of that? So I've also went forth and made a presentation, a PPT presentation using these graphs. Let us see what I have done. So this is how the client expects them to be, because they do not understand this coding and everything. They want a formal presentation wherein you focus on the analysis based on the graphs. So this is what I have done, analysis of hotel booking. I've given the graphs saying reservation status percentage, 62.8% of reservations have not cancelled their bookings, while 37.2% has cancelled, and I've shown the graph simultaneously. In comparison to resort hotels, city hotels have more bookings. It is possible that resort hotels are more expensive. ADR in city and resort hotels. So price of resort hotels are usually higher than city hotels. The graph shows that. The spikes are perhaps due to the rise of price during weekends or holidays as well. Reservation status per month. So month 1, that is January, shows highest cancellation rates and lowest non-cancellation rates. Month 8, that is August, has highest non-cancellation rates and lowest cancellation rates. So lowest cancellation rates might be an exaggeration of the term, but yes, it has very less cancellation rates. Now what I've done is an average daily rate per month. So this shows that cancellations are most common when prices are highest and least common when prices are lowest. Therefore, we can infer that cost of accommodation is highly dependent on cancellation. Now we have also printed the 10 countries with the highest reservations, cancelled reservations. This shows Portugal is standing in the front row, followed by Great Britain, Spain, France, etc. in quick successions. So that is also true. These are in quick successions, while Portugal is way by far has the highest cancelled reservations. Now, we have also done some market segments analysis, that where the customers of cancelled bookings are coming from. So it is seen that most of the guests who cancel their bookings are coming from online travel agents, followed by groups, offline travel agents, direct, etc. In terms of quants, around 47% guests come from online travel agents, 27% comes from groups, while only 4% comes directly. These might be due to the false advertisement shown by online travel agents. Now, ADR versus cancellations. This graph shows that reservations are cancelled when ADR is higher. Therefore, higher prices leads to higher cancellations. Guys, up to now, what I have done is I have taken all the graphs that I have created, pasted them in PPT, and written my observations. The final slide shows the suggestions that I would want to make to our client. So the suggestions that I make are: cancellation rates rise with increase in price. In order to prevent cancellations of reservations, hotels could work on their pricing strategies and lower the rates based on locations. Some discounts can also be provided to customers. Since ratio of cancellation to non-cancellation is higher in resort hotels compared to city hotels, the former should provide reasonable discounts, especially on weekends or holidays when spike in charges are seen. In January, hotels can start campaigns on marketing as the cancellation is highest in this month. They can also increase the quality of their hotels and services, mainly in Portugal, to reduce cancellation rates, because Portugal was by far having the highest cancelled reservations. So yeah, that's all about the PPT. That's how we present a formal report. We first get the business case. We do some exploration of the data, brainstorming, understand the problem statement, do some brainstorming. We do some analysis. Before that, we do the cleaning of the data, then the analysis, visualizations, and finally, we create a report to present in front of our client. And that is exactly how our data science process, end to end, is carried out. We also have machine learning in place, but this is beyond the scope of this particular course. So this is all about being a business analyst, how being a business analyst looks like. So that's all for this course. Thank you guys. Hope you liked this course and learned substantially well from this. Hope to see you in further courses. Bye guys.